Hey everybody, this is Brian. Welcome to the first Flutter tutorial. You'll note at the time of this recording, Flutter is still in alpha and is an open source project. Now, version 2 is coming very soon, and I'm going to try to adhere to version 2 so that going forward this tutorial set remains relevant. So first off, what is Flutter? Well, it is a mobile app SDK that helps you build pretty beautiful applications very quickly. There is an actual really nice fact in here that you should read and get accustomed to is, what is it? Who uses it? What's it for? Answer some general questions right now. It's really designed to make mobile programming not suck. If you've ever tried making a mobile program cross-platform, you've had just a major headache. Who's it for? Developers of all walks of life, but mainly people targeting mobile development. Flutter is built upon a language called Dart, which is a new language, which I believe, somebody correct me if I'm wrong, was actually developed by Google, or at least had a lot of Google backing. Google depends on Dart to make very large apps. You can see that there. So this has a few distinctions from other mobile frameworks. Um, you can build cross-platform, and this Hacker Noon article, I'm not going to steal all their thunder, but what's really differently is you have, OEM SDKs where you have native code that runs on a specific platform. For example, an Android app will not run on iOS, iOS will not run on Android. You have web views, which are kind of like I want to say a hybrid, where you have like Cordova, Ionic, et cetera, where you have a JavaScript application that communicates with a bridge, which actually communicates with the hardware. Then you have what are called reactive views, where you have JavaScript, which communicates with a bridge, same thing, talks to the hardware. What's different about Flutter is the Flutter SDK is really the only SDK out there that doesn't really use a JavaScript bridge. And it's actually very quick, very easy. I want to say very expressive, and I want to say easy to learn. We're going to find out. I'm currently building my own Flutter project, so I thought it would be nice to do these tutorials as I go. As you can see, it's built a little different. You have your native code, which widgets are rendered, and you have platform channels, which communicate with the hardware. There's no JavaScript layer here. Um, we will have to learn Dart programming, so the first few set of tutorials out of this whole series will be nothing but Dart code. Um, if you are a veteran programmer, Dart is very quick and easy to learn. If you are a new programmer and this is your first language, don't worry. I'm going to step you through this, but we will move at a pretty quick pace. So if you need help, definitely go out to my website, go in contact, and be sure to join the Voidrum's Facebook group. There's 1,700 programmers out there who can help you. And I should note that the source code for this and all tutorials will be out on GitHub. There's a link to my GitHub repository out on voidrums.com. All right, so first thing we need to do with Flutter is actually install it. So we're going to select our operating system. I'm on Linux. I have Mac OS and Windows, and I gotta say they're all just dead simple to install. The first thing we'll need to do is actually make sure we have the system requirements. Do I have X number of space? Am I running this platform? Do these commands actually work? Yes, they do on my case. So without further ado, we're going to get this. Make sure I don't already have it installed. I do not. But you can see I already have Android Studio installed. I'll be developing on Linux. However, you can develop on any platform you'd like. Just know that I will be targeting the Android projects. All of the programs that we write should also run on iOS, and I may actually do some iOS programs simply because I have a Mac and I like playing on it. But to start off with, you should already have Android Studio installed, and you should have the IntelliJ Community Edition IDE. Now, when you go to IntelliJ, or I'm sorry, JetBrains.com, and you go to download IntelliJ, there's a couple different versions. Ultimate Community. You want Community because it's free. I'm not deterring you from buying it. You can go ahead and spend money, but I will be using the free version. That way people all over the globe without any money can follow these tutorials. All right. So back to what we were doing here. First thing we need to do is actually grab the code. So we're going to just copy that, paste it in there. And if you have no idea what this is doing, we're using a program called Git, which will clone the source code or the repository from GitHub, and that's the actual link to where we're going. You can actually follow that link and go out and browse all the source code for Flutter, but right now we're just going to install it. And this will take just a moment to download. Once this is done, you're going to want to actually set your path, and it walks you through here step by step. Now, notice this command is only a temporary workaround. You're going to want to follow the directions for your operating system to make it permanent. See, what happens is if you just do this and nothing else, when you log off and log back in, it suddenly doesn't work. To test this, we're going to do Flutter Doctor. Not Fluster, Flutter Doctor. I have got this wicked cold, and it is just messing with me. These cold meds are just making me really loopy. All right, so you notice the first thing Flutter Doctor is doing is downloading the Dart SDK. So if you're working with Dart, know that Dart is a language in itself, and while this is downloading, I'll just discuss Dart a little bit. Dart is a full-blown language. It's not just for Flutter. You can actually use Dart to create web programs, mobile, and a Dart VM or console server applications. My hope is that someday they will actually put like I want to say like a desktop GUI over this, sort of like C++'s Qt, where you have, buttons and list views and things like that for desktop applications. I think that would just be amazing. So let's check on this. As you can see, it's downloading the SDK, it's building the Flutter tools, and downloading all the other little things that it needs to run. And at the very end, you get this scorecard. Now, if you don't have checkboxes next to everything, you're going to want to investigate what's wrong. And most of the time, it'll tell you flat out what you need to do. That's what I love about Flutter Doctor. So if Flutter ever acts a little screwy and you think it's not working right, just run Flutter Doctor and see what it has to say. Generally, you're going to get an output like this. Flutter on whatever operating system. You have the Android toolchain. On iOS, you'll see both the iOS with Xcode and Android. You have Android Studio with a specific version. Now, when I say specific, it should be newer than a certain version. And it tells you the Java OpenJDK runtime and the IDE. Now, notice how it says Flutter plugin, Dart plugin. You probably will not have those. And what we'll need to do is go into IntelliJ. And go into settings, and you may not have this window, especially if you just installed it. Close that. I'm just going to say new project. That's not what I wanted, actually. Let's go settings. I was trying to bring this up. If you have just the generic, you've never opened this before, you may see a different window. So get into settings however you can. Go to plugins, and if you don't already have Dart and Flutter in there, click on Browse Repositories, and you'll want to type in Flutter. Mine, there's no button, but you'll have a button here that says either install or update if you already have Flutter there. So to go ahead and install it, you'll probably have to restart the IDE. And you'll know that it's fully working when you see it in here, and when you can say File, New Project, and there is a Flutter and or a Dart icon here. So to begin our applications, I will actually be working with Dart. Notice how the Dart SDK is actually inside of Flutter. So go ahead and set up the Dart plugin for your IDE, and don't worry about this Dartium. Honestly, I'm not really sure what Dartium is. I think it's like kind of a help binding. But we're just going to be working with the raw SDK at first to learn the Dart language, and we'll be using console applications. Then, when we get into more complex apps, we'll actually be switching over to Flutter. So, what we have here is just a generic hello world kind of thing. As you can see, there's a lot of folders. You have an IDEA folder, you have Android folder, an iOS folder, a lib with main.dart. Main.dart is actually the index or entrance file. Basically, you need the main function inside of main.dart to run your application. And we're going to go over all this stuff in future tutorials. So if this looks really crazy, don't worry about it. We're going to cover it. So to recap, you're going to want to download and install Flutter. You're going to want to get a little familiar with the Dart language page. We're going to actually be going over the language tour. Maybe if I can find it, cold medicine. We're going to go over this pretty in depth. We're not going to spend 3 weeks talking about what is a variable. We're going to step through it fairly quickly, but there's a lot of information to learn. And I think it's going to be fun. Whoops, I was dragging and dropping something there. All right. Questions, comments, concerns, please be sure to join the Voidrums Facebook group and leave me a note out there, and I'll talk to you guys later. Hey everybody, this is Brian. Welcome to the second Flutter tutorial. I know it says Dart here, but before we really dive into Flutter, if you remember from our previous video, we actually have to learn the Dart language first. Don't worry, it's pretty painless. So we're going to just click on language. We're going to go to tour, and this is what I'll really be working from, although I won't be following it verbatim, but I want to definitely point you to where you can find additional information here. So, tour of the Dart language. They walk you through what is a basic program, and we're just going to actually open IntelliJ, create a new project. We're going to make a new Dart console application, and let's call this VarTest. Whoops. Just because I'm horrible at naming projects. And this will take just a second to load. I actually don't know why this is so slow. I have just an ungodly amount of RAM and 2 solid state drives. This is actually my PC I use for video gaming, so I'm not sure why this takes a while. But while that's sitting there churning in the background, what we're going to really cover in this tutorial is what is a variable, what is a constant, what is a final. There's a distinction there, and it's a little tricky. And then some of the built-in types. You can actually click on that built-in types and you'll see there's numbers, strings, booleans, lists, maps, runes, and symbols. Not going to really cover these last two, but you can definitely look them up in the official Dart documentation. All right, so now that we have got our brand new shiny program, let's just run this and make sure everything builds correctly. If you followed along and you've got the same setup as I do, you'll see Hello World 42. That's actually kind of funny. It's funny because of a book by Douglas Adams called Hitchhiker's Guide to the Galaxy, where the ultimate answer to everything was 42. So we're going to remove that import statement and remove the print statement. Just save and run it again, and you should have absolutely nothing there. That'll be a good starting point for us. Now, structure of a Dart program. You can see how the main.dart file is in the bin, and this is our main statement or our main function. This is the entry point to the application. So we're just going to say print hello world. What we're doing here is we're calling a function. You've probably seen this in other videos, and if we just save and run, you'll see, sure enough, it says hello world. But what's really going on here under the hood? We have a function, which we're going to cover in a future tutorial, that works with something called a variable, which is right here. Hello world is actually a string variable. So what is a variable? A variable is simply something that will change over time. So variable is actually a scientific term, something that will change over time. So we're just going to say var something. Whoops, if I could spell, hello world. So what's really going on under the hood is Dart is creating a new variable with that information in it. So this and this are exactly the same thing. You can save, run, and it does literally the same thing. To kind of drive that point home, you can actually press dot after hello world, and you see it brings up all of the other functions in the string class, which if all of that sounds like voodoo nonsense, don't worry, we're going to cover all this in future tutorials, but you just need to understand that a variable is something that will change. To drive that point home, you can say, oops, hope if I spelled something right. Cats rule. Now, if you're a dog lover, you can put dogs rule. I won't come find you. But point is, we've changed this. We've made changes to it. Now, on the flip side of that, a constant is a scientific term that means it is constant. It will never change. So we'll say const. What do we want to put here? We'll just say nope equal 1. So if we try to take our nope variable here, and I should say nope constant, and make this a 2, notice how there's got that little red underline and it starts complaining, and if we even try to run it, it's going to crash, and it's going to say cannot assign to final variable nope. Now what's going on here? We call this a const, but it says final variable. So there's a little bit of information you need to know. And I found this really great article. I'm just going to put this right in the code. But the difference between final and const is it's tricky to understand, and you won't really get it until you really get into the language. But I wanted, right up front to tell you there is a difference. If you're writing your code and you're following along, say, in another book, and you say final noper 1, noper equal 2, essentially you're doing the same thing, quote unquote. You have something that you cannot change, and it's going to complain every time, and if you try to run it, let's comment that out, you'll see that, yes, it still crashes. Cannot assign to final variable noper. Okay. Let's comment that out. By the way, if you don't know what a comment is just something that the computer completely ignores. It's there for your enjoyment, if you will. A lot of times programmers will comment code as they go so you can understand it, not just from a machine perspective, but from a very readable human perspective. So anyways, back to this. Variable is something that will change. Constant and final cannot be changed. So what's the difference between constant and final? This article sums it up the best. Ignore static for now, but final means a single assignment. A final variable or field must have an initializer. What does that mean? Basically, it means that you have to give it a value. So for example, if we just comment that out, you can see how, it must be initialized. You must actually give it an initial value. Well, let's try the same thing with nope here. Notice how nope is also complaining must be initialized. So you understand what an initializer is, and because it's a constant or a final, it has to have a value starting up. Once assigned a value, a final variable's value cannot be changed. Final modifies variables. Basically, it takes the variable and sets it in stone and says this will never change. For example, a constant would be the sun. Unless it explodes, it is a constant. It will never change. Or I should say it's a final. It'll never change. A constant, however, has meaning that's a bit more complex and subtle in Dart. Const modifies values. Notice the distinction here, values. Final modifies the variable where const modifies the value. When you look at these two real quick here, this is the variable, this is the value. So let's go back here. A final modifies the variable. So final modifies this, the variable, where const modifies the value. So you can pass that constant around to other constants. It will always remain a constant, but you can pass it around with a different variable name, whereas a final is final. That is the only time that can ever exist in that. So if we try to do a const noper, see how we're getting an argument. Noper is already defined. You're going to get that anyways, but that's really the distinction, and it gets really deep, and like I said, you're not going to truly understand it until you get really good with Dart, and you end up in those cases where you need to understand the difference between the two. But I'm going to take this article and throw it in here just so we kind of have that as a reference. Whoa, what is this? Cancel. All right, so which one should you use? I use const just because it suits my needs. And until I get into complex applications, I won't really need to know the difference. Now, if that's not confusing enough, there is that other one called static, which we'll get into in future tutorials, which really deals with classes, and that's why we're going to cover it in future tutorials. So onward. Now that your brain is completely numb, just understand there is a variable is something will change, and a constant or a final will not change. Changeable versus not changeable. In this tutorial, we're going to be working with things that change, or variables. There's different variable types. Notice how in the front I put var, or const, or final. That's the type. Well, there's a lot more types here, so we're going to get into numbers. And they are, well, numbers. Yeah, exactly what you think they are. So we'll say num, and we'll say age equal 12. Why not? Now, if we type AGE and hit the period, you see that we go into that class's scope and we get a whole lot of functions. This is a lot of built-in functionality. In Dart, everything is an object, much like in Java or other languages. So because everything's an object, you can actually go in and get reusable code, something somebody else has already written. Like we can round, we can double, we can convert it, floor, ceiling, ABS, toString, is it not a number, etc., etc. Now notice here on the right, you see some words like int, double, string. What are these? Well, that's the return type. So that function is going to return a double, where this function will return an integer. So you know automatically what you're going to get. So as you would expect, because this is a variable, well, let's add 20 years to this. Let's add 30 years to this. Why not? We're going to just print the age out here. So you can see how now it is 42. And I'm kind of doing this on the fly here. So you see how it says age is 42. If you put the $sign inside, you can actually reference a variable outside. If that makes no sense, let me repeat it. What we've done here is we've created a string variable, but inside that string variable, we're referencing an external variable called age. See how that works? Otherwise, what you would need to do is actually go, whoops, plus age. Now, notice how the argument type num cannot be assigned to the parameters type string, because this right here is actually a string. If you hit the period or the scope operator, you will see that you have options or functions from that class that you can choose from. So we actually got two variables we're working with here, this variable and this variable. So it's kind of a matter of preference. Some people like doing this, some people like doing that. Do what's comfortable to you is really what you should do. And just in case you were curious, if you're going to do it like this, you just say age.toString, and it converts it to a string for you automatically. So you can actually, let's do like this. And we'll run it just so you can see age is 42. I'm going to put it back the other way, just for the purpose of this tutorial though. So I actually got a little ahead of myself here. So a boolean, we're going to actually jump backwards in time here, and we're going to say bool is working equal false. A boolean is like a light switch. It's either on or off, true or false. And we're going to say is working equal true. Booleans are very helpful for certain things, like for example, let's go back to our age example here. If we want to say is infinite, is age infinite, it's going to return a boolean value, and it's going to tell us whether or not that number is infinite or negative or finite. All right, let me check. Oops, somebody messaged me. That's the problem with doing videos real time. I don't edit my videos, so you'll see and hear a lot of craziness going on here. One thing we should really be aware of is that there is more than one type of number. For example, an int would be, let's say, cats, the number of cats I have. I actually don't have any cats right now, so I'm lying a little bit. And then there's a double. And let's say pi equal 3.14. So what's the difference between an int and a cat? These are big, 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 big numbers. You can actually go out to the Dart documentation, and you'll see integer values generally be between -2 to the 53rd power to 2 to the 53rd power. That is a huge number. Where a double is a 64-bit double precision floating point numbers as specified by the IEEE 754 standard. Whew, that's a mouthful. Basically, what you need to understand is almost all numbers that you create are going to be converted either into an integer or a double, depending on what they are. But both integer and double actually inherit from the number class. What does that mean exactly? Well, what it means is that if you say age dot, you'll see all these things like round to double to int to floor, blah, 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 blah. What inheritance does is if we say cat dot, you'll see that it's inheriting all of those, plus it adds a few little extra. So an inheritance is, think of, back to scientific terminology, you inherit your genes from your mother and your father. Everybody does, unless you were born in a laboratory. But anyways, we won't get into that. So you have parts of both your mother and your father. So, for example, an integer has parts of num. A double has parts of num. Pretty simple. We'll cover that more when we get into our classes tutorial, but just understand that there's essentially two different types of numbers. There's integers and doubles, and you can use the generic num if you don't know what type of number it actually is. See, it won't break anything if we do that, but if we try doing that with an integer, it gets a little angry at you. It says it has to be a double. All right, now we get into the really fun stuff, strings. I don't know if you guys can hear that. I'm in Michigan, and it's just starting to get cold and snow, and my neighbor is now just trying to get their leaves up, and I can hear them like yelling at each other. It's kind of funny. So we'll say string title equal hello world. So what is a string? A string is a sequence of characters. What is a character? A character would be these individual letters. Now, you should note that I think there's 200, we're on the internet, so somebody will correct me if I'm wrong, 255 different characters. Not all of them are actually human readable. For example, the space is a character, a tab's a character, zero, not the number zero, but just nothing is a character, things like that. So a string is a sequence of characters. Now, if you want to work with Unicode, spoiler alert, you'll need to work with something called a rune, which we're not going to cover specifically in this tutorial. We may cover it in future tutorials if there's like a huge public outcry for it. All right, so you get now that it's a sequence of characters. What can you really do with this? I mean, what does a string really let you do? Strings let you do a whole lot of really, really cool stuff. For example, you can say title equal, whoops, my kittens. Just why not? I had no idea where I was going with that. And we're just going to say print title. So you can actually build strings. There is a class out there you should use called a string builder if you're going to actually start building strings. It's much more efficient than working with a string directly. But for this tutorial, we're going to just cover strings. All right, so back to this. What do we want to do? Let's say we want to play around with this thing. And let's actually... So we're just going to have this say hello world right here. Let's say we want to know some values out of this thing. Let's say we want we want to extract part of that string, substring. So we want the start index. Let's say we're going to start at 0, and we want the first 4 out of this thing. Let's run this, and you'll see that, ta-da, nothing happens. Because we're not actually changing this variable. We're actually calling a function that's returning a variable. So let's grab this. And you'll see the first 4 is, whoa, that's kind of dark. I didn't mean to do that. The first 4 is hell. Sorry, ladies and gentlemen. But what we're doing here is we're grabbing a substring, or the first 4 characters. Now, you can see how the 4 characters are outlined there. What is this 0? Well, under the surface, this is really a list of characters. We're going to cover lists here in a few minutes. But lists are 0-based indexes, meaning it starts with a 0 instead of a 1. So this position right here before that H is 0. 0, 1, 2, 3, 4. that's how you get those 4 characters. So substring starts with 0, and then we tell it how many characters we want, or you could start at a different one. So for example, let's say we start at 1, and now we're going to get some gibberish eel with a space. That's not a good example. Let's do 2. That's really not a good example either. Let's grab 5 characters. Why not? Hello. So you can see. Oh, you know what? We should cover other things as well. Let's put this back the way it was, just so I can really freak people out when they download this code. And let's say we want to. I'm really doing this video on the fly here, so bear with me here. We want to replace all. So we're going to say title equal title dot replace all. And we want to get rid of the L's, the uppercase L's, anyways. And replace those with Z's. As you can see, we've got these 2 Z's in there now. Pretty neat. Now, one thing you can really do with a string that's kind of interesting is you can play around with it. So we're going to say string book my world's issues in a day. What have we done here? You notice how instead of using single quotes, we're using double quotes. You can use those interchangeably. It doesn't really matter. And you would use those for specific instances like this, where you want to put a single quote in there. This could also be written as, let's say, string book 2. Notice how it's got that slash in front of the single quote. That's called an escape sequence. You would use that for specific things. Like, for example, this is a single quote. So anything after the escape is the sequence we're going to inject into this string. For example, let's say we want to do a /n, which is a new line terminator. So let's print these 2 out. We're going to print book, and then we're going to print out book 2. Just so you can see the difference here of what we've done. And you can see how my world's issues in a day and then my world's issues hard return, or actually new line in a day. Now on some platforms, like Windows, I think it's RN instead of just N. So it gets into some platform specific stuff there, but you can see that really it doesn't matter whether you use single or double quotes, and it's kind of personal style and preference on which one you use. All right, so now let's get a little different here, and let's say string names equal just going to make some names there. And we're going to assert something. Now assert is a special function in Dart that will say this must return true. Whatever we put in here has to return true. So we'll say names dot dot contains, and we're looking for Heather. Probably help if I put that at the end there. Notice how each line has to end with a semicolon. That tells us that we are at the end of the line. Very funny, huh? So when we run this, nothing happens, but we've done this assertion. So let's say just random junk in here, and we try to run this now. Notice how it'll error out. Names contains whatever is not true. So that'd be a good way of testing your variables. Let me put this here. So we're going to talk about lists next. Lists are, well, a list of objects. So we're going to say list. And you notice how the IntelliSense pops up and it says there's this weird bracket with an E in there. What was that? Well, this is called generic programming, and what it allows us to do is reuse code. And we're going to get into this in future tutorials. Just right now, understand that we have to give it a value type, or I should say a variable type, sorry. In this case, string. So we're going to say list equal names.split. Split's going to take a pattern, and we're going to split that based on the comma. So what are we really doing here? If we examine names.split, you can see how it's returning a list with string. So a list is going to be a list of objects. In this case, we want a list of strings. We very could easily have said integers or doubles, or even, var if we don't know what type it is. Actually, I don't think it would allow us to do that. But in this case, we're just going to use a string. So think of a list like a, what's a good example here? Think of a list like a shopping cart. Shopping cart, you just throw anything you want in there, but we're saying a specific type of thing. So in our shopping cart, you can only put strings. We don't want to put integers or doubles or anything else. We only want strings in there because we're going string shopping, if there is such a thing. So from our list, we can then pull items back out. Or we can just examine the list. So let's say we want to know what's in our list. Save this and run it. In our list, we have Brian, Heather, Chris, Carl. Let's say we want to get the item at, or I'm sorry, the element at the second index. Because remember, a list, we talked about this, is 0 base. So the second one, 0, 1, 2, is Chris. Now, you can also shorthand this, as most people do, and say list bracket 2. That way you don't have to do the element at. It does the exact same thing under the hood. You see how we got Chris there twice now. Now, from here, let's say we want to add to our cart. We want to add a string here. So we're going to add Bob. Bob's been a good boy. He can go into our little shopping cart of strings. And let's print our list out again. And you can see we now have Bob at the very end. Now, let's say we want to add somebody, but we want to add them in the list, not at the very end. So we're going to actually say insert. Notice how it's wanting an index and a string element. So insert, we're going to insert this at the first position. And we're going to call this, I need a name. I need a good name. Back to our Hitchhiker's Guide to the Galaxy, let's just say we're going to add Ford. I should have added Slarty Bart Fast, but yeah. Let's actually do that. He's a character in the book. I love that book. It's funny. So then we're going to print our list out. And you'll see how in the first position, because it's a 0-based, 0, 1, we have now added or inserted Slarty Bart Fast. So what if we want to know where something is? Let's say we want to print. I can't type. Let's say we want to know the index of, let's say, Carl. Ooh. Why did that return a -1? Let me play around with this for a minute. Did I misspell something? There we go. So Bob's at the 5th index. Why did that say 0 or -1 for Carl? That's weird. Obviously, I have a boo-boo somewhere. That's interesting. I'll have to figure that one out. But basically, index of gives you the position of where they are. Let's actually play with this a little bit here. Figure this out. So we're going to say there's a little function in here called for each. And what for each will do is it will list out every single item in the list. And we're going to say for each give me just a second here. If this looks like voodoo magic, I will explain this in just a minute. Oh. Semicolon expect. Oh, derp. Derp, derp, derp. All right, that's what's going on here. So if you look at our list here, we've got Brian, Slarty Bartfast, space Heather, space Chris, space Carl, and Bob. That's the problem. That's what's going on here. Remember how we split it based off of this. So what we should try to do here. What is the name of that? Was it trim? No. Let's just do this easy way. I'll have to look it up, but I swear there was a function in there you could do that. Let's remove those, the spaces in there, right? What I was looking for here is names dot trim. Trim will remove the blank spaces. I was hoping to do that per item, but I think it's going to be more of an advanced topic. I've also got a cold, so I'm not going to really fight through the cold medicine to do it. So when we run this now, you'll see how there's no spaces in there. And if we go back to putting Carl in there, I think Carl was throwing an error, and so was Heather. You'll see now that it is at position 4. So back to this list for each. What in the world are we doing here? So we're taking our list, which is this thing here, and we're saying for each item in the list, and then we're doing a anonymous function, and we want a v, or a variable, and we're going to print that. I know this is a bit of an advanced topic for people that are brand new to the language, but those of you, really gridiron veterans who have worked with multiple languages are probably loving me for this right now. Just know that you can do these kind of things with Dart language. That was makes it so elegant and so nice. And it makes troubleshooting things a little bit easier too, as you can see. So, anyways, finally, maps. Maps are a little bit different. We're going to say map, and we want to give it, once again, we're doing generic programming here. We're going to say string and an int. And we're going to call this ages equal. And what a map is you have what's called a key value pair. So we're going to say Brian and 43. Man, am I 43? I'm getting old. I was just playing Call of Duty. That explains some things why I was just getting completely smoked on Call of Duty by some of these players. Literally, like, I shot a rocket at some guy and he just laughed at me and like stabbed me in the face with a shovel. So it was not fun. I actually thought about just uninstalling the game at that point. Fortunately for me, though, Carl also plays video games and he is older than me. So thank you, Carl, for being my friend. Anyways, so what we're doing here is we're actually building a map or a key value pair. Uh-oh, somebody's texting me. This looks important. You can wait just a minute. So the key value pair is going to align up. We have the key and we have the value. And in here is our actual map. Now, it's called a map because you actually have two lists under the hood. These names are a list, or the keys, and these values are a list called values. So let's just say print ages.keys. You'll see Heather, or I'm sorry, Brian, Heather, Carl. Brian, Heather, Carl. Those are the keys. Notice how it's a list. Now, let's say print. Whoa, did I hit caps lock? Sorry for yelling at you guys. Print ages dot values. So you can see how we have two distinct lists here. So what a map does is map those or correlate them. This one maps to that one. This one maps to that one. That's why it's called a map. All right, so how do we work with this? How do we really extrapolate data out of this thing? Well, let's say we want to get the value of one of these keys. So we're going to say print ages, and then we're going to say Brian. My throat's getting a little sore. I've had this nasty cold, and it's just really driving me nuts. So there's 43. So you can see how Brian maps to 43, and we've got the value of Brian using that key. We could also do something like this, and we could say ages.keys at element 0. So we want to get the first one. Whoops, maybe that isn't really working well. Isn't defined by... Really? I thought I could do that. Element at. Let's do it this way because I said so. And it does the same thing, basically. But now I really want to know why I couldn't do this. You think you could do this? Did I screw something up? It's probably because it's got these double blocks. Which leads me to my next point. It's just a fairly new language, so things will evolve over time. I expect something like that would actually function at some point. Alright, so how do we actually add in here? So we're going to say ages dot, whoops, actually, let's say ages, give me a name, Mark, equal Mark's in his 50s. So we'll say that. And then we can print ages Mark. Let's save and run this bad boy. And you can see there's Mark in his 50s. Now, just for giggles, let's say we wanted to do something like we did with this list here, where we do a for each. So we're going to say ages.for each. Notice how it has string int, fat arrow into void. If you have no idea what I just said, we will cover all of that, I promise you, in future tutorials. And for this, we're going to say k and v for key and value. And we, of course, because this is all one statement, need to end that with a semicolon. That looks crazy nuts, doesn't it, if you're used to other languages? So what we're going to do here is we're going to say print and then do this. So you can see that for each item in our map, we're saying key is value years old. So Brian's 43, Heather's 24, on and on and on. Pretty neat, pretty simple. So that in a nutshell is working with variables. And I realize we kind of got off base on a few areas. I apologize. I've got this bad cold medicine going on. But if you ever want to know more, you can definitely go out to the Dart Lang page, dartlang.org, and look at the Dart language tour, and definitely check these out. One other thing you should note is you can click on libraries, tour of Dart libraries, and you can see the built-in libraries, Dart Core as it's called, and you can get much, much more information out of all of these things. You can get some really good examples. This is something I really have grown to love about dartlang.org, is it has all this information baked right into the web page, so I don't have to spend 5-10 minutes, looking up on Stack Overflow or Expert Exchange or anything like that. You can get a lot of great info out here, so definitely check this out. That being said, thank you for watching. I hope you found this educational entertaining. And before you go, the source code for this will be out on voidrums.com, also on GitHub actually. There's a link to it on my website. And be sure to check out the Void Realms Facebook group. There's 1,700 other developers out there. And that's it. Hey everybody, this is Brian. Welcome to the third Flutter tutorial. Just posted the first two the other day, and as you can see, I've already got a few hundred on each one in comments and some thumbs up. So everybody seems to be really interested in Flutter, so we're just going to continue on down the path here. Now, to back up, we have to learn Dart before we can learn Flutter. Looking at the tour of the Dart language, you can see how they kind of, if you go in, they cover variables, keywords, variables, built-in types, which we've covered, but then they jump to functions, which if you're new to programming, really doesn't make a whole lot of sense. If you remember, a variable is something that'll change, where a const or a final is something that will not change. A function is a way of organizing that into a logical group, but you haven't yet used variables. You don't really know what to do with them. So we're going to actually skip down to control flow statements. So control flow statements are exactly that. They control the flow of a program. And the first one we're going to cover is if and else. So let's just crack this open here. We're going to make a new Dart console application, and we're going to call this flow1. And while that is thinking, we're going to skip back here. So some of you may be confused and go, why are you jumping to control flow statements? You're not talking about functions. We're going to talk about functions after we deal with control flow statements. The reason being, you know what a variable is, like I said. Now you need to know what to do with the variable. It's something that will change, but how do you handle that change? What do you do when the change occurs? So that's what we're going to really cover today. So let's just get rid of this and get rid of that. Once again, the structure of our application, we have got our main.dart in here. And if you're wondering what this lib is, this is just part of that demonstration code that let me undo all this. It's part of that demonstration code that comes with the template. Really, they're just importing this, which we're going to cover in a future tutorial. But for right now, you can safely ignore it. Now, if you go back to our previous tutorial, you'll see that, ta-da, there is a variable here called arguments. So this main function already has a variable, so something's going in here. An argument is something that is passed to your application when it is first started. Something we're not going to really be dealing with, but just be aware that that's there. That's how you can tell a program, start just normally, or start and open this file, that kind of thing. So if and else, whoopsie, cannot type. So let's make a variable here. Let's say bool is on equal false. So we have a variable, and we're going to say, let me actually just jump down a little bit so it's easier to read. If, and then you have these parentheses, is on equal. Notice there's two of those. Now there's a bit of a heated debate in the programming community, and I'll get to this in just a second as I can't multitask today. It has to do with the brackets here. This is what's called a C style language. C is probably the grandfather of all languages. Well, not all languages, but all C style languages. C was meant to make assembly easier. C is actually kind of challenging, but so you have these brackets, and this denotes a scope or a block of code. You notice how there's two of them here. You notice how there's here and here. And actually, in this IDE, if you click on one, it shows you where the ending one is. So there and there, there and there. That's your scope. So what we're really going to learn right now is two quick things. First is variable scope, and what is the if and else statements. But the religious battle, if you will, is where to put this little bracket. Some people like putting it down here. Some people like putting it up there. Now, when I say up there, what I really mean is you take this and you put it on the same line, like that. It doesn't really matter where you do it. Some companies have coding guidelines and standards that you should really follow, but just know that you need a start and end bracket to denote scope. So what is scope? I'm glad you asked. Okay. So let's make another var. Let's call this var kitty equal I don't know what to name a cat. Let's just call it cat. Why not? So let's run this, see what happens. It is off. So we've got our variable, bool is on equal. Notice there's only one, false. If, so this reads like a statement here, if, and then we have our parentheses. This goes back into arithmetic where you have to multiply and add things. So you'd say 3 plus 2 plus 6 equals, whatever, right? What's ever done in the parentheses is going to be calculated first. That's why it's in parentheses to begin with. So we know that this is going to be evaluated. Now, this is an evaluator. Actually, this is a, drum roll please, operator. And it is an equality operator. And you can read a lot more here. So you see how there's two of them. Now, why wouldn't you put one? Some of you old programmers know what I'm talking about. If you do that, what you're really doing is you're assigning the value, much like you're doing up here, is on equals false. So when you do the double, you're saying is on is equal to, if is on is equal to whatever the value. So that's why it says it is off. Now if we change this to true and run this, it is on. So you can see how you have control flow here. This statement is being executed because it is true. If we flip it back to false, then this statement will be executed along with this variable being created. So let me add some comments here. Inner scope, outer scope. Did I misspell outer? That'll be embarrassing if I did. I don't think that's outer. That's otter. Anyways, it's not even otter. Man, cold medicine, I'm telling you. So scope, anyways. Scope goes in a logical order, or you should say top down. So for example, is on, notice how we can actually access it here. Let's actually do it like this. And let's actually just copy this here. Run this. So is on equals false. So we can access this variable in this scope or in this block of code. What happens if we try to access kitty? Notice how IntelliSense isn't helping us out, and it's saying object, meaning it doesn't know what the hell we're trying to do here. And it's complaining, and it's saying, hey, unidentified name kitty, but we have it here. That's called scope. And true enough, if we try to run this, it's just going to say blah, no top level getter for kitty. What's a getter? We'll cover that in a future tutorial. However, just be aware, kitty is out of scope. So where is kitty? Right here. Where's the scope? Right here. We can access kitty just fine as long as we're in that scope. Once again, is on, this variable, probably horrible variable name, is in the outer scope. So it's available to anything in a subscope. Subscope being a scope declared within this larger scope. Whew, that gets confusing. So let's go over that one more time. We have our outer scope here. In that outer scope, we have subscopes. Kitty is defined within a subscope, so it is not accessible in the outer scope. However, variables described in the outer scope are available on the inner scopes. Is that even the right way to say it, inner scope? Somebody correct me if I'm wrong. But if we simply move this print statement up here, we can see it runs just fine. So that is a very quick lesson on if and else and is on. So what's the difference between if, else, and, scroll down here, whoa, we went way too far. Else if, you'll see this a lot. What's really the difference here? I just stuttered, that was embarrassing. Anyways, the difference between if, else if, and else. Let's figure this out. Let's just, through the magic of copy and paste, change this around a bit. Actually, no, I want to keep this as an example. Let's say int test equal 1. Why not? Why are you indented? I don't like you. All right, so if test equal, I'll say 2. Now, if you're going to choose a bracket style, you should be consistent in that style. And you should probably put it in the print statement, Brian. All right, so we've got our little else here. And we can even break that down further like this. I'm kind of like an indentation snob, if you will. I like it a particular way. Else, and we're going to just say now from our scope conversation, we know that we can access this variable because it's in the outer scope. So let's run this. So test is 1. So this got executed, not this. So let's just copy this again and see what happens. Notice how we're getting an error already. Expected a statement. What's going on here? Line 30, position 3. So we're at line 30, position 3, because we're 3 spaces in. Unexpected token else. But if we say else if up here, what happens? It breaks. So let's look at this and see what we're doing wrong here. We have our if. We have our else if. Now, this is what we're missing here. So we have to notice how all the errors suddenly clear up. And let's just, so we know this. Run that. So test is 1. Because test is 1. Confused yet? Don't be. It's just a way of chaining if statements. You have an if statement here, an if statement here, and if neither of these actually apply, then do this. That's really all that does. Now, there is an easier way of doing that, or at least a more elegant way of doing that. But before we cover that, I want to talk about comparisons in the if statement itself. If you read their disclaimer, it says, remember, unlike JavaScript, Dart treats all values other than true as false. See booleans for more information. Sometimes people will say things like test equals 0, and then instead of that, they'll just say test, if test. And you notice how it must be a type of bool. So it's got to go into a true or false sort of statement. It's pretty easy to do that, though. So now we're going to cover what's called the switch statement. It's called switch in case, and I think that'll probably wrap up for this tutorial. So this looks just horrendous. What is this thing? Okay, let's break it down a little bit. You've got switch. Now think of this as a giant switchboard on off, right? You've got a dozen switches in front of you, and you can flip each one on and off. So here's the variable. So we've got var command, and then we've got our evaluator, the parentheses, and then we've got a scope. So within this scope, we've got a bunch of cases. Now think of these cases as shorthand for if else. We're going to rewrite this whole thing. So using the test, switch, test, and there's our scope. Notice how what we're not doing is testing for equality or inequality. Like we're not saying, not equals or is equals. We're just saying we're going to switch on this test. Now we've got a bunch of switches, and we'll say case 0, break. Case, let's actually back out here, case 1, break. What is going on here? Well, let's find out. Nope, test is not 1, test is 0. Derp. I hate having a cold. I feel so just out of it when I have a cold. It's finally going away, but man, what a long road this has been. All right, so you can see up here our variable is 0. So what's going to happen? And let's actually define this out here. Switch. That way we can really see what's going on when we print these out. Run this bad boy. And you can see switch test is 0. So really what we're doing is pretty much the same thing. It's just we don't have all this if-else gobbledygook. So this monstrosity right here is the same thing as saying case equal 1 inside of a switch. So here's our switch. Here's our switch. Now, one thing you should know is there is an invisible scope here that you don't really realize. So let's just say var dog equal Sam. And then we're going to print Sam. Notice how Sam is going to say undefined object, and if we try to run this, of course, it's going to break. Oh, no, it actually didn't break. Interesting. Probably because it didn't execute. Let's do this. Yeah, now it's going to break. So that's how you'll find some errors in your code. Like if it's working just fine one time, but then not working another time, check your scope. The invisible scope is between the case and the break. Think of the invisible brackets being here and here. Each one of these cases is a little switch, like a light switch, right? So we've got 2 of them here. We are declaring this variable inside of this switch, or this case. It's not declared here. Therefore, this code gets executed when it's 0. This code gets executed when it's 1. So if this code's executed, this variable's never created. You see the catch-22 now. So if you wanted that, you would either have to make that in each one, or better to do it up above. Now let's get rid of that and get rid of that. And let's see if this works. Nope, no top level getter for Sam declared. So you'll have to understand that scope here is a little wonky and a little crazy sometimes. So you just definitely want to make sure that you declare your variables in the proper place. Now, why isn't this working here? That's a good question, and honestly, I don't know. In other languages, this works just fine. So why is this not working? Probably because I have the wrong variable name altogether. So let's retest all of that. That was embarrassing. So let's print dog. I may be wrong. I'll be flabbergasted if I'm totally wrong here. All right, so back here, test is 1, so this will execute. Yeah, all right, so, and if we put this here, it suddenly works, but it would be much better to actually put it up above right here. All right, sorry for that little confusion. That's also a good conversation we should have is variable names. If your variable doesn't exist, you're going to get an undefined error, as you just saw. So that in a nutshell is the switch statement. But there is one little question we have, one naggy little question. What is default? You notice how it's case, default. And what does break mean? Well, let's try something here. Let's actually make a case 3, print I'm actually trying to hurry because I'm supposed to take my daughter out to lunch and I am starving, which is probably why I'm making a lot of mistakes here. And then we're going to say default. No idea. Wow, I can't even spell no today. I'm going to go get some food here right after this video because I am just dying. I'm going to go get some hot wings, man. I'm hungry. All right, so we've got our cases here, and we're just going to put a hard return so that it's easier to read here. So we've got our case here, our case here, our case here, and default, which is actually a case. So let's change our test to a different number, something that we're not accounting for, and run this. See how it says no idea. So default is basically a giant else. It's this else statement here. We're going to switch this back to, let's say, did we totally skip 2? We did. That's just odd. Somebody's probably yelling at their monitor going, there's no 2. Get rid of dog here. All right, so we've got 2. Let's just get those in there the way they should be. Put that in as a 2. Run it just to double check. Test is 2. Now, let's talk about these breaks. Let's actually comment these out and see what happens. Notice how last statement of case should be break, continue, rethrow, return, or throw. What does that mean? We're going to get into that in a little more in depth in future tutorials, but right now you need to understand what's happening. Break is like hitting the brakes on your car. It stops execution of the code. If we change break to continue, continue statement is which must have a label or as a target. What that's telling us is that we could continue the flow of execution if we wanted to go somewhere else. I actually don't know how this works, but let's say continue 3. Nope, continue case 3. I'm sure there's a way to do this, I just don't know. Continue case is not a word. Yeah, I'll figure that out in a future tutorial, but basically just understand what break is doing is actually breaking. So let's get rid of this again and see what it's saying. The last statement of case should be break, continue, rethrow, return, or throw. So let's try return because I know that'll actually work. What is the difference here? See how case 3, the last statement of the case, blah, blah, blah. Let's turn that. There we go. Now it's working. So what's going to happen here? All right, pop quiz, everybody. Based off the current code, test is equal to 2. What do you think is going to happen? Is it going to print done or is it not based off this code? Let's find out. There's no done. But if we switch this, whoops, and rerun it, see how done suddenly appears. So that's what's going on. Break will stop execution, but not return. Return means it actually exits the entire function. Return is actually returning out of this entire function. Actually, out of this function right here. Switch isn't really a function, but I'm going to call it a function. Shh, don't tell anybody. So it's going to exit out of the switch statement and then hit print. So when in doubt, use break, but just understand that that break is there for a reason. Some languages have what's called fall through. So you could actually say this and then this. So if it's case 1, break, case 2, we want it to do this and this and this. So just understand that is a thing, and we need to prepare for it, which is why the break statement is there. Well, that is a lot of talking and typing, and I'm going to go get some hot wings with my daughter. Thank you for watching, everybody. The source code for this and other tutorials will be out on my website, voidrealms.com. There is a link to GitHub, and let's just go out there. You can click on repositories, and what I do is I have individual repositories, but then I have a master repository that has the individual lessons in there. These are called submodules, so you may have to use, it may not actually download with a full zip. You may have to actually use Git and pull the whole thing down. That way people can contribute to the code. If I make a glaring mistake and it is out in the world forever, somebody else can, submit it. If you found this even remotely helpful, my website and all this code is actually run purely off donations. You don't have to, obviously, but if you are a company and this is helping your employees learn, definitely donate. Anything that goes above and beyond what I use to run the website actually gets donated to charities. Other than that, thank you for watching. Hey everybody, it's Brian. Welcome to our drum roll. I think this is the 4th. I lost count. Yep, it's the 4th Flutter tutorial. Today's just been nuts, so forgive me if I'm a little scatterbrained, but we are going to pick up where we left off on control flow statements, and we're going to be looking at the while and do along with the break and continue, and we're going to touch on the for loop. So if you're reading along in the official documentation, you can see there is this while and do while. While loop evaluates the condition before the loop, and you can see this nice little example, versus a do while loop evaluates the condition after the loop. That's confusing. So let's look at these a little bit here. So let's say Let's make a variable. Let's call it bool, because I like things indented. While running, we're going to say print Now, if you're new to programming, one thing you should be aware of is that a loop needs a break, if you will, or it needs to be able to stop execution of that loop. Or what happens is something like this, where it just goes boom, and it just runs forever. You can see down here, it just runs and runs and runs. And to kind of illustrate that, what we're going to do is we're going to make a variable here. And we're going to say counter. If you don't know what that is, it's the same thing as saying counter equal counter plus 1. It's actually shorthand for that. And we're going to say, we'll call this the while counter. So if we were to just run this right now as is, it's just going to count until eventually it gets a Stack Overflow and dies, or until the underlying framework resets that into a 0. Sometimes it'll actually flip it back to a 0 for you. I actually don't know what it does in Dart, but every framework kind of handles that a little bit differently. Stack Overflow would basically be like the whole program just crashes and you get an error message where it will say value out of range or something like that. So what we really need to be able to do here is say if counter greater than or equal to 10, actually say 5 just because I'm lazy, then we will say running equal false. So what we're really doing is we're saying, hey, stop running, but we tell it, hey, set this variable to stop running. Let's run that, and you can see it says while counter equal blah 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 down to 5. So what's going on under the hood here is it's saying while evaluates this expression must equal true, and because we're setting it to false here, every time it reiterates through this loop, it's reevaluating. So when it gets to here and that's false, it just stops. So we can say print onto the next, and you'll see kind of what's going on here. And it says bang, 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 on to the next, and then it just stops. Now the do loop is very similar, and there's our evaluator. And we need to reset that actually. Running equal true. Let's see, counter equals 0. And we're going to actually put in some print statement here. Let's not say waiting, let's say done with while. And then down here, we're going to say done with do loop. And we can actually just take this, and you'll see that it's pretty much the same thing. See? Probably help if we put this as a do instead of a while so it's less confusing. You see it's pretty much the same thing. So why do we need two of them? It's actually pretty simple. It depends on when you want your statement evaluated. Do you want it before or do you want it after? Typically what this will do is it'll take action, then evaluate the statement. I shouldn't say typically, that's exactly what it does. It'll execute the scope of code, then evaluate the statement. Oops, I just screwed that all up. And the contrast to that, the while statement will actually evaluate, and then if it's true, then it'll run it. It's a unique difference. You can get into some pretty special situations. You can actually get into trouble a little bit, like if you have like if you're doing like socket programming and you're not ready to receive data yet, or you're not ready to send the data, but you do a do loop instead of a while loop, you can get kind of messed up. So just understand the basic differences between that. Essentially, they do the same thing. It's just the order in which your statement is evaluated. Now, this could also be rewritten like this. What is that actually doing? Well, it's doing a few things. First, it's ignoring our evaluator, and it's actually breaking out of the scope. You ever play that game Breakout? That's what break does. Remember how we said it kind of hits the brakes? So it's going to run this scope, but when it hits this break, it's going to say, nope, I'm done, and it's just going to break right out. So which one should you actually use? Well, it depends on your situation and what you're trying to do. You could also say, well, counter is less than 5. I'll actually say less than or equal to 5. And let's do this. We're just going to ignore that whole running variable. Clear our buffer. Now, you can see how things change a little bit here. Now we have up to 6, where we really wanted, because it has this counter in here, we only wanted 5, now it's going up to 6. So you would say, less than 5, run it again, bang. So you see how it really depends on how you structure your code and how you write it. There's really no correct way of doing it. That's the beautiful thing about programming. Personally, I don't like to put this evaluator here. I like to use an actual variable. That way I can check that variable state at any time. And then I like to actually set the variable. I don't like to do the breaks. Personal preference, that's just how I like to do it. Let me make sure this still runs the way we expect it for the tutorials. And now we're going to look at the for loop. For loop's a little bit different. Actually, let's cover continue here. Real quick, why not? We'll say if counter equal 4, then continue. This is the difference between break and continue. Remember how break will break out of the scope of execution? And what we're going to do here is we're going to say, I don't like doing that, but we'll do it anyways. Let's run this so you can see exactly what's happening here. 1, 2, 3, 5. We totally skipped over 4. So what this is doing is we're saying if, and then we're evaluating here, the counter is equal to 4, continue. What continue does is it says, okay, I've heard everything I need to hear. This is a lot like arguing with your wife. I've heard everything I need to know, and I don't need to hear the rest of this. Let's just go back to the beginning. So what this does is it actually says go back to the next iteration and starts completely over. Let me go back up here so you can see it. So in this case, it'll go 1, and it'll go through 2, it'll go through 3, it'll go through 4, it'll go through, hit this, and say, nope, I've heard everything I need to know, and it goes back up here. So this never gets executed. And on 5, it runs all the way through this and says, hey, counter is greater than or equal to 5, and we can actually just say equal to. Probably a better, more streamlined way of doing this. Counter is equal 5, then break. Just hit the brakes. I'm done with this whole thing. I'm getting a divorce, and I'm leaving you. And it just jumps out, and it says done with the while loop. So there you go. Now, back to what we were going to talk about, which is the for loop, which is a little bit interesting. For loop, if you're new to programming, you're looking at this going, oh my gosh, this looks insane. I don't want to type this out. It's actually very simple, and it's very easy to get. And the first 2 times you do it, you're going to get it down the rest of your life. And it's in almost every major language, so here we go. I equals 0. Let's say I equals 0. Notice that little guy right there. And then we're going to say I less than 5, I plus plus. So what are we doing here? What is all of this? Let me put this back up here before people on YouTube yell at me and hurt my feelings. Let's just print this little guy out so we can see what's going on here. And we're saying I 0, 1, 2, 3, 4. So we've done this 5 times. Let's kind of examine this. The for statement actually takes 3 separate parameters. And I almost wish those were commas, but it's just not how it is. And that's a holdover from the old C++ days. So this first one is actually setting a variable. We're going to say we want a variable named I and set it to the value of whatever, in this case 0. Then we're going to say while, because there's actually a hidden while in here, while I is, and then whatever, and we're going to say less than 5, increment I. So here's our incrementer is back here. So basically we have what we want, when we want to do it, and what we want to do to it. And then while that whole thing evaluates to true, we're going to execute. Plus we have our variable from the top. Confusing, but why do we need this? Imagine this. List, and we're going to say string, and we'll call this list equal new list. I have a bit of a sore throat and it's kind of bugging me a little bit here. So that's how we make a new list of strings. Now we're going to say list.add. Everybody always asks me, why do you always put your own name in these? I don't know. It's just because I'm on the spot and I just can't think of names. I'll come up with names like Slarty Bartfast, like I did in the previous tutorial. I just, on the spot, can't think of really anything other than like myself and maybe immediate family, if I could spell immediate family. All right, so let's say we've got a list of people, and in this list we've got 3 people. So, how would we go about doing this? Remember, this is a 0-based index, right? So we're going to say list, and we're going to say I is less than length. And then we're going to increment. So let's just run this and see what happens here. So we know that we have 3 items. First one starts with 0. So what we can actually do here is we can say we're going to try this. I'm not sure if we can do this, but we're going to try it. It might blow up and I may have to put it outside, but it'd be really cool if we could do this. Boom! Didn't do it the way I wanted it to do it. Yeah, let's just put it outside. That way it's easier for people to follow along. So for the sake of the tutorial, this is what we're going to do here. We've got our string, and in there we have our I variable equals, and it's not actually signing, this is just a string, and then we're going to catenate, is that right? Catenate that string with the value of that item. So you can see that 0 is Brian, 1 is Heather, 2 is Chris. I kind of want to figure out how to get that to work. Element at, let's try element at I and see if this actually works here. I'm sure there's a way to do this, and that's why I'm kind of wanting to try it here. Forgive me for just a minute. See if that actually, I don't think that's going to work. Fingers crossed. Nope, didn't do it. All right. Dear Dart developers, if you are, or Dart, yeah, Dart developers would be right. If you're watching these videos, please make that work. That was awesome. I'm probably not doing it right, and there's probably a better way of doing it, but that in a nutshell is how you would do it. Personally, I prefer the shorthand. Get rid of that scope operator there. Same thing. So why do you need the for loop? What's really the difference? I mean, couldn't you just say while we are not at the end? Well, you could, but it's very ugly. So what a for loop replacement would look like, we would say, counter equals 0. Let's say, hey, while counter is less than list dot length. I have a nasty habit of putting that on the other line. Counter plus plus, and say print. And here we're going to say whoops, we want it to be counter. Actually, let's make it I. That way it's more intelligent here. And I. I, and I, and let's run this. Ooh, what do we got here? What's going on with this? Invalid value not in range, exclusive 3. So what we're saying here is we have, it starts at 0, and I is less than length. So let's try this. You see why this gets a little hairy here. Actually, let's do this and see if it just runs. Okay, so that does run. And let's get rid of this guy, because that's what's actually causing the error here. And let's just see what we got here. Boom. Oh, see, 1, 2, 3. So we got it in the wrong spot. That's really what's going on here. So we need to actually increment this afterwards. Now it'll run. There we go. So this kind of illustrates some pretty good point. And let's actually put this. So we can see the difference between the two. So we've got our for and then our for replacement. They do exactly the same thing. It's just one is a little bit more complex, a little bit more error prone, while the other is a little more streamlined and elegant and kind of, if you will, industry standard. So if you ever get like a professional job writing code and you do something like this, your quality control agent or your manager is probably going to sit you down and say, why didn't you use the for loop? Because this is exactly what the for loop is designed for. So anyways, those are the distinct differences between them. Just to recap, the while loop evaluates before, the do while loop evaluates after, and the for loop is perfect for going over lists and enumerations. Whew, that was a mouthful. Thank you for watching. If you found this educational and entertaining, be sure to go out, visit my website. All the code is out on GitHub, and I've got a link out to the repository right now. If this was helpful, feel free to donate. This site is run 100% off your donations. Thank you. Hey everybody, this is Brian. Welcome to the 5th Flutter tutorial. All right, so we're going to jump back into Dart here where we left off. And if you remember, we left off on flow control. And a lot of tutorials start things backwards, in my opinion, where they will talk about a variable, then instantly jump into functions and classes, which make no sense at the time because you don't know what you're doing. So what we've done is we've started with, what is a variable, what is a const, final, and then we've gone into flow control. How do you actually control the flow or the execution of your program? And we did the if, else, for loop, while, break, etc., etc. What we're going to cover now is going to be functions. So what are functions? Believe it or not, you've actually worked with them already. This main right here is a function. Main is actually the quote-unquote main function or the entry point of your program. What I have here is just a new Dart program, and it's straight out of the template here as soon as you open it up. And you see how it's got this int calculate here? That's also a function. So really all a function does is break up or chop up the scope of a code. So we can do things like, let's get rid of this because we haven't talked about that stuff yet. Let's say print hello. Just something simple like that. We just want to print the word hello. Well, print is also a function. somebody has already written that code for you, and that's how you're able to call it. So let's say we want to print 9 times. So we're going to say for int I equals 0, I less than 9, actually I less than 8, and I plus plus. Let's do this. One, two, three, four, five, six, seven, 8. Did I count that wrong? 1, 2, 3, 4, 5, 6, 7, 8. I did. Silly me, I had it right the first time. My brain's fried. Sorry about that. It looked funny. That's why I was like, what is going on here? All right, so we just printed 9 times. We've done this before, and this is old hat. But what we're going to do now is we're going to take this guy and put it into its own function. Actually, let's not call it test. Let's say hello. So what we have here is we've created our own function called say hello. And it has this weird thing called void in the front. A function is always precluded or preceded by a return type. So we can return a variable from this function if you want. Void means that we're returning nothing. It's just void of any return value. So if you see the word void and you're wondering what the heck, to call that, you just simply say the name. Does the exact same thing. What we've done now is we've broken up the scope of this a little bit better. If we flip over here, one of the things is called lexical scope. Dart is lexically scoped language, which means that the scope of the variables is determined statically simply by the layout of the code. And we've talked about this before, right? So like here's your top level, which is visible by everything. That's visible by everything. But the inside function is not visible by that. That's called lexical scope. We've already learned that. So what we're doing now with functions is actually breaking this up even further by saying, for example, this I is not available here. We could even say int age equals 99. And we cannot here say print, whoops, age. It doesn't know where age is because of that scope. Age belongs to this lexical scope or this block of code. So if you're still new and you're still trying to wrap your head around scope, that's really what scope means. So what a function is basically taking scope, chopping it up even further and saying, I want this function to exist. And this function will only know about things that are inside of this function or this lexical scope right here. So for example, if I say int age, well, let's not say that, int cats equal, and there's 9 cats. I don't know why I'm fixated on the number 9 today. And here we try to say print cats. Well, guess what? It's not going to work. Undefined name cats, because it's not in the same scope. So let's get rid of those. I'll get rid of that. So that is a very, very bare bone basic example of, you guessed it, a function. Now, what we're going to do here is we'll say, void annoy. We all have that one annoying person, right, in our lives that just loves to talk. And we'll say int times. And here we're going to just say for int I equal 0, I less than times I plus plus. I think my music stopped playing. Did my music stop playing? No, it's just very quiet for some reason. I have to play music in the background or this wireless headset will actually shut down on me. It's kind of weird. So some videos you'll actually see me flip back and forth. But so we've got our for statement here. Very similar, except for instead of just hard coding it, we're doing this. So we're going to say blah. So somebody says hello. Let's actually leave that the way it is. But then the annoying person, annoy, and let's say they come up and they just start talking. Blah, 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 blah. We've got 1,000 blahs in there. I mean, at this point, you just want to like walk away and tell them to go bye-bye or something. So what we've done here is we've actually passed a variable to this. Believe it or not, this is a variable. Some would say it's a value, but remember, everything in Dart is an object. Therefore, that is actually a variable under the hood. This is called a parameter right here. The cool thing about parameters is what we're doing here is we're actually creating another variable, and that variable exists within the scope of this function. You can see how we're accessing it right here. And we can actually say things like, let's get a little funky here. I of my phone made a weird noise that I never heard before. So here we're going to say, what number of the number of times we're supposed to do it, and then they're still talking. So let's just run this again. And you can see, boom. So we obviously have access to this variable. And there's really no limit to how many times you can actually do this. So what we can do here is we can say, void really annoy int times, and then we could just say, let's grab this. Now this may look a little weird, and I wanted to do this as an example. So let's grab this and let's just comment these out here. So what's going to happen when we execute this code? Well, really annoy is going to get called, which is this guy here. What really annoy is going to do is it's going to actually call annoy, which is going to do this. So it's 5 by 5. You can see how it does this. And it just goes over and over and over again. So that is a function calling a function calling a function kind of thing. You have to be kind of careful when you're writing functions because you have, and some people are going to argue this isn't really the case, but you have a bit of encapsulation. And what this does is this gets a little confusing if you're not used to scope. For example, in really annoy, we have int times, and times is here and times is here. However, this times right here, while it's the same value, is probably not the same variable unless Dart's doing something under the hood where it, because it's the same value, it moves it in memory and blah, blah, blah. It's not the exact same thing. It's got a completely different scope and therefore it has a different access. So we can actually change this name to blahs. And notice how now we've got to change it here and here. But it does the same thing. So looking at the functions inside of the tour of Dart, you can see there's other things like bool. And of course, now that I'm looking for it, there's void string, things like that. So you can actually make some really cool functions. So what we're doing here is just we're concatenating two strings together, actually technically three because this is also a string, and we're turning a brand new string object. So let's go ahead and do this. Okay, so we have my first name and my last name. And you can see how it just prints out the string Brian Cairns, because what we're doing here is we're calling this function, which is taking two parameters now and returning them as one variable. Now, if you're wondering what types of variables you can return, well, any type of variable, any object actually. You could actually even say var for unknown type. Oh, actually, no, you can't. The return type can't be var. I stand corrected, ladies and gentlemen. I thought you could do that, but you cannot. Which makes me wonder if you can return an object. You can return an object. Okay, so if you have no idea what you're returning, it's just something, you can return an object. But in general rule of thumb is you don't want to do that, because then they have to either know the type or they have to use something called reflection to go in and figure out what type of variable it actually is. Dart is a static type language, meaning that you have to declare your variable types. So let's go back to the tour here. There's some really good examples, and if you're not familiar with any of this at all, you should really kind of just play with some of these and figure out what they do. One thing you can do is default parameter values, and this is really kind of built into almost just about every language here. And what you can say is, your function can use an equal sign to define the default values for both the name and the positional parameters. The default values must be compile time constants. If no default value is provided, the default value is null. Meaning, because these do not have a default value, they are null. Null means there's just nothing there. It's like nothingness. It's like when you lose a puppy, you're just empty and void inside. So what we can do here is, where to go? Is we can turn one of these into a default value, right? So let's just say this. Not good at Call of Duty. And it says positional parameters must be enclosed in square brackets here. So what did we screw up here? That's a good question. What did we screw up here? This thinks it's optional here. Let's try that. Brian Cairns. Now if we omit this guy here, we suddenly get Brian not good at Call of Duty. So what we're doing here is we are saying this will be null. We are not assigning a value to it. It must be assigned, and there it is here. So if we just delete this, you notice how suddenly it's going to freak out and say 1 argument is required but 0 found, because this is the required argument. We haven't supplied anything, and you can't actually do anything with it. So you could actually pass null, which may actually make this thing explode. Let's find out. Yep, see, the method blah, blah, blah was called on null. So we're saying null plus these strings. So Brian, well, let's just change this to is not, because I'm really not good at Call of Duty. I've been trying to get better at it, but I'm not good at it. Let's run this again. So we've supplied the first value, and it's not null. And then we have this optional, and we are assigning the value to it. So because it's optional, and you have to include any optionals in these brackets, you don't need it. You see how there's no name here. But the minute we include it, and let's just do my name again just because why not? Run this, then suddenly it is not using the optional parameter because we have supplied the value. Once this value is in here, it gets converted to a variable, and it replaces this. So think of this right here as like a temporary variable. And let's say, oops, let's just call this string extra. And let's make that lowercase just because I'm kind of snobby about that these days. And we're going to add the extra in there. So you can see how we actually can do this, right? So we have Brian, which we've supplied, Karen's, which we've supplied. We did not supply the extra, therefore it's going to use the default. And we could actually take this out right here, and you'll get two of them. See how that works? So as you can see, functions are pretty neat. There's a lot of things you can do with them. One thing you should really be aware of when you're creating your functions, though, is the actual scope of the variable, because sometimes things can get a little squirrely and you're looking at one function, and because you've named the variable the same in many functions, you think that variable goes everywhere, and it really doesn't. So that's all for this tutorial. I'm going to keep going down. There's actually a lot to cover on functions, so we're going to make a couple of these. But if you found this helpful or even moderately entertaining, go ahead and visit voidrums.com for the source code for this and all other tutorials. And if you're so inclined, go out and join the Voidrums Facebook group. There are 1,720 members out there right now, all walks of life, all programming languages. So definitely check that out. Join up, become a member, and help everybody else out. Thanks for watching. Hey everybody, this is Brian, and welcome to the 6th tutorial on Flutter. We're going to continue down our path with Dart. I'm going to try and go through these fairly quickly, but because Dart is a new language and there's new features, we got to go through some of this elementary stuff. So some of you more advanced folks, just bear with me while I slog through this. There are some new features, so definitely pay attention, and I'll try to call them out when I get there. So this is going to be our advanced functions tutorial. So the first thing we're going to do is just create a new project here. Make sure it's Dart console application. And let's call this Advanced Func. Why not? I have a really hard time coming up with names for this sort of stuff. And it'll process and do its thing. Tick tock, IntelliJ's always so slow. There we go. All right, so we've covered some of this stuff before. We've got our calculate function, which is off in the lib, and we're going to actually use that this tutorial. So if you're curious about how that works, definitely pay attention. All right, so we're going to go ahead and just get rid of this. We're going to leave this up here this time. And we're going to cover that in just a second, but let's get through the rest of this first. So in our main function, we want to make a variable. And let's just say list. My keyboard's crooked. Bear with me here. This is what happens when you get old and cranky. So we're going to make a list with an integer type. Call it list. And if you remember, these little brackets with the type in it is generic programming, because that list can hold more than one type. And then in our list, we're just going to add a few values. So we'll say 1. And I'm not going to really add too many variables. I'm actually just going to use this one variable, because this is a function tutorial, and I don't really want to spend a lot of time wasting your time writing variables. So I know a lot of tutorials out there have like these big, weird, complex algorithms that are hard to understand. We're not doing that. All right, so we've got our variable that we're going to work with. So the first thing we're going to cover is a function as an object. Maybe if I can spell object. So what does that really mean? Let's just make our function here. Nothing super special about this, right? And we're just going to say print I. There's really nothing going on in there. If you remember, everything in Dart is an object, and I mean everything, right down to functions. So we're going to say list for each. Now, you notice how there's a little bit of verbiage here. For each, and then there's parentheses, int, and then an arrow, and then void something something. We're just going to double click it from the moment, and you see how it says void f element, e element, sorry. So really what that's saying is it cannot return anything, void, and the function itself is going to take the element. Now the element goes back to generic programming. Under the hood, this actually says something like this. List E, and E would be the representation of whatever object we're shoving in there. So the template for this thing has to be void, cannot return something, and then it has to take the element. So we're just going to say as object. Finish this off with our semicolon here. And let's actually, because we're going to make a bunch of these. I just finished watching Stranger Things last night. Oh my god, that show is so good. But now I'm trying to find other things to watch, like a Netflix junkie. All right, so when we run this, this is what happens. It says as an object, bam, and then list for each, and then we're calling the actual function as an object itself. This object is instigated when the code is run, so we don't have to do this, new blah blah blah. It already exists in memory, and there's one copy of it. So as object, and then that has to follow the template. So if we do something like this, it may get kind of franky on us and say, hey, nope, yep, see, argument int string void cannot be assigned, blah 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 blah. Basically what that's saying is it has to follow the template, and the template is you're passing one element which is in that list. So that is a function as an object. I tend to not use that too much because then the code gets kind of weird. You're trying to hunt down this thing and figure out what's going on. But if you just want to go through it, then I guess it's okay. What I tend to do is, yeah, I'm just going to copy and paste this whole thing rather than type that all out. Bang. As an anonymous function. I'm lazy. I really didn't want to spell anonymous like 6 times. This keyboard's kind of jacking with me. I need a new one. I was playing Call of Duty, and admittedly, I slammed my fist down on the keyboard, and now it's acting kind of crazy. So, anyways, so we're going to do for each. Now, this time, we're going to do something a little different. We're going to do what's called an anonymous function. Now, an anonymous function has kind of a crazy syntax, but it'll save you a lot of headache. What you can do is say for each, and then we're going to just say parentheses, I, and then bracket, and don't forget to close this out with a semicolon. And we're just going to say print I. This is bananas. What is this? Let's run this, make sure this actually works. So as an anonymous function, bang. What in the heck is going on here? So what we're really doing is we're creating a function in memory that only exists in this little loop here. It actually under the hood gets optimized and it turns into a temporary function in the base code or whatever, but for our purposes we don't have to jump around all over the place. We just know that, hey, we want to do this and we want to do it right here. So it does the exact same thing as this. It's just you don't have an independent function that you can call as an object. Notice the syntax is we have our parameters, and then we have our brackets, so we have our scope block here, and then we have our actual code of what we're going to run. It's pretty simple, pretty elegant. I actually hated anonymous functions when I first saw them, but I think I first saw them in Java, and they just drove me nuts. But they're pretty useful. As you can see, you don't have to make yet a separate function. Now, if you're going to call this many, many times, like over the course of your entire program, then definitely branch it off into a first-class function right here. So now we're going to see what I mean about my keyboard? External. Why can you not spell keyboard? I'm going to Best Buy and getting a new one. Forget this. External function. So what is an external function? We've been talking about this little file over here for a while now. Let's crack this back open. You see how it's got a function. It returns an integer, and it's called calculate. And it has no parameters, and then it just returns 6 times 7. We can actually call that externally. So let's just say print. And how do we know what to do? I mean, how do we call that thing? Can we just say calculate? Notice how when you start typing calculate, it recommends advfunc.calc. Where did it get that name from? Let's just double click it so it puts it in there for us. It actually got it up here from this import statement that we left. And if you accidentally delete it, go ahead and retype all that in. But it's very simple. Import, and then we're importing a package, semicolon, and then the path to that package. advfunc is actually the name of our project here, advfunc. And then the actual Dart file, advfunc.dart, down here, as, and this is where we're creating the variable. So really, it's that. And we can run this, and you can see the result of that is 42. So let's crack this open. Let's just add another one here. Let's say bool loves this keyboard. String name. So if the person in this function is Brian, me, then I do not love my keyboard. Otherwise, we're going to return true, because everybody else in the world loves their keyboard, especially when they're playing Call of Duty, little bastards. All right, so as you can see, whoops, loves this keyboard. And then we could say I'm so buying a new keyboard. And there's our false. So how would you actually, go about making your own here? You can actually make a new one. We'll just call this Dart file, and let's call this my file .dart. And rather than typing that out again, we're just going to cut this, put it in our little file. Notice how when we did that, suddenly main.dart got cranky because this no longer exists. So now we got to make another import. We're importing a package. And there's different types of imports, but we're just going to cover a package for today. And notice how it actually tries to help you out. So we're going to import advfunc/myfile.dart, the file we just created. Now we need to make it as a variable, and let's call this Call of Duty. It is currently grayed out because it's unused. We're going to actually change that. Bang, now suddenly it's used. Does the same thing. So that is how you would import an external function. Now, the next one is going to get a little bit crazy, but this is the last one in our little tutorial here. We're going to compare apples to oranges. You've heard that expression before if you're in the United States, or maybe even if you're out of the United States. So we're going to make optional parameters here, and we're going to say int apples equals 0 and int oranges equals 0. And then we're just going to simply say compare to other number and actually we don't have to do any of that, we can just return it. I had different in my little notes here how I did it, but this actually, there we go. Maybe. There we go. That didn't work either. What did I do wrong here? Return type int. Oh, that's why, because it's doing an int type. Yeah. So the compare to function is something I really didn't want to use, but basically, let's just switch this just so we can see. Compare to is used for ordering in lists, which we'll cover in a future tutorial, but let's just do this. What we're really focusing on is this part right here. We have our function, and all this does is it has optional parameters. Notice these are optional. They're optional because they're within these brackets and they have a default value. And we're just going to say, man, are you possessed, keyboard? What are you doing here? Jeez. All right, so naming a parameter, and we're going to just say print compare. Notice how you can actually put the parameter name in there. and then hit enter. And it's giving us a -1 because they're not. So let's just change this to 9 and that to 3. And you see how it's now a 1 because it does an ordering thing. I was going to use a bool, but let's just say this is 6 and this is 6, and it should come back as 0, meaning they are equal. So why would you want to actually name your parameter? Why can't you just, do the order here? Very simple. A lot of more advanced code will actually use name parameters. When you get into Flutter, you'll actually use them quite a bit. And it's just an elegant way of saying, hey, this is actually going to be this. And I just want to test this. I want to actually move this around. So you notice how we've actually got it backwards. In the compare statement, it's apples, then oranges, but we're actually saying oranges, then apples. This would normally throw an error in other languages, but should run just fine, and it does. So that is also why you would use it if you don't want to use an ordered list or an ordered list of parameters. So more information, go out and read the official documentation in optional parameters, and you can see how when calling a function you can specify name parameters, etc., etc. Definitely read up their documentation. It's well worth the read. I know it's a little bit lengthy, but I can't possibly cover everything in these videos. If you found this educational and entertaining, the source code will be out on the website. You can just click for the link out to GitHub. And there is a Void Realms Facebook group with, I think, 1,700 other programmers out there, all walks of life. We can definitely help you out with any issues you come up with. Unfortunately, I get just an extreme amount of email. I've actually had to make a separate account and hide it from the world just as I couldn't do anything with it. So don't email me. Go out to the Void Realms Facebook group and go out to GitHub and get the code. I'll talk to you guys later. Thanks. Hey everybody, this is Brian and welcome to the 7th Dart tutorial. Alright, so today we're going to click language and then go back to tour. And what we're going to start today is called classes. You may be sitting in a class watching this video, but this is different. So first off, what is a class? If you've never come from any other language, it'll say Dart is an object-oriented language with classes and mixin-based inheritance. What in the heck does that mean? What it really means is a class is a blueprint. From that blueprint, you create an instance of that object. So let's say you have a house. Well, a house is a abstract concept, right? There's different types of houses. They come in all sizes, shapes, colors, rooms, locations. So a house would be your blueprint. From that, you would instigate or make instances of houses. So you would actually build the houses from those blueprints. And that's kind of what we're going to be doing today. All right, so we're going to create a new project here. And we're going to make sure it's console application in Dart. And let's call this classes 1, even though it's really like intro to classes. So while that is just grinding away, calculating the trajectory of everything in the universe, what does the mixin-based inheritance mean? You'll see this passed around quite a bit. Really what that means is you can have multiple classes and have those classes inherit from each other. For example, you are inherited from your mother and your father. So let's say your mother has red hair and your father has blue eyes. You probably have red hair and blue eyes. Actually, I think most redheads have blue eyes anyways. When I had hair, I was a redhead. But anyways, so let's just dive right in here. So first thing I want to cover is why do we need classes to begin with? We can already put functions in here. So let's just say we want to do void print speak. Whoops. That was just stupid. We want to speak. And then in here we're going to print something, right? And we can call this pretty much from wherever we want, right? We've done this before. And we're going to say, so when we run this, we know absolutely what to expect. It's speaking. But let's say we want to mimic a dog or a cat. Then we've got to change this. So let's say string, I don't know what to call this, noise. And then we're going to add the noise here. And oops, yep, we forgot to add this. So now we want to say, we're going to just imitate a cat here. Meow. Why not? And now it's going to meow. But what if we want to do a dog now? Well, okay, I guess we could just do this and then bark instead. But we are now imitating a dog and a cat, but we don't actually have a dog and a cat. What if we want to add things like fur color, eye color, name, things like that? That's where classes really shine. So first thing we're going to do is make a new Dart file. Let's just call it cat.dart. And notice how I put it in the bin file. If you read the official documentation, the lib is actually really for external or public things. So if you want to share that with the rest of the world, where bin is really for your internal program. I may be wrong on that, but that's what I read. And whoops, we don't say void, we say class because we're giving it an actual type. Now this is not a return type, this is a declaration. Notice how it doesn't take any parentheses. It just has these brackets. So there's no parameters here. We will get into that. They're called constructors. We'll get into that into a future tutorial. But right now we're going to keep it simple here. So now we're going to say void speak print meow. And we're going to just, through the magic of copy and paste, make a new file. Call this dog. And go back to our main file here. Let's just get rid of these. First thing we really need to do is actually import those. So we're going to import, and we're going to import cat.dart, and we're going to import dog.dart. Thought my phone made a weird noise. I just heard that. Anyways, I dropped my phone and it, like, the camera case cracked. The phone itself is fine, but I had to order a special part, but now the phone's acting just weird. All right, so now that we have our classes, our blueprints, we have to actually make instances of those objects. So we're going to say cat, and I don't know what to call the cat. Let's call him Mr. Twinkles. I have no idea what to name the cat. Equal new cat. So what are we doing here? We've seen something similar. So we're declaring a type, which is actually our class, our blueprint, this guy right here. And then we're saying our variable name, and then we're going to actually assign it a value. We're saying new. New is a keyword. New cat, meaning we're going to take that cat blueprint, make a brand new version of that, and hand it to this variable. We could also do this. So now we have two instances of the same blueprint, but they're two different objects. We have an object here and an object here. And we can say now we have an instance of our dog class. And then we can say Mr. Twinkles, speak, Fluffy, speak, and we'll say, what do we call him? Fido, speak. I prefer to do lowercase, but we should, because they're names, I'm kind of weird about that sometimes. So when we run this bad boy, you'll see we have meow meow barks. We've got both cats meowing and dog barking here. So we got a noisy room. Okay, great. But what are we really leveraging here? What's the real power of classes? What we can do here is say like bool clause out. And with the dog, we can say string color So what we have now is our blueprints are different, right? Both of them have a speak, but dog has a color, cat has a clause out. And we can access those through their properties. So let's say Fido, oops, not final, Fido, there we go. And let's just print this bad boy. My spelling skills are much to be desired today. There we go. So you can see we now have brown after bark because we're printing out Fido's color. So that is, in a nutshell, how you would build a class and how you would actually make your blueprint. Now, there's a lot that goes into this, and we're going to have to split this up over several videos. And what I want to do now is actually make a bit more of a complex example. And to do that, we're going to kind of abandon the dog-cat example. We're going to make a new file, and we're going to call it, let's call it house. And in here, we're going to say class house, and we're going to make our scope. Now, we're going to make a private variable here. We're going to say age. And then we're going to make a public variable. Whoops. And then we're just going to make a couple properties that are public here. Like we're going to say int width, int height. Ah, that was my phone. I did hear it. Go away, phone. I'm doing a tutorial. And then what is the difference between private and public? Some of you who know other languages understand this, but some of you that are new may not. Notice how it has this underscore in the beginning of it. That is how you differentiate between private and public. Private means that only this class inside of this scope can access this variable. Public means anything in the class and outside of it can access it. So, good example. Let's just import here. We're just going to say house1 equal new house. So if we try to say house1 dot, and we do that underscore age equal 99 years old, you notice how it is not liking that. It's going to say the setter age is undefined in class house. What does that mean? The setter age. That makes literally no sense. What's going on here? So let's try house1 dot width equal, we'll say this is 100 feet, and house1 dot height. Actually, we should have called that length, but actually let's change that because I want this to actually make sense. And let's say this is 200 feet long. That's kind of a big house. Those take it just fine. So what is this complaining about? Let's just try to run it. And of course, boom. Same error. Class house has no instance setter underscore age. It's doing that because we have a scope issue. This is a private variable and we're trying to access it outside of the class. Now, if we're in the class itself, and let's just say notice how it suddenly works. That is called scope within the class. You cannot access that outside of this class or this scope. Whenever you see these brackets, think of scope, because it is private. Private is denoted by that underscore. That is specific to this language, so definitely pay attention to that. In most other languages, you actually write the word public or private in front of the type. Dart goes away from that whole concept, but fear not. There is an easy way to set that, and we're going to show that right now. What we're going to do is a getter and setter. So we're going to say, you remember the error message that it popped out with is there is no setter. What's a setter? Well, this is a concept that sprung up about, I want to say 20 some odd years ago. And we're just going to go over it real quick. So when we get something, you're taking something, right? You're saying, give it to me. So we're going to get, and we're going to say footage. And then we're going to do fat arrow, width times length. What have we done here? We're getting a getter. We're creating a getter using the get keyword that is an integer type. The variable is called footage. The fat arrow really basically says we're making an anonymous function here. Because it's all one line, we don't have to break this into like something like this. Int footage return with times length. Yeah, you don't have to do something like that. So we're just going to delete that because it's all one line, right? It's all compact. You can definitely do it the other way, but that's what all this fat arrow really does. It just condenses it to one line. So we're getting that. And we have this anonymous function here. Or is it inline function? Anonymous versus inline. That always messes me up. So let's get our square footage from this thing. Let's actually delete that so it'll run. And we're going to say print house one, oops, footage. So when we run this, you can see this is a large house. Let's scale that down. That's like, massive house. Let's just say this is a length of 50 feet. Actually, 25 feet by 60-foot house. Okay, that's more reasonable. That's about a normal house size here. So how is it calculating? How's it getting this footage? Well, back to our blueprint here. We got our getter. And the getter is saying, hey, whenever you try to access this variable, run this code. And all that's doing is taking our variables, width and length, and multiplying them, and then returning them. Pretty simple. But what if we want to actually set something? We want to set the age of the house up here. So let's do that. Now, we have another problem is we can't access that because it's a private variable. That's where getters and setters work in tandem. So we're going to say int get, and let's just call this home age. That way, no, let's call this years. That way there's no real issue between underscore age and age. And we're going to say return age, and then we're going to set years old value. I want to give it a type there. So what we're really doing is we're saying, okay, when you try to get something out of this, when you're trying to access that, return this, which is actually up here, this private variable. However, when you're trying to set it or save something to, think of a variable as a container, like a little bucket. Remember, a variable is something that will change. The contents of that bucket will change. So when we go to pull something out of that bucket, we're calling get. When we go to put something into the bucket, we're calling set. Think of it in terms of those concepts and it'll make much more sense. Now set and get, you have to have a type here. So we want to pull out of that bucket an integer. And set, we want to put into that bucket an integer. And that's how we're actually doing that. So when we go to pull out of the bucket, this will get run. When we go to put into the bucket, this will get run. That's a very confusing concept if you're new to programming. That's why I kind of really wanted to cover it. So we're going to say house one dot years old equal, let's say it's a 10-year-old house, and then we're going to print house one dot years old. Let's run this, and you can see there's our 10. So here we're calling the setter. Here we're calling the getter. Getters and setters are important because sometimes you don't want to actually expose your variable to the outside world, or you want to control how it's accessed. For example, let's say you want to set this, but you're running a real estate agency and older houses really are more attractive, so you want to add 10 years to that house. So what we're doing here is a little sneaky, right? Because we're saying house 1 years old is 10, but under the hood, in the background, we're actually adding 10 years. So it's now 20 years old. So always think of getters and setters as if you're working with a bucket, and it'll be much easier in your head. And that's why you need to use them, so you can actually isolate that variable from the outside world. So that's great and all. What happens if we have multiple homes here? So let's just make a new house. Let's make a couple of them. And let's add a property in here called, oh, we've already got it, color. And we're going to go back here and we're going to say I want a red house, house2.color. I want a blue house, then house3. I need a good color. I need like a solid color that's just going to stand out. Black. You don't see any black houses. I don't know why. Black's a pretty cool color. I think it'd be really trendy to have like a completely black house. I'd buy one. So, back to our trusty list example with generics programming. Remember how we have worked with, I think, strings and integers in the past. See how it says list, and then the little arrows, and then E? That is the template we're going to be working with. And we are going to say we want to use our house class. Notice how, maybe it's not visible, it's got that little C right here. It wasn't too visible when I'm on it, but it's got that C. That denotes it's a class. So we're going to use the class, not an actual variable. We're going to call this homes equal new list house. Now that statement that we've worked in the past makes a little more sense because we know now that list is actually under the hood a class. And this just means it's using generic programming, which we will use in future tutorials. Now we're just going to say homes.forEach, and in here we're going to say, whoopsie, come on keyboard, work with me here. There we go. We are just going to do our function. I'm going to say value, and we're going to say print value.color. So really what we're doing here is we're saying make a list, and in that list we're going to store homes, or the house class, that blueprint. And for each of them we're going to print out the color. And you can see how it is now, where'd it go? Why did it not do that? There's brown. Print value.color. Did I screw that up? You know it's been a very long day when you just completely forget to do something. There's nothing in our list. That's why it wasn't working. My brain is totally fried. I have bought a house. I am currently doing a lot of stuff at work, so bear with me if I'm a little scatterbrained sometimes. Home ownership will definitely make you lose your mind. I spent all weekend installing these lights. It should have been the easiest thing in the world. After about 1,000,000 cuss words, the lights are installed and working though. There we go. So there's our 3 houses with the 3 different colors. And in there you can access the other properties and things too, like, footage. Things like that. Alright, so that is, in a nutshell, intro to classes. I hope you found this educational and entertaining. We're going to cover these a little more in depth. Be sure to really read up on classes on the official Dart site. And for the source code, go out to my website, voidrums.com, click tutorials, and there's a link to my GitHub repos. I do have it out here as Flutter tutorials, and then I have them as submodules in here, and I'll put in the additional submodules. If you're so inclined, if this helped you, definitely consider donating. This site's run 100% off your donations, and I thank you for watching. Hey everybody, this is Brian, and welcome to the 8th tutorial on Flutter and Dart. We're going to go ahead and continue our conversation on classes. Well, let's actually call this class 2. Well, let's call it classes 2. There we go. And while that's churning away, we're going to look at what we're going to cover today is called constructors. What are constructors? Well, whenever you have a class and you create a new instance of it, something has to happen in the background, and that's what we're going to cover today. That background is called a constructor. It's when the object is actually constructed in memory. And to kind of solidify that main point here, what we're going to do is we're going to go out here and we're going to say new house dart. And I'm kind of doing this unscripted, meaning I do not have my notes. I'm just kind of typing. So there'll probably be some errors and maybe some goof ups. And we're going to keep this class very simple because we're not focused on the class itself, but rather the constructor. So width equals 0 and length. All right, so we've got that, and we need to import house.dart. And we're going to say house1 equal new house. So we've done this before. We know what this is. It's just going to make a new house. What's going on under the hood here is it's looking at your blueprint and saying, what do I need to do? And then it's going out and making a new instance of this. And hold on, let me turn my music down. I can't even hear myself think here. I have to keep music on the background or my headset shuts off. It's kind of like an annoying feature. But anyways, so it's saying, what do I need to do here? Now, it knows what it needs to do by way of what's called a constructor. And every class has what's called a default constructor, meaning it just magically exists. And if you're wondering where it is, it's right here. Boom. So somewhere in there, under the hood, unknown to you, is a function that looks like this. And it probably just says return, would be my guess. Now, all that is, it's called the default constructor, but it doesn't exist in a manner that you can see it. It's under the hood, and you'll never access it. It exists solely for the compiler. Now, if you want to actually play around with it, you can add it in. Constructed. So what happens now is when we run this, you'll see it suddenly says, boom, constructed. Where's that getting called? We haven't changed anything in our main. So it's saying, all right, here's the blueprint we want to use. Here's the name of the variable we want to use. Make a new instance of that and use this constructor. In this case, it's saying use the default constructor. You can tell it's a default because there is a parentheses with nothing in it. That's called the default constructor. To solidify that, we're going to make yet another one. And it's going to say default constructor already defined, meaning it knows that's the default because it's just an empty set of parentheses. Okay, that's great. What do you need a constructor for? What's the whole purpose of this thing? Constructor says, hey, what if you want to initialize a set of variables before you actually use them? In this case, let's say we want to use the width and the length. We don't want those to be 0. So whenever a new house is created, we want to automatically set those variables. And we want to force whoever is using this class to set those variables. So we're going to say int w, int l, and we are going to say width equal w, length equal l. And we're going to print these out. Yeah, fat fingered that one. All right, so when we go to run this now, you guessed it, it's going to crash. Bang. Why? No constructor house with matching arguments declared in class home. Whenever you see that, your first thing should be look for the new keyword, and then you'll see the error right next to it. It says 2 required arguments, but 0 found. Well, how do we know what those arguments are? By looking at the constructor. We have 2 integers we have to deal with here. So let's say we want it to be 5 by 9. Bang. So now suddenly we have a width of 5 and a length of 9. We can actually take that a step further and make this, you guessed it, optional. And let's say this is 5. Let's say this is 9. Well, let's go back to our program here and notice how we've got to actually name them out now. I'm doing this for illustrative purposes. And we want to say we want the width to actually be 6 instead of 5. And it should be 6 by 9. There we go. So that in a nutshell is how to deal with a constructor and why you need one. Now, special note, Dart does not have, at least I haven't found, the concept of a deconstructor. And what a deconstructor is when the class is actually being destroyed. Under the hood, there's this thing called garbage collection. And garbage collection is a very complex topic, but it's very easy to understand. When you are creating variables, right here, the use of the new keyword, you are putting that out on memory, and you're putting it on something called the heap. Under the hood, it may actually be somewhere else, but the heap is just a giant free store memory. Think of it like a giant warehouse. You're basically opening the door of the warehouse and throwing a house in it and saying, here, store this somewhere, I don't care where. The problem is when your program dies or gets shut off or the user closes it or whatever, that house still sits out in memory. So you need to actually delete that. Garbage collection takes care of all that mess for you. All you have to do is say, I want a new house and I want you to put it somewhere, I don't care where, and let me access it when I need it. And then when your program is closed, or if that variable goes out of scope, let's say we have a function up here. And let's move this up here. Whoops. Yeah. And let's call a test. Does the same thing. However, something drastically different is happening in the background here. What we're going to say, and I'm just going to put it in comments here. And then flagged for garbage collection. That's what's really going on in the background here. So when this test function is called, it's going to go up and it's going to say create a new house. Bang. Then it's going to call our constructor, whatever the constructor may be. Then in the background, it goes out of scope. What happens is everything that was created in this scope is now flagged for garbage collection. What that means is it is no longer being used by the program, and the program thinks it's safe to delete it out of memory. Now, if you've ever worked with older languages like C and C++, if you try to access something that doesn't actually exist in memory, your whole program just goes kaboom and crashes. Garbage collection takes all that headache away, meaning you don't have to worry about it. You just have to create it, it'll take care of it, and then when you're no longer using it anymore, it'll get rid of it for you. If your program crashes and dies an ugly death, it'll delete all that memory for you and you don't have to worry about it. Whew. So why does all this matter to you? Because all of this is being done under the hood. Now, there's a special case. What if, and just follow me here, you want to actually do something with this and then close it out? You really should, and there's probably a million other ways to do this, dispose your class, meaning, and this is very similar, it's actually built in, I think, in some other languages. Kill me now. You would call that before the end here. So you would say you may be tempted to do something like that. Now, why would you do this? Let's say you opened a file or a database or a network connection. You would want to actually close it here. So you would say close all open connections or close all the things. That would be a good way to do it. But remember, under the hood, garbage collection is being called. So if you forget to do any of this, it's going to happen automatically, and you don't have to worry about it. That's a very nice concept. There are more advanced topics to it, but that in a nutshell is constructors and deconstructors. I hope you found this educational and entertaining, and thank you for watching. If you're so inclined, you can get the source code for this and other tutorials out on my website. Just go out to tutorials, click on the tutorials link and go out to GitHub, and I will have all the code out there. Thank you. Hey everybody, this is Brian. Welcome to the drumroll. Where are we? We are on the 9th Flutter tutorial. We're going to continue our conversation on classes here. Did have some interesting feedback from this guy here, President 1. Dart is dead. Why are you doing tuts on this? I actually don't think Dart is dead. I think Dart's actually just getting started. I think it's very new and very in its infancy. And I'm hoping Google grows it quite a bit. So that is why, kind sir, I am doing tutorials on this. So we're going to continue our conversation about classes. If you're trying to follow along with the official documentation, we are on extending a class. So extending a class, use extends to create a subclass and super to refer to the superclass. What in the heck does that mean? Well, we're going to cover that over the next 3 tutorials. And I'm going to do a little bit here. I'm going to actually cover how to extend a class, abstract classes, and mixins. But we're going to have to kind of break it up into a few tutorials. So let's just get going with this one here. And let's do next. Got to adjust my office chair here. What's up with that? And while that is calculating the meaning of life to everything, I'm going to actually adjust this chair. Man, it's like driving me nuts. All right, so what we're going to look at here is classes and inheritance. And you may have heard of inheritance before in other languages. So the first thing we're going to do here is we're going to make a new Dart file. We'll call it mammal. And in mammal, we're going to make a class. And we're going to say bool has backbone. And we're going to make another bool has hair, because a mammal has to have a backbone and hair. And there is our beautiful mammal class in all of its glory. So what we want to do now is actually make another one. And we're going to call this feline. For all you cat lovers out there, we're going to import the mammal class. And we're going to say class feline. And this is where the extends keyword comes in. Extends mammal. So what have we actually done here? If you're not familiar at all with inheritance and what I'm talking about here, is we're extending this class. It used to be, the keyword used to be in other languages inherit, or it was just a semicolon. So what we're doing is we're taking the mammal class and actually adding to it or extending it. So we're going to say bool has clause. True, because most cats have claws. And then we're just going to make this void test. We're going to say assert. And you notice how IntelliSense is smart enough to know what's going on here. Has claws, has backbone, has hair. So you can see the other properties here. So we're just going to assert that this has a backbone. And we're going to assert that it has hair. Now what assert does is it actually throws an error message if this tries anything and it doesn't evaluate to true. So that's just a test function we're going to leave in there for now. But what we're going to do is take this even further and show you that you can do some really cool things with inheritance here. So now we're going to take our feline class that we made. We're going to make a class, we'll call it lion. And we're going to say void roar. And let's just do this. So tomorrow is Thanksgiving while I'm typing here. And I'm actually kind of nervous because I'm cooking a turkey for the first time. Yeah, it's going to be interesting here. Some people have told me to cook the turkey upside down. Some people have told me to not stuff it. Some people have told me to stuff it. Some people have told me to do all of these crazy things. One person told me to get like a surgical syringe and actually inject things into it. I'm guessing that's how you actually like calm down your guests. You just like inject like some sort of sedative into the turkey. All right, so what we're doing here is we've got our test, and we've got our roar function. Now let's actually just test this whole thing out. Let's get rid of this. And let's say lion, Simba, why not? Is that actually how you spell Simba? Oh well. Equal new lion. And we're going to say Simba dot, and you notice how, bam, it has all these other properties here. So we can actually call test. We can actually make him roar, although I don't think Simba would roar, but come on, keyboard, you can do it. I believe in you. And he's roaring, and the test ran. We can actually go back here, and this is a tricky thing about inheritance. Let's say back in the mammal class here, we flip this to false. Then we're going to say not all mammals have hair because I'm changing everything. Well, you can see how feline's test is now going to just explode. Lion's test is now just going to explode. So let's run this and see what happens. And you can see unhandled exemption, failed assertion, meaning our assert statement evaluated to false, has hair is not true. And it's saying line 7, number 12. So there's 712, bam, that's where our issue is, right here. And then we can kind of do this, and you can see how it's in lion test, da 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 da. What we can actually try here is play around with what's called the super class, and we can say super, whoops, dot test. So what is this actually doing? Super actually grabs the class that you're extending, in this case feline, and it's going to call test here in feline. So let's actually do this, print testing in feline. And let's do this. Print testing in lion. That way we know exactly where this is coming from here. And you can see how it's testing in lion, testing in feline, because this is being called, but then we're calling super.test, which is actually calling in feline. Now, this assert function is actually failing right here. It's saying blah, 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 line 9, 12 is not true. And we can see how it's calling feline test right here. And it gives you the path to the file. And I think, yep, you can actually click on it. It takes you right to it. So you can follow, this is called a trail here, if you will, or a stack trace. You can see that it's being called here, it's being called here, and finally, boom, that's where the error is being called. So that is the tricky part about inheritance, is if you make something and other people inherit classes and extend them, you can really break a lot of things. And so you have to be a little careful, and you have to almost not trust what you're extending. And that is where overrides come in, right? So we should just put override there so we know what we're doing here. This is just a declaration telling us that we're overriding this. What we could actually do is we could actually put a setter in here and set that to true. But I'm not going to mess around with it. I want to leave this as is so you understand some of the pitfalls that can happen when you're doing inheritance. So to kind of recap here, we have our lion class. The lion inherits from feline. Feline actually inherits from mammal. And let's flip this back to true. That way if somebody downloads the code, it's not going to have an error and I don't get 100 hate mails. So what is mammal really doing here? Mammal is considered the root superclass, if you will, meaning it's not extending anything else. It's just the base class, if you will. All of these properties then flow up through all of the other things that are inheriting it. So that is inheritance in a nutshell. Short, simple, to the point, but a very powerful feature. You can do a lot of cool things with this, but you can also paint yourself into a corner. So definitely structure your programs well. That's it. Thank you for watching. I hope you found this educational and entertaining. If you're looking for the source code for this and other tutorials, go out to my website, boydrums.com. You can go out to GitHub and download all the source. Also, there is a Voidrum's Facebook group with 1,700 other programmers out there that can definitely help you if you have any issues. Hey everybody, this is Brian. Welcome to the, what are we on, the 10th Flutter tutorial. We're going to talk about abstraction today. So what is an abstract class? Use the abstract modifier to define an abstract class, a class that can't be instanated, meaning you can't make an instance of it. Abstract classes are useful for defining interfaces. What is that? What are we talking about here? So there's a few key concepts we have to understand. First, an abstract class cannot be created. You can't use the new keyword. Second, we're going to be defining something called an interface. An interface, just think of that simply as a contract. So when we look at, this is the previous tutorial, we had the mammal class, which has backbone, has hair, and we're setting the value actually in the mammal class. The problem with that is when we change something down here, it blew up the entire stack. So if we changed it here, suddenly feline stopped working, lion stopped working. We're going to fix all that today. So let's just go new project. We're going to make a new Dart console application. We're going to call this classes. Yes, let's do this window, and that will calculate the meaning of life and everything else. All right, so let's just get that out of there. Somebody emailed me and said, hey, stop complaining about how slow that is. Mine's really slow. So we're going to make a new, you guessed it, mammal file. And we're going to say abstract class. And we're going to say bool has backbone. Oops. I've got weekend on the brain. It's technically my Friday. It's the day before Thanksgiving. I'm just kind of cranking out a couple tutorials here. And avoid speak. So what is going on here? This looks like a normal class, but there's a few minor changes. The abstract puts the abstraction to this class, and then we have some elements here that don't have a value. That's actually part of our interface. What we're saying is anything that inherits this class has to include these. Think of an interface as a contract. It's a lot like buying a car. So let's go out and say feline. My office chair is driving me nuts. Sorry about that. Mammal. And we're going to say abstract class feline. Whoops. Extends mammal. So far, nothing's really changed here, right? Bool has claws. Let's play around with this and see what happens. Let's actually go out to our main, and we're going to import that feline class here. We're going to say feline, call it cat equal new feline, and uh-oh, we already have a problem. As you have suspected, abstract classes cannot be created with the new expression. We can't instantiate them. Can't make a new instance of it. So how do we actually do that? Well, we have to make a concrete class here. So let's actually go file new. We're going to make a lion class here because why not? Whoops, lost my place in my notes here. All right, so in our lion class, we're going to actually import the feline. And then we're going to say class lion extends feline. Whoops, that is not what I wanted. There we go. Now it's giving us some sort of other issue. It's saying, okay, missing concrete implementations. Because this is a concrete class, not an abstract class, we have to actually now implement that interface, or actually interfaces, because this is an inherited interface. So when we mouse over here, you can see that it has claws, has backbone, has hair. So it's missing the implementations from feline and mammal. And you can actually right click on this, go to generate, and then implement methods, and you can see exactly what it's missing and what it's from. You can even double click and create it, which I'm not a big fan of because I don't like the way it does it. But if you're curious, it just looks like that. So we're going to say bool has backbone And we're going to actually implement this now. Bool has hair. Bool has claws. Misspelled has twice. Wow. So we have everything that we need now. We can actually make an instance of this thing. So let's change this. We can now actually make an instance of this thing, and we can actually dot speak and see what we want it to do. Now, I've never heard a lion say hello world, so we're going to change that a little bit here. We're going to go in here and we're going to say we're going to make the lion roar instead. So you can see how it's very similar to actually just inheriting and extending a class, but there's some key caveats here. First off, you're not setting this value in the abstract class. You're not setting the actual getter. So that's called an interface. You actually have to have that in your concrete class. Without it, it will actually generate an error. See how suddenly it's complaining, missing concrete implementation of mammal.hasBackbone. You would do that for certain things. For example, if you're building a car or a truck, not all cars have all the same features, but you want certain things that make up a car. Car has 4 wheels, for example. Car has a windshield most of the time. If you pay extra, usually it has a windshield. So the other key component here that we're missing is you can actually do some really cool things with abstraction and interfaces. So we're going to actually make another file here and call it a bird. And we're going to say abstract class bird. And we're going to say bool has wings. Now let's just get a little crazy here. Let's make another one. Scorpion. I don't know what that thing's called on the back of a scorpion. I just call it a stinger. Why not? So what are we doing here? We're just making abstract classes. We're actually making interfaces. So we're going to make a concrete class now, and we're going to call it monster. We're going to actually build a monster here because that's just how cool we are. We have nothing better to do. We're going to build a monster. So we're going to make our bird, or we're going to import our bird. We're going to import the scorpion. And we're going to actually import the feline. And this is an example of interfaces. So I'm just going to put that in case anybody's wondering. So we're going to say class monster implements. And we're going to say bird, feline, and scorpion. So now we've got multiple inheritance going on here. But as you can tell, we also have multiple things that we're going to have to make concrete implementations of. So we're going to say bool has stinger. Yeah, let's give our monster stingers. And let's say bool has hair. Do we want a hairy monster? Why not? And through the magic of copy and paste, we're just going to do a couple of these. So we're going to do that, and then we're going to say I don't know what noise a monster would make. I mean, some gobbledygook, I don't know. That's a monster noise, ladies and gentlemen. That's what that is. All right, so what are we missing here? Has claws and has hair. Oh, yep, because we misspelled this. All right, so now we've got our monster class. You can see this little icon over here, and you can actually see implements method has clause in feline. You can actually click on that, and it'll take you right to the implementation of it. All right, so let's go back to our monster here, and let's go to this chair. Man, my whole little office here is just falling apart. All right, so monster. What do we want to call our monster? Let's call it the Babadook, if you've ever seen that movie. It's kind of a crazy movie. And we're going to make the Babadook speak. And why not? Let's just run this, see what happens. Bang. So there's our lion, and there's our monster making some crazy noise. A lot of work, great, but what has it really bought us? Well, we now have two different extensions of this feline class in lion and in monster. And you can see how we have multiple inheritance going on here. And notice the use of the implements keyword here. That is key. If you try to do extends, that's a different thing. It's kind of hard to really explain, but when you're extending a class, you're extending the class. You're taking it and making it more. When you're implementing it, you're actually implementing it. You're saying, I'm going to follow the directions. So really we're just using, drum roll, you guessed it, interfaces through abstraction. And what has it bought us? Well, we can actually say we don't want our monster to have hair. And when we run, there's no error. Where if we had done this through pure inheritance and we put has hair all the way back up in mammal, because we inherit feline, this whole thing would have just exploded and it would have said nope, assuming we would have done an assert down here. Whew, that's a lot of talking. But as you can see, you can do some really just crazy, outlandish things. You can make like a airplane that's also a refrigerator, or you can make a car that's also a helicopter. So that's it's a really good example of inheritance, class abstraction, and interfaces. For the source code for this and other tutorials, I encourage you to visit my website, voidrealms.com. Click on tutorials, and drumroll, there is a Void Realms Facebook group with 1,700 other programmers in it. Go ahead and click that link. It takes you right to it, and ask to join. Hey everybody, this is Brian. Welcome to the 11th Flutter tutorial. I'm hoping we can wrap up classes today. Not going to really cover enumerated types because it's kind of a little different, but what we're going to cover today is mixins. Let me back up. When I say enumerated type is kind of different, it's more or less used as a variable. We will cover these in future tutorials, but right now we're going to really cover mixins. So what is a mixin and why do we need it? So it says mixins are a way of reusing a class's code in multiple class hierarchies. To use a mixin, use the with keyword followed by one or more mixin names, and then some examples. And I kind of wanted a better description. So a better description is in object-oriented programming languages, a mixin is a class that contains methods for use by other classes without having to be the parent of those other classes. So you kind of take inheritance as a fundamental hierarchy and you break that. And it's not really interfaces with abstraction. It's kind of like just saying, hey, I don't really want to use the whole class. I just want this little part of it, meaning I don't want to really inherit it and I don't want to have to be tied to it. It's kind of weird. So let's just make our new project here. And this will calculate the sun, moon, and stars. There we go. go out here. Did my music stop? I think my music stopped. Yep, I'm still listening, Pandora. Thank you for doing that, Pandora. All right, so back to what we're working on here. We are going to make a car. We're going to make a concrete class. And we're going to say int doors. Make a getter for this. We're going to make a black car because why not? Black's awesome. And we want to play music in our car. And we're just going to say boom, I don't know, just music, whatever. So we've got 4 doors, it's a black car, and we're just going to play some music. All right, so pretty simple class, not a whole lot to it. Now we're going to make a truck. Going to make this concrete as well. And we're going to say bool has 4x4 because you need that with a truck, especially here in Michigan. Give this 2-door. We're going to say string color. I want a... what color truck do I want? Let's make it a red truck. Giant, big, red monster truck. And we're going to say void. I'll honk the horn. Why not? So we've got a car class and we've got a truck class. Now let's say we want to make a hybrid of those. We want a Jeep. Actually, let's call it an SUV. I owned a Jeep for years and years and I loved it. So in this we're going to import the car class and we're going to import the truck class. We're going to make another concrete class called SUV, and we're going to extend the truck, but this time we're going to say with the car. What the heck? What's that mean? Alright, so let's see what we got going on here. Color is inherited as a getter and also as a method. Ooh, I screwed something up here. See, there's color. Oh yeah, that's why. There we go. Fix that problem. Alright, so our SUV here extends truck with car. What does that mean? Well, that's interesting. Let's find out. In here we're going to import the SUV. We're going to say SUV Jeep equal new SUV. And let's just examine this object and see what we got going on here. You can see how we have colors, doors, 4x4, it has a bed, it honks the horn, plays the music. It does all the things that we want it to do. So we can actually say, you know, honk the horn, Jeep dot play the music, and let's say we want to print the number of doors. And we want to print the color. Let's see what happens here. So we honk the horn, we play the music, we have 4 doors and it's black. Well, where did it get 4 and black from? That's interesting. Well, if we look at this, you can see we're extending the truck with the car. So if we look at the car has 4 doors and it's black, so that's where it's getting that from. If we flip those around, you guessed it, we're extending a car with the truck. It will now have different properties. It'll now have 2 doors in red. So that's really how a mixin works. You can kind of piecemeal classes together and use the parts that you want without really having to mess around too much with interfaces and inheritance and abstraction. It's kind of I'm not a big fan of it, to be brutally honest with you, because as you can see, if you do things in a specific way, you can change the outcome of what you expect. Like, I'm going to flip this back to truck and flip this back to car, and then bang. So, you really get some unexpected results sometime. Now, some would argue, well, you know what results to expect because of, the way you're ordering things and all that. Let's just, for giggles here, I'm actually just going to try this. Let's say, I have no idea what to call this. Industrial. We're going to make an industrial vehicle. And we literally are just going to copy this car class here. And we're going to say this is, what haven't we used? Blue. And we're going to give this like 900 doors. And of course, there's no way to play music in this thing. Let's go back to our SUV. Whoops. It's funny, I always get this viewer feedback where everybody's like, we actually like watching you make mistakes. We learn from your mistakes. I'm like, you guys are so mean to me. So now we're extending the truck with the car and the industrial equipment. Let's see what this does here. We'll run this. Suddenly it's got 900 doors and it's blue. So the problem here is that it's picking up the last one. Now, I'm not sure if that's actually a standard or if it depends on what sort of just-in-time compilation you go through. So if you get a different vendor's just-in-time compiler, it may take the first one and not the last one. So now you've got to actually account for those and make, functions that do that. You should actually say string color equal, I have no idea what to make my Jeep here. Lime green. It's like the ugliest color on the planet. And then you should actually say int doors equal, and we want 3 doors just because why not? We'll say it's an old Jeep and one door is messed up. Now suddenly we have the way we want it. But you can get some just kind of crazy unpredictable results with mixins. It's not bad to use them. I don't want to deter you from it. It is an option. A lot of older programmers will stay away from them simply because they like the structure that inheritance gives, or they want to know what an interface is. They want to know that they have everything that's in the interface that you're providing, because an interface is a contract. Whereas a mixins, it's just kind of, Wild West. You just do what you want. So I hope you found this educational and somewhat entertaining. We're going to continue on with Dart. I'm trying to plow through these fairly quickly because I really want to get into Flutter. I really think that Flutter is going to take off in the next year or two, and I think it's going to be a major competitor with the other languages out there, especially things like React Native. So if you found this even remotely helpful, go ahead and visit my website and go to tutorials, and you can download the source code for this and other tutorials. Click on Contact and go out to the Void Realms Facebook group. There's 1,700 other programmers out there. And in case you're wondering, all of the website and everything is funded 100% by your donations. When you look at my dashboard, estimated revenue is $0. I do not have monetization on any of my videos. So if this helped you guys, especially if you're running a business and you're training your people, feel free to donate and help others. Hey everybody, it's Brian. Welcome to the 12th Flutter tutorial. We're going to continue our journey on learning Dart. Now, one thing you should know is that we skipped something here. We went from control flow statements to classes, and we skipped this exemptions. And there's a reason why I did that. A lot of tutorials out there will talk about exemptions and say, exemptions are classes, but we'll cover classes later, which means you are completely mystified and confused by exemptions the whole time. I wanted to reverse that and talk about classes first. That way, during this tutorial, there should be zero misconceptions about what's going on under the hood, and we can actually work with the advanced code rather than jumping back and forth. So, without further ado, exemptions. Dart provides an exemption and error types. And there's a distinction between the two that you really need to understand here. So the exemption class is basically it's information that we are conveying, where the error class is an error object that represents the actual failure that we should have avoided. So that's kind of the distinction between the two. And Dart has a little bit of, I shouldn't say a little bit, a couple predefined subtypes, and you can actually build your own, which we're going to do in this tutorial. To do that, not just build your own, but to just handle errors in general, you have to know how to throw errors and how to catch errors. Think of it like playing with a ball. You ever play, with just like a baseball or a football as a little kid, you throw it and catch it. You have to understand that program execution is very linear, meaning if at any time it breaks, your program will stop. I'm sure you've seen programs that have completely died. All right, so what we're going to do first is we're going to say, we're going to catch an error. Now, usually when you catch something, it's not a great thing, right? So we're going to say test A, and then we're going to print, and let's say, we're going to intentionally make an error here, just because I want to show you what happens. Now, if you see this, you can tell that somebody ran out of coffee. There was some issue going on. Not only is this not even a variable, but it's undefined completely. We don't even have a test class in here anywhere. So let's just run this and see what happens. First off, you can see the actual application is really trying to warn us, hey, bad things are going to happen if we do this. But if we actually just run it, you'll see that, boom, whole thing just explodes, and life as we know it has, ceased to exist. No top-level getter or setter, test, declare. The entire application just hard crashed. We can look at the stack trace here, and we can see, tracing it back up to here, this is the reason why. No such method error. Now, that's a keyword right there, error. We were just talking about exemptions and errors, and the error is the actual thing that happened. So, really what is going on under the hood here is there is no such method. And that's, kind of preceded by the error name here. So that's the typical format for errors. You'll be able to see, division by zero error, catastrophic failure error, blah, blah, blah. There's any type of error you can imagine, but that's really the naming convention. And we're going to make a custom error. Before we do all that, we're going to actually learn how to catch these things. So first thing we're going to do is I just want to print some things out here. Oops. This may look a little weird at first, but just trust me on this. Whoops. All right, so this probably looks a little bit crazy, and we're going to go over this in depth because this is kind of the bread and butter of this tutorial here. And then we are just going to say done. So we know this is going to crash because it's got the same code in here. What we're going to do is we're going to wrap it around what's called a try, catch, finally block. So here's try, here's catch, and here's finally. These do three distinct things. Try will try to do something. For example, try to run a marathon, try to get a new job, try to find a wife or a husband or whatever you're doing, try to bake a cake. Catch means that an error was thrown and we need to catch that. Think of it like a big fishing net. It's catching the problem. And then finally does not care what happened up here. Finally is just off doing its own thing, saying, okay, I don't care what you two are doing. I want to do it my way. So if you want to execute code, and regardless of whether or not there was an error, you would put it down in finally. So let's run this. And you can see, sure enough, starting, trying, error, no such method error, same error. And then we've got our error message with the rest of it. And then tried, calling, test. And then finally we're done. And you could actually just, get this right here. Say, we just don't care about that error. See, error, don't care. So we're just going to keep going on. And our program finished with exit code 0, which means that it did not crash. It ran fully. It did exactly what we expected it to do. And life is good. Some things you should know about this, though. It is very bad programming to make what's called a silent error, meaning nothing happened here. Because if that error became catastrophic, it could potentially crash your program. So it's always good to either log or let the user know or do something. That's why randomly sometimes when you're using a program, you'll see a message saying error occurred, blah, 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 and you're like, I don't care, leave me alone, I just want to do my work. But that's the programmer's way of telling you, hey, something under the hood went boom, and you should be aware of this. So that is how you catch an error. Now we're going to actually raise an error. And this is actually a little funky if you've never done it before. All right, so we're going to do our try catch block here. If you're wondering what this E is, the E is an automatic variable. It's actually a representation. It's the error class, or the actual, I'm sorry, not the error class, the exemption class that's in memory. And we're going to show how to build one of those here in a little bit. But right now, I just want to flesh this bad boy out, so bear with me here. All right, so we've got our try catch block in all of its glory. And we're just going to do some simple logic here. We're going to say if A not equal B, then throws a special keyword. And then do. Wow, that's bad when you misspell do. I'm still in a turkey coma. Yesterday was Thanksgiving, and I'm just like not with it. All right, so we're going to catch the error. And right now, this is what's called a silent exemption because we're not doing anything with this. So we want to actually fix this problem here. Something went boom, and we want to, just because, actually print out our error message and print complete. Completer, is that even a word? Completer. And let's actually just, while we're in here, fix the problem. Wow, I wasn't playing around when I said I was going to make a lot of errors in this tutorial. All right, so we're going to, geez, there's even another one up here. All right, so we're going to call this out, and let's just comment this guy out here. So we know that because those numbers are not equal, that it's going to throw this error. Now, if you look at that, you're going to stop and say, Brian, that's not even an exemption class, that's just a string. You're absolutely right. In Dart, you can throw any type of object you want. That will be, I think, under the hood, it gets wrapped into their exemption class and bundled up nicely and converted into a message. I think all it really needs is a toString function under the hood. All right, so let's run this and find out what happens. And it says something went boom, not the same. So that is how you throw an error. Now, why would you want to ever create an error? I mean, why are you intentionally doing this? It's simple. Sometimes you want to know that something bad happened and you cannot continue execution. For example, let's say you're trying to open a file, but that file does not exist. You would throw a file not found exception or a file not found error and say, hey, boom, file not found. A big ugly message pops up on the screen and the user goes, oh crap, wrong file name. So one thing you should also know is that you can actually cascade error messages. So let's make a void internal. And we're just going to say throw nope. Program just doesn't feel like working today. And in here, we are going to just call the internal. And let's see what happens here. Let's comment this out. Now, when we run this, boom, it crashed. So we're calling outer, as you can see here. Outer's calling internal. Internal actually throws the error. So you don't actually have to catch the error where you're throwing it. That is where some tricky programming comes in. Because you never know where an error is actually going to come from. So that is how you would actually catch that. See? Program failed. What I'm getting at here is sometimes you'll use classes and libraries and things that other people have built, and if an error occurs or an error is thrown, you may have to actually catch those. So you may not know that the error could potentially exist, but you're going to have to deal with it at some point. And that right there can get to some real headaches. And that's actually one of the biggest biggest reasons why programs crash. It's you rely on somebody else's code, you're not fully comprehending what's going on under the hood, and then problems ensue. All right, so let's just say we want to create our own error object here. So we want to implement the exception class, and we want to just kind of flesh this out. Say final string, we want a message. And we're going to make this optional just because. We're going to override this. Whoopsie. Fat fingered that one. Very simple. I mean, very easy. You can make this extremely complex. We've had our conversation about classes and flow control, all that. You can do a whole lot of stuff in here, like maybe a custom thing you'd want to do is dump this to an error log. Maybe you would want to pipe it out to a website. Maybe you would want to take corrective action and fix something or pump something out to a database table. But for this example, because we haven't covered most of that, we're just going to make it very simple, very easy to work with. So we have our color error. Let's close that, close that. So now we're going to import our color error, and we are going to make one horrendous, ugly looking piece of code here. Now I did promise we would cover enum, so let's actually, without further ado here, whoops, we're going to make an enum and we're going to call it color. There's a reason why I didn't make an entire tutorial just on enums, because they are just dead simple. So an enum is basically a enumeration of something, an enumeration of values. It's a zero-based index, so this is 0, 1, 2. And it's super simple to work with. And we're going to say void cats because I like cats. Then we're going to say color. And let's call this color. Notice how the upper and lower case are two distinct things. And we're going to say try. And then we're going to say catch. And finally, now here we're going to actually check. And we're going to say if color not equal color dot, and then notice here's our enumerated values. And the values is actually in there as a function. You can get a list of colors. We've talked about generic programming a little bit at a high level. It's going to be probably actually the next tutorial. But you can see how we have a list of colors, much like in the past we've had a list of strings or integers. So if the cat is not black, then we're going to say throw new, whoops, cat error. Why are you not picking that up here? Oops, it's not cat error. Geez, color error. Told you Thanksgiving got me all messed up. Must be black, because black cats are pretty awesome. Some people think they're bad luck, but I had black cat for years and years. He was probably the best cat I ever had. And then we are just going to leave it at that. And we're going to say print So if we do a brown cat, why not? Everybody likes brown cats. Run this, you can see that unknown error must be black, and probably would have done that. So we can see that nothing really happened here. Let's actually just pet the cat. Whoops. Let's run this again. You can see how pet the cat never gets printed because we had the unknown error of must be black. Now, this is a problem. Why is this an unknown error? We actually know it's an error because, well, we threw it. So what we're going to do here is we're going to add another called on. Oops. We're going to say on color error. And what we're doing here, whoops, we missed a little bit of verbiage here. We need to do something with that. So on color error, catch, there we go. We're going to catch the exemption. And then we're going to say print, you selected the wrong color. So what we're really doing here is we're saying, hey, we want to know that Brian is horrible at spelling. We want to know what type of error. And so you can actually create your own error types here using error classes. And let's actually make another error here just because, and we'll say cat A, and we'll do our faithful little error here. There's no cat type, therefore, we know it's gonna extremely explode here, and that would be a programming error anyways. So you selected the wrong color. Let's actually make this black. Now our little program should work, meaning it should pet the cat, but then we've got this guy right here. Let's see what happens. Bang, suddenly we get an unknown error. So that is a good example of a couple things. A, how to use an enumeration or an enumerator. B, polymorphic programming. We see that this algorithm does two distinctly different things based on the input, and how to use custom error handling. It can get much more in depth than this. You can make just dozens and hundreds of these. Typically what I do is I will write a function, and then in every function, especially production quality code, will immediately be wrapped with a try catch finally, and then I will put my specific error cases exactly how you see in this tutorial. That way if I expect like file not found or disk space full or something like that, I know exactly what happened. And then I always have a catch-all at the end. That way if something completely out of left field happens, my program doesn't crash. It just says, hey, unknown error occurred. So that, in a nutshell, is error handling. I hope you found this educational and entertaining. Be sure to check out my website, voidrealms.com, for the source code for this and all other tutorials that I'll be out in GitHub. In case you're wondering, I actually gotten quite a few questions about that. I put a lot of tutorials out here, and when you click the link, it actually puts them in as tutorials. So I've got like Qt, Java, Python, Flutter, blah blah blah. If you just crack it open, you'll see the lessons are in there. These are all submodules, so you can go right into the submodule and get the actual code. If there's no code, it'll just have a README file. I try to keep it in there, that way I don't get the, hey, you're missing this, you're missing that. Last but surely not least, if this was even remotely helpful, feel free to donate and go out to the Void Realms Facebook group. There's 1,700 other programmers out there that are willing to help you. That's it. Thanks for watching. Hey everybody, it's Brian. Welcome to the 13th Flutter tutorial. We're going to continue down our Dart learning curve here. We have to learn the Dart language before we can work with Flutter. And we're going to talk about generics today. And we've actually worked with this before. Whenever we've made like a list, like you can see this little snippet of code right here. And it's actually as the arguments in every single program we've made so far. So we can do something like list. So I had that E, so we have to define type. And we'll say things, new list. And then we can add things in there. Now, we could have also said string or bool or whatever we wanted to do. So why do we need generics? What's really the value here? Well, let's say we wanted to make a function, and let's just say void add. And void, we want to just take something, let's just say a string, and we want to just add it. So let's actually come back here. Whoops, not string buffer. Jeez. All right. We just want to add it here. So we're going to say return value +1. But now let's say we want to take the same thing and we want to do it with integers. So now we've got to rewrite this whole darn thing. And now this isn't a string, this is an int. And you can see how now it's complaining that it's already defined, and so now we got to turn this into add int, and then turn this one into add string, and then we'd have to know which one to call, and you can see how it gets very confusing very quickly. So yeah, we're not messing with any of that nonsense. What we're going to do is we're going to use generics. And what generics allow you to do is they allow you to actually take the type and turn the type into a variable, if that makes any sense whatsoever. And we're going to actually discuss this, but if you read through their examples, they're actually very helpful and very insightful. I went through that section in probably about 10 minutes. It was super easy to understand. So we're just going to dive right in. And we're going to say log. Now we want to put these little arrows here. That means anything in these arrows is going to be a type that we're going to use for generics. And we can use that in our program now. And we're just going to print value. So what effectively have we done here? We've said, hey, we're making a method called log. We want to use generics, so we're going to have a type. That type will change. That's what I mean by that's a variable type now. So that type will change. And here's our actual variable, which is going to be of whatever type we shove in here. And it's just going to print it out. Print takes an object, so it won't actually freak out on us. So now we can say print, we can say hello, or we can even say print and some number, and they both work. See? Down here we've got hello and then whatever number that is, giant long number. My laptop made some weird noise. That kind of scared me a little bit. It was like It's kind of like Godzilla. It was weird. Anyways, so that is a very super simple example. We can now put anything we want in there. So let's say we want to actually restrict the type. Let's go back to our addition. We're going to say add, and let's say t extends. And we want to extend the number class here. Now we're not doing inheritance here. That's the confusing bit. What we're doing is we are saying that anything of the t type has to inherit from the number class. Now when I say the t type, I mean this guy right here. So anything that we put into this has to inherit or extend the number class. So let's go ahead and finish this out. We're going to say return value +1. So what we can say now is print, we're going to say add, I'm just going to say 1, and this should print the number 2. And there it is, number 2. So if we take this and we now try to do something like this, you can see how it's already mad at us. It's saying an argument string cannot be assigned to the parameter type num because it knows it has to extend the number class. And if we try to run it, of course, it just explodes on us and says, nope, can't do it. And it even tells you why. Type int is not subtype of string or other where, and then it just shows you. So that is one way of limiting that right there. So let's get a little more complex here. Let's actually work with a class. And I know I say complex, but this is actually just dead simple to work with. And I'm almost embarrassed making a tutorial on this because it's so easy to work with. Other languages, generics, get very complex very quickly, but Dart makes it very simple. I think they kind of borrow some of the best parts of other languages, but that's just my humble opinion. So we're just going to have a dog class. The dog's going to speak, and then we're going to make a new class. We'll call this stray, which is like a stray dog kind of thing. I'm going to import the dog class. And this stray is really not going to do anything. I mean, we're not going to have any properties in it. And then we're going to make a trainer class here. And we're going to import the dog class because we're going to be working with that. And we're going to say class trainer, and we want to have our generic type in there. And in here we want to say, okay, void add, and we want to have our t value. And whoops, I missed a step here. It doesn't make much sense what I'm doing if we don't have this. So what we're going to do is just make an internal list here, and this is not uncommon for a lot of programs. All right, now this will make a little more sense what we're doing. Then we're going to fat arrow this into animals, add, and we're just going to add the value there. So we're going to be able to add remove to that internal list, and then we're just going to say void train. And if you have no idea what I'm doing here, I encourage you to watch my previous tutorials. We're just going to do that, and then we're going to say for int I equals 0, I is less than 3, because why not? And then going to increment. So now we're going to say value dot speak. This looks weird. Let's talk about this. Okay, so what we're doing here is this is our generic class. The dog is just a normal class. The stray just extends. Whoops, we actually didn't even do that. Extends the dog class. And then the trainer itself is just a generic class. Now, when I say generic, I mean it's using this. And you can see internally we're using this list, and we're actually using the same type. And we're just going to add and remove values to that list, and then we're going to work with that list. Now you notice how instantly it's saying the method speak isn't defined for class object. What does that mean? Well, it means that we actually have never defined this. We haven't said what it extends, so it's going to automatically extend the object class, which is the base class for pretty much everything in Dart. The base class object does not have a method called speak, which is why it's saying, ta-da, object doesn't have that method. Now, let's try to work with this and just see what happens here. And let's say, and whoops, I don't want dog, I want stray. Now we are going to make, you guessed it, a trainer, and we're going to say, trying to think of a good name. That's why I'm like sitting here for a minute going, let's say stray, and let's call him, why not? Let's call him Bob. And then let's do this. Oops. Bob.add. We're going to add Fido into this. So Bob's going to train Fido, basically, is what's going on here. So we are adding Fido. We're going to train all the dogs in the list, and then we're going to remove Fido because Fido has been trained. And let's see what happens if we run this. And it says, woof, woof, woof. So now back up. Wait a minute. What's going on here? Notice how we've done a couple things. We haven't added the generic, or we haven't added the type in here. But Dart was smart enough to know that because it's here, we're doing it. Also, in the trainer class, it's still saying method speak isn't defined. This is a perfect example of what's called polymorphic programming, which means that your program changes based off the input. If we were to put a integer in here, it's going to die because integer doesn't have a speak in here. And let's actually try that. Let's say let's say 1 and 1. That's probably not going to work, but let's try it. Yeah, see, boom. Class int has no instance method of speak. So the same code did work, but didn't work. If you kind of follow what I mean, it works for what we programmed it for, but it didn't work for integers. So what we need to do now is go back in and modify this a bit. And you guessed it, we are going to say extends the dog class. Now suddenly it clears up and it knows that, hey, dog and anything that inherits from or extends from dog actually has that. So now this should just work fine. Woof, woof, woof. There we go. So just some little caveats is you should be a little careful with generic programming. It's a bit of an advanced topic. A lot of questions that I get when I talk about generic programming in other languages is why? I mean, when do you actually use this? You'll see a lot of generics in core libraries, things like lists, for example. So if you're making a program that takes plugins, for example, you would have a base plugin that all other plugins would extend or inherit from. And in your generic programming, you would, just like we did with the trainer here, you would extend that base plugin. That would be a really good example. Another thing would be like if you're making like a music player, you would have a generic class called song or file or whatever, and everything would extend upon that, and then you would have your base methods in there. So another question I always get is, how do you have more than one? Like there's T. What if you wanted like a couple? You just simply separate them by commas like that. We have E and H in there. Now we could use E and H, but then you have to, in our file here, you can see how they're suddenly exploding. We would have to say int and string, and they would have to match up. Whoops, probably help if I spelled string correctly here. Yeah, really screwed that one up here. Sorry, guys. And then you would have to, obviously work with the extra types as needed. But I'm going to get rid of those because I don't want them to be part of the example here. Just remember that generics are a bit of an advanced topic. And really, it's a powerful tool. The problem with a powerful tool is that when you hit yourself in the foot with it, it's going to hurt a lot worse. And you'll get some weird errors like this value speak. Like if we didn't extend dog, if we just let it extend object automatically, and we throw the wrong value type or the wrong variable type in there, suddenly the program starts crashing and we're trying to figure out why. So just be mindful of that. As always, I thank you for watching. I hope you found this educational and entertaining. There is a Void Realms Facebook group with 1,700 other programmers out there. We can help you with just about anything you need. Very good group of folks. I'm constantly asking questions in there. And the source code for this and all other tutorials is out on GitHub. You can just simply visit voidrealms.com and the link to the tutorials is right out there. I should mention, we did have a nasty bug with our group where if you try to join, it said you don't have permissions to modify the group. We have since fixed that. So go ahead and send your requests and we'll get you in the group as fast as we can. And that's it. Thank you for watching. Hey everybody, this is Brian. Welcome to the 14th Flutter tutorial. We are getting into the advanced Dart topics. Remember, we have to learn Dart before we can really dive into Flutter. Today we're going to talk about asynchrony support or asynchronous programming. What in the heck is this? That is even a mouthful to say. I'm sure everybody listening to this has had somebody tell them, hey, do this, but while you're doing that, also do this, and then maybe do this, and this. It's really multitasking. Asynchronous programming is different than multi-threaded programming under the hood on how the computer actually works with the code. Won't get too deep into that, how that works, but just understand that asynchronous programming allows your code to run asynchronously, meaning at the same time as your other code. And you can do some really cool stuff with this. So let's just dive right in here and let's create a new project. And next, let's call this multitasking. May help if I pull my keyboard out a little bit here. And honestly, I wasn't really going to cover this because I'm kind of chomping at the bit to actually get into Flutter, but it is a part of Dart and it's going to be heavily used. A lot of the I/O functions work with futures and streams objects. And in the words of Ripley from the movie Aliens, you started this, show me everything. So if you haven't seen that movie, it's like one of the best movies of all time. Anyways, let's just dive right in here. Now, if you've never worked with asynchronous programming, reading the official Dart documentation can be a little bit confusing and not really for the faint of heart, although it's actually broken down very well. It's just a very complex topic and it's a very advanced topic, and even seasoned programmers make some very bad mistakes. So I apologize in advance if this tutorial has some mistakes, and I'm sure everybody on YouTube will point them out. I have to chuckle when I say that because they do point them out. All right, so the first thing we need to do is we need to import Dart async. And you notice how that has Dart :async. It's in the past we've done just a raw import where you import a file, and we've imported libraries and stuff. But Dart, whenever you see that Dart : that means it's part of the core framework, if you will, or the Dart libraries. Now, I should note that everything in Dart is a library. Even this program we're working on now is a library. But that is how you import something directly out of Dart. So we have to kind of understand some things before we can really dive in here. So I'm going to start with a very simple example, and we're going to call this future. And notice how that took a generic type, which we just covered in a previous tutorial. We'll call this the long wait. All right, so already we notice some big differences here from what we've worked on in the past. Let's just finish this out real quick. Int I equals 0, I less than, let's just say 5, and then I plus plus. So we're going to increment that. And then we're going to just print out the prefix and the current number. And then at the very end of this, we're going to just return true. Some things you need to understand what's going on under the hood. A, you cannot use async without this import. You will get a glaring mistake here. Let's just cut that. See how suddenly undefined class future, and if I take that out, that'll start lighting up. And so first step is you've got to import the async library. The second step is that your functions and methods will have to be treated a little bit different. I keep saying functions, but they're actually called methods. They're treated a little bit differently. You won't actually return a Boolean. You're going to return what's called a future that wraps around the Boolean value that you're returning. Now, what does that really mean? You have to do that because of the way the code is actually executed. And let's just do this. Let's say and then we're going to print, whoops. Nothing too snazzy about this. It looks like it'll just run, right? So let's actually grab this and run it and see what happens here. Notice how it says starting done, then it says 0, 1, 2, 3, 4. Now wait a minute. If we look at the code, it says print do this, which is actually this guy right here, then print done. But if you notice, it's saying starting done. So it's going from here to here and skipping this guy altogether. It's not actually skipping it. It's doing it in parallel. This just takes longer to execute than this print statement does, so that's why it says starting done. But it's actually happening asynchronously, aka pretty much at the same time. Now, as you can imagine, that can lead to some very big problems if you're expecting things to be in a certain order. We're going to cover how to do that. But I wanted you to understand that we're not actually getting the Boolean value. We're getting a future, meaning we're going to return a Boolean value or whatever we put into this generic template here. So to get that Boolean value, you have to say bool ret, whatever we want to make it, equal. And we're going to use the await keyword. So what this will do is it will say, hey, this is an async function. You have to be in an async function to call an async function. As crazy as that sounds, it just needs to know. Let's actually test that. Yeah, see, suddenly await lights up and says, not going to run. So you've got to be in an async function. And the await keyword will actually, well, pretty self-explanatory, it will await this to be completed. So it's going to say starting. It's going to await for that to be completed. Once that's done, it's going to unwrap that future object. It's going to get that little value there and shove it into this one right here. Shove it right into that variable and then hand it off to our program, and then it'll say done. And we're actually not really using this, but I kind of wanted to show you how to get the variable back out of there. So let's just print this out. Just so that you can see there is an actual value and not a future object. See, now you can see how it says starting, and then we've got 0 through 4, and then the Boolean value, and then we're done. So that is how you would work with that. Now, there is a bit of an easier way. I say easier. Some people love it, some people hate it. It's just personal taste, really. Void, and we're going to say test then. Man, this keyboard's really ticking me off here. Yes, in case you're wondering, it's the same keyboard I was having problems with a few weeks ago. All right, so we're going to go starting. And through the magic of copy and paste here. Pretty much the same structure. We're not using the async keyword here. So we're in what's called synchronous code, and we want to run asynchronous code. Well, we have two options. We either turn our little function into an asynchronous function like we've done before, or what we can do is and we want to say then get in there. And this will take a little bit of explaining. And this is why some people love this and some people hate this. Let's actually shove this in here and see what happens. All right, so when we run this, you can see how it says starting done. So we think that we've already screwed up, but then it says 0, 1, 2, 3, 4, done waiting. I left this done in here so that you could see what would happen. It will actually treat this, as synchronous code, meaning it's going to do the then. Now, I understand that makes no sense. What does it mean by do the then? Code execution starts here, says do this long wait, it goes up, evaluates this, and says, oh, it's an async function. Good, I can just run this in parallel. So it's going to asynchronously run that. While that's running, it's going to jump down here and go, okay, we're back into synchronous code. So start, done, and then this executes off to the side at the same time. That is where the then method comes in. What then does is it says, do the asynchronous code, then when you're done, run this code. That gets a little confusing. Some people love that, some people hate it. Personally, I prefer this method because it's very clear to see what's going on. However, you can do some really cool things with this. So let's actually do this. And we're going to just say, oh, let's just grab this whole thing rather than type all this out. I'm getting old and cranky here, so. All right, so now what we've got here is, let's actually do this a little differently. So we're going to grab the future object out of here. Notice how we're not grabbing a boolean, we're grabbing the future object. And from here, we are just going to say, let's run this and just make sure this works as expected before we really dive into it. All right, so it's starting, done, and then we've got chains, blah, blah, blah. So what we're going to do here, and this is where I always screw up, and that's why I wanted to kind of do this, is we're going to grab this, and we're going to say bang, bang, done, chain 1, chain 2, chain 3. So let's run this again, see what happens here. Now you can see how you can actually say, hey, once you're done, do chain 1, do chain 2, do chain 3. So you can do things in a specific order after the asynchronous code executes. So this could be like calculate the sun, moon, and stars, and then put it into a database and then log it and then dial into a server and spit out some value or something. So you can do what's called chaining, and that's why I said chains. Let's just get rid of chain here and just say done 1, done 2, done 3. Done, done, done. Anyways, that was lame. If I edited my videos, I would edit that right out of the video. That was really lame. So now what we're going to do is we're going to actually test waiting on multiple asynchronous calls. And this is pretty advanced, and this can get kind of nuts. But the syntax for it is just dead simple. That's why I'm going to add this in here. And notice how we are back to the async. And we're going to say print and we're just going to say future f1 equal kind of just copy and paste this a few times here. So we've got our 3 asynchronous calls here, and let's actually comment this out so we can see it work in real time. And you can see how there it goes. 1, 2, 3. That is how that's going. Now, this does not necessarily guarantee that it's going to be in order. It may not be 1, 2, 3. These are each independent, distinct calls. So it may be 2, 3, 1 or 3, 1, 2 or whatever permutation here. So what we want to do is we want to know when all 3 of those are actually completed. You see how we got starting done. We want done way down at the bottom here. So what we have to do is we have to say await future, and then future itself has a wait call in it. And notice how it wants multiple futures. So we're just going to, you guessed it, we're going to wait for those. And once they're done, it'll print it out. Bang. So starting, and then there's 1, 2, 3, and then done. That's pretty neat. So just be aware that there is a lot of code, especially I/O code, that is synchronous, and you'll have to really learn how to work with that, but it's really not that hard. To be brutally honest, some other languages, the syntax in like JavaScript, for example, is very similar, but for whatever reason, JavaScript makes me want to just rip the keyboard out of the wall and throw it across the room. I don't know why. Dart, however, is very streamlined and very elegant. I really like the way it works. So that, in a nutshell, is asynchronous programming. It is by no means the lexicon of asynchronous programming. This would be just like a high-level primer, just so we can start working with Flutter. You will run into issues, and you may have spotted 1 or 2 bugs in this little program here. So if you find the bugs, definitely go out to GitHub, modify the source, commit it, and I will approve it. And we'll go on from there. Speaking of, if you found this educational and entertaining, visit my website, voidrums.com, for the source code for this and all other tutorials. And I keep saying it, there is a Voidrums Facebook group with 1,700 other programmers out there, all walks of life, every language you can imagine. I'm constantly asking questions out there. It's a great resource for other programmers. That's it. Thank you for watching. Hey everybody, it's Brian. Welcome to the 15th Flutter tutorial. We're going to continue on our learning curve of Dart. We're actually getting towards the end of this here. If we go ahead and jump into language and then do a tour of Dart, you can see that we've covered pretty much all of this. Today we're going to backtrack a little bit and go back into classes a little bit here. I want to discuss static, my brain just shut down, static methods and static variables inside of classes and how they actually interact in Dart. So let's just go ahead and crack this open. We're just going to call it stat. I like that word, stat. So if you are from another language, you're probably rolling your eyes going, I already know how this works. There are some minor caveats. If you're brand new to programming, this may completely blow your mind, and I apologize in advance. So we're going to just kill that, kill that. And the first thing we're going to do is we're going to make a new class here. And we're going to call it counter. Now in the counter class, we're going to make a private variable here called static int. Well, let's call it count. So what does a static mean right here? Static is a keyword. You can tell it's a keyword because it's highlighted in bold. Really what it means is it exists throughout every instance and non-instance of that class. And we'll really get into that here in a second, but just understand that it means it always exists. So what we're going to do is we're going to say int get. We're going to make a getter and setter for this. I swear my phone is dying. It just made the weirdest noise. Now, why am I making a getter and setter? We really don't have to. I'm just doing this to show you that, you can have this as a private member variable, but also have it static. Some people get a little confused and think that just because it's static, it has to be public, and it really doesn't. So now we're going to make some static methods here. So we're just going to increment and decrement respectively. And then we're going to make some non-static methods here. And actually we can just shorten these up as well. I don't know why I was going to do it this way, but oops. And then so we can add and remove 10 respectively, and then we are going to just print the count out. Now, you may be looking at this and asking some questions. What is static? Why is it all scattered throughout this? And how come we're using count and not the getter and setter? Well, remember, getter and setter are primarily used for outside of your class. While you're in your class, you have the inner scope, and therefore you can access this internally. Everything outside of this, because this is a private variable, will not be able to access it, so you have to use the getter and setter. And now we're going to go over to our main file here. We're going to import the, oops, man, that was a major fail right there. That was kind of embarrassing. So first thing we want to do here, let's just say counter, and you notice how if we just type the class name counter, we have the decrease, increase, and print count. And if we look at the class again, you can see that increase, decrease, and print count all have static. That's what it means, is we don't have an instance of this class, yet we have those functions, or I should say those methods. And we can actually work with those. So we don't even have an instance of this, but yet still it works. We've gone from 0 to 1, and we can actually increase this a few times if we want. Now, one thing you should notice is we don't have access to the non-static fields. And that is simply because they're not static, meaning you have to have an instance of that object. All right, so we're going to say counter obj, just short for object. And you notice how now we have access to the non-static fields, but we do not have access to the static fields. So we have access to add 10, but we don't have access to increase or decrease. Whoops. Boy, I screwed that one up. And this is why we're using our getters and setters, so we can access those. And we're going to dereference that object. And once again, we're going to print the count. So what we're going to do here is we're accessing the static fields, and then we're going to make an instance of that object and modify it with an instance of that class. Instance of that object, that doesn't make any sense. We're going to make an instance of that class, we're making an object, and then we're going to modify it using the non-static fields. And then we're going to actually print the count out again, and we can see how the count actually increments. So we've got 0, 2, because we've gone from 0 plus 1 plus 1, so there's our 2. And then we have gone to 12 because we've added 10. And then we've set it to 5, so there's our 5. And then we've set it to null. We set our object to null. But yet we can still print out 5. And if we made another instance of this class, let's call this obj2. So we know it's a completely different object. Let's get rid of that right there. You can see that it stays at 15 because now we've added 10 to the 5. And even though we've set this to null, it still stays there. So that, in a nutshell, is static fields. Now, one thing you should know is you don't always need static. A lot of people think I need to convert this to static and that to static. You really don't. Many times what you would actually need to do is persist this off to a storage device somewhere rather than actually holding it in memory. For a counter, it would actually make sense. Like, let's say you were building like a humane society that houses animals, and you want to know how many animals are in there. Every time an animal is added or removed, you would increase the counter. But for normal lists and things like that, static really does not make a whole lot of sense. What is a good use case for static? Well, this right here, actually. If you want to make what's called a utility class, or a class that has a lot of functions in it, or methods in it that you would just use throughout the day, rather than having to actually build an instance of that object, you can just say class dot whatever it is, and then you've got all your built-in functionality. There's actually a lot of libraries that do that, so that's a good use case. That's all for this tutorial. I hope you found this educational and entertaining. The source code for this and all other tutorials will be out on voidroms.com, and you just click on GitHub and it takes you right out to the tutorials. And there is a VoidRoms Facebook group. The link is out here in the contact tab, and we've got 1,700 plus and counting other programmers out there from all different languages that can help out. Hey everybody, it's Brian, and welcome to the 16th Flutter tutorial. We're still on the Dart learning curve here. We've covered quite a bit, but what we need to do now is if you scroll all the way down here, you can see there's libraries and visibility, and I wanted to talk about this a little bit here. In Dart, everything is a library, including the programs that we've made up to this point. There's a distinction in how those libraries are actually set up and how they're used, though. Another distinction is whether they're internal to Dart. They start with the import Dart semicolon, or whether they are packages that are not included in Dart itself. There is a lot out there, and to be brutally honest, there's some of these features you may never actually use. You can import a package as a variable. You can actually show only specific parts of a package and hide specific parts of a package. You can even do lazy loading of a library, meaning you can have this massive library and only load the pieces you need as you need them. It's actually a really cool feature. They don't really cover it a lot in the tour of Dart. You have to actually click on libraries over here. And you can see there's a tour of the Dart libraries, commonly used libraries, and then a whole tutorial on how to create your own library packages. We're going to cover a little bit of this, but I wanted you to be aware of this for future tutorials here, that when you click on that, let me back up in case that wasn't apparent what I did. You click on Tour of Dart Libraries, and you can see they have got just a ton of information of all of the built-in functionality with Dart, and their slogan is batteries included, which I think they kind of took that and plagiarized that from Python. I'm not sure which one came first. I'm pretty sure it was Python. But anyways, it is actually batteries included. There's a lot of bang for your buck in here. One of my favorites is they have, browser-based apps. They have I/O, they have conversion, and they have mirroring, which is reflection. So it's really nice to have this right into the library itself, so you don't have to go and get something external. However, back here, you should be aware that you can actually make your own, and you can publish it out on this thing called pub.dartlang.org. Now, if you're wondering what it's pub is a tool for managing Dart packages. And if you go out to pub.dartlang.org, you can see there is a lot out here. So let's say we want to, and I'm just going to pick something at random, image. You can see there's image pictures, Flutter image, zoomable image, image carousels, image transformers. Okay, let's try something a little more specific like resize. All right, so here's a good one. Provides server and web apps with the ability to load, manipulate, save images in various image file formats. And you can see it works in Flutter, it works on server, and it works on web. So we can actually just click on this, and it gives you a brief rundown. And not all of these are created equally, mind you, but some of them have a lot of documentation, some of them don't. You can see the author. This was not an official Dart package. And you can see that it has no reliance on Dart I/O, so it can be used on both server and web applications. You can read-write all of these formats, read only those, and it has all of these functions built in. And it has changelog and how to install and how to use, which we'll cover in a future tutorial. But for this tutorial specifically, I wanted you to know that that functionality exists. Just know that there is a massive amount, and it's growing daily, of libraries out there for you to use, and just about any functionality you can think of is already out there. And it's, I mean, as you're listening to me speak, it is continuing to grow and grow and grow. I've heard a lot of programmers say, oh, Dart is dead, don't work with Dart. I've actually seen it grow right before my own eyes, and it's kind of crazy. So let's dive into this one. We're going to make our console app. We'll call this lib intro. Why, I don't know, just because I couldn't come up with a better name. All right, so now that we have got this, a little bit of explaining what's going on here. You can see how we have this folder lib and we have this folder pub. When we use something out on the public, i.e. in pub Dart, it actually goes in here. And you'll see that in future tutorials. What we're going to be working with is right here and in the built-in libraries. So let's actually expand this. And this is just boilerplate. This comes with every single application that we've made to date. And you can see how it says import package, semicolon, and then it has the path libintro/libintro.dart as, because we're importing this as a variable. And then we can, down here, libintro.calc. And we can import this as pretty much anything we want. I mean, we could say cat. And then it will calculate using the function out here. And we've talked about this before, how we can add things in. It's a pretty strong feature to be able to do that. You can structure this pretty much any way you want. There are some caveats. One thing you'll have to have, and we'll cover this when we actually build our own library, is you'll have to have this pubspec YAML. Which just has some details into it. All right, so what I wanted to cover is the differences here. So let's actually work with a built-in Dart package here. So let's say local notice how I'm starting with Dart semicolon, and you can see all of these that it come built in. That's pretty crazy, right? We've worked with a sync before. So what we're going to work with is called convert. Convert really has some pretty nice features to it, but what we're going to work with a little bit is called JSON. If you don't know what that is, it's a way of stringifying, I guess is a good way of putting it, an object so that you can work with it. Some people like XML, some people like JSON. It basically takes an object and makes it into a giant string or variable that you can pump off to the network, read it into another program, and convert it back into an object. So we're going to make a map, and we're going to say string int and then we're going to say map dot put if absent. And what we're going to do here is we're just going to say put my age in here. Yeah, now I feel old. I feel ancient. I play Call of Duty, and these kids like mop the map with my face. And we'll just throw my daughter in there. So what we're going to do now is we're going to actually convert that object into a string. So we're going to say string encode, and we're going to encode the map itself. Then we're just going to print this out. And you can see there's the JSON right there. That's the string representation of that object. So now we want to convert this, well, from a string back into an object. So we're going to say map string int. And let's call this people so we know that we have a different object altogether. And we're going to take that string and decode that into an object. And we're just going to say people for each, and then we have our key value pair. Maybe that was kind of bad. We have our key value pair. And we're just going to print that out. So really all we're doing is we're taking our map, our object, using JSON to encode it into a string, and then using JSON to take that string and decode it back into an object. And you can see here's our JSON, and here's our actual decoded object being printed out in the for each. So this seems like a very simple example, but it really shows you just how powerful Dart is. Not so much that it can do JSON encoding and decoding. Other languages can do that, obviously. But the fact that you can very easily add this functionality right into your application without jumping through a lot of hoops like you have to with other languages. Sometimes you'll have to import this, do some local build, do some extra steps, do some configuration, Most of the time, it's very simple, very easy. And I think in future tutorials, probably actually maybe the next tutorial, we're going to actually show how to just grab something random off of pub.dartlang.org and show you how to leverage somebody else's code. I may have to actually, well, it's not that I may, I'm going to definitely have to test a few of these that make sure they actually work as intended. But I mean, as you can see, just about anything you can really think of, like let's say you want to do a server. Let's look out here. Okay, so there's all different types of TCP servers. A web server, here's a multi-server, web server middleware, ICU server. Let's just pick something completely random here. Let's say IRC. There's an IRC library out here, IRC client. I mean, as you can see, there's just a lot out here, and I hate to sound like a broken record, but it's continually growing. So it's very important that you learn how to work with this, because a lot of the times you'll find functionality that you need already exists, and rather than reinventing the wheel, you're going to have to import the code and actually work with it. Well, that's all for this tutorial. I hope you found this educational and entertaining. Once again, visit my website, voidrealms.com. Click on tutorials and then GitHub for the source code for this and all other tutorials. And this is 100% funded by your donations. So if you found this remotely helpful and you're not a starving college student, go ahead and donate a few dollars if you will. Every dollar that you send funds this website, and at the end of the year, if it's I have what's called an overage, meaning I have more money than what I need to fund the website, it goes into a charity. And last but not least, be sure to go to the contact page and visit the Void Realms Facebook group. There's 1,700 other programmers out there that can help you. Hey everybody, it's Brian. Welcome to the 17th. I better double check that. 17th tutorial with Flutter. Got a little frazzled there. My phone was kind of beeping in the background. Anyways, we're going to continue on down our Flutter tutorials, and we're going to learn a little bit about I/O. Now, when I say I/O, I don't mean the moon I/O. I mean input-output. And the first part of input-output we're going to work with is called files and directories. Files and directories is a huge topic, and we're going to kind of condense it down a little bit. So obviously we can't cover every single little use case, but we're going to cover the vast majority of them. We can't cover everything because we will be here for 300 more videos. You can do just about anything with files. You can encrypt them, decrypt them, encode them, decode them, pump them across the network, scramble them up, chop them up, dice them. I mean, whatever you want to do. I hate to sound like an infomercial, but files are quite literally the bread and butter of most programs. So, without further ado, let's go ahead and import Dart convert, Dart IO, and let's work with this. So, the first thing we want to do here is, let's say we want to figure out how to list files and directories in a path here. So, we're going to say void list. Help if I actually did that correctly. And we first want to surround this with a try-catch block. Now, why do we want to do a try-catch block first? It's because working with the file system can be very error-prone. If you ever worked with an older OS or a computer that's kind of flaky, you'll know that really quickly, that sometimes files just do not play nice. Alright, so, whoops, equal new. Alright, so what we've got here is we've got a directory object, and we're just going to make a new directory object based off the path. Then we're going to say, now if you notice how we can say exists and exists sync. This is kind of the crux of the I/O portion of Dart. I/O is asynchronous, so what they've done is they put some helper functions in here that allow you to help you call this synchronously. So instead of doing exists and then messing around with await and then and futures and all that, we're just going to do these sync and let them do all the heavy lifting for us. So if it exists, then we're going to get file sensitive entity. And we want to list sync. And then we're going to just print out so first thing we want to do here is actually let's get a listing here. So we'll see. We're just going to, I'm on a Linux system, so we're just going to grab the root path. Users, you might want to do that on your C drive. Let's just run this and see what happens here. And you can see how we get a whole list of things. This is everything that is on my root path here. If you know Linux, it's really nothing special on this virtual machine. All right, so whoops, I gotta pause the video for 1 second here. Sorry about that. Somebody was at my front door, so I had to go see what it was all about. We're gonna change this path here, and it's just the path that I have the videos in. That way we're working with a very small section of my file system, so if I goof up, I'm not reinstalling my operating system here. Although on Linux it's really hard to actually blow something up. But you can see how we actually have a different structure now, and this is actually the movie that we're creating at this very point in time. So what we want to do is we want to learn how to write to a file. I'm going to say bool, and this is just the way I do it. There's the problem with programming, or I should say the added bonus with programming, is there's literally billions of ways you could do this. I'm just doing it my way. If you don't like it, feel free to do it your way. But this is typically what I do when I'm writing a program. All right, so we're going to do the try catch block. Whoops, we did screw something up here. Now, if you're wondering why I'm doing just a print toString, it's because I want to know when something actually blows up. The last thing you want is what's called a silent error, which means you have a catch and then you don't do anything with it, because then you run your program and nothing happens and you're like, what the heck? So you want to know that there was actually an error, and that's why I just print it out. But all right, so we need to say file. So we're just saying want the file object to be a new file based off the path that we're giving it, and I probably should name this to path, but I'm just going to leave it as file. And then we want to say a random access file. I'm going to call this rf equal new random access file. Actually, nope, sorry, I screwed up. We want to get that off of our file reference. Sorry about that. And we're going to say open sync. Now you'll notice that there's open read, open, which gives a future, and then open write and open sync. We're just going to work with open sync. There's different types of files. We're going to work with what's called a random access file, meaning we can randomly move around in that file and do whatever we want with it. I typically work with random access files because they're a lot more flexible, although they are a bit slower. Technology's grown to the point that the difference between a random access file and, say, a sequential file is very minimal. And then we want to actually give it a mode. And the mode here is going to be the mode that we give the function, or I'm sorry, the method. If you're wondering what the mode actually means, you can actually say file mode dot and see the different modes. There's append, there's read, there's write, write only, and write only append. Append basically takes an existing file, if it exists. If it doesn't exist, it creates it, but let's just say it exists. And it just keeps adding to the end of it. Think of it like a line in the bank. It'll just keep adding to the end of it. Read will read from the file. Write will completely destroy the file and write it from scratch. Think of writing as, you take your parent a bad report card, they wad it up into a ball, throw it in the trash, and say, bring me another. Write only means you can only write to the file, and write only append is pretty self-explanatory. You can only append to the file. Why they didn't call it append only, I don't know, but all right, so those are the different modes, and that's pretty standard of most operating systems, regardless of what platform you're on. That's kind of like a file primer. You probably spent a week talking about that in your computer science class. All right, so what we want to do now is we want to write string async, and we're going to just say data, and then we want to flush sync, and we want to close sync. So flush and close, those are real keywords. Kind of ignore the little sync at the end here for now. Sync just means that we are asking Dart to do this synchronously. Focus on flush and close. What flush does is think of a file as, well, like a toilet. I hate to say it that way, but think of it like a toilet. And you're just dumping stuff into it. And when you're done, you want to flush that toilet and write it down to the disk. So flush literally tells the operating system, hey, write it down to the disk. Close then closes the file. I am not 100% certain, but I think under the hood, close may call flush for you. I know on some Some different languages it actually does. I'm not sure if it does in Dart. So I'm going to call the flush intentionally because that is what was out in the actual code they had as an example out here somewhere. I'd have to find it. Yeah, right here. Writing file contents. I think they're doing this because their example is asynchronous and I'm doing it synchronously, so I'm not sure if I actually need to do the flush. I think I just need to close. All right, so now that we know we can write to a file, we need to know how to read from a file. And this is a little bit easier. And we're going to say string, and we're going to say read file. All right, so we're going to just do our try catch block. Now, for some of you, while I'm typing this out, may be reading the comments out on YouTube. There's a lot of folks saying, hey, you know, we don't like these tutorials. We want more Qt or QML, or why are you using Dart and not Qt and QML? It's because I've done a lot of other tutorials in another language called C++ that uses a library, or I should say a bunch of libraries called the Qt. I don't want to call it the Qt framework because it's a Qt library, but it's called Qt. And it is, kind of lost my train of thought here. It runs on any platform. It's an amazing system. I still love Qt, I still love QML, and I want to do more videos on that, but right now Dart and Flutter really have my attention, so that's just kind of my focus. And we're going to say read as string sync. Now, what we're doing here is we're just saying create a new file with the file name, which creates the file object. Now that we have the file object, f in this case, we're saying f read as string sync, meaning that's going to read the contents of that entire file into one giant string and then return a variable. We're then going to take that variable and return it from this method. And what we're doing here is the default encoding, which is UTF-8, which is an entirely different conversation. Encoding is how the actual information is written and read to and from the disk. In this case, we're going to leave it as UTF-8. You can feel free to experiment and change your encoding, but just understand that not all encodings are compatible. So we're just going to leave that as default. All right, so now we have the ability to write and the ability to read. Let's test this out. Let's actually just go here, and we want to say we need to make another variable here. Let's call this txt file, and we're going to just say, just give it a very simple name, and we're going to say if write file, and we need to give it our text file, and we need to say some sort of data that we're going to write to, and we're going to say and then the mode, we're going to say append. And we're just going to play around with this for a little bit. Oops. So really what we're saying, if this, then that. So what's going on under the hood, assuming this works because we haven't actually tested the code, we're going to write to our text file, which is going to be on this path in my virtual machine. And we're going to write this data. This right here is called an escape character, and this right here is called an escape sequence. Wow, I misspelled world. That's embarrassing. So what escape does is it escapes out of the character sequence and says, I want to put a special character in here. /n stands for new return. You can, if you're on a Windows machine, I think it's /n/r or /r/n, something like that. Actually, it's the other way around. I can already tell by looking at it. It's rn, which does a hard return a new line. That's how Windows does it, but on Linux and Mac, it's just a new line. You can also put like a tab in there. You can put special characters. You can put just anything you want. We're just doing this to break it up so there'll be a line. We're doing that because we're in append mode, and we want a new line every time we run this. Then we're going to print, and we're just reading the contents of the text file back that we just wrote, and we should see hello world down here when we run this. And you see, bang, hello world. So if we go out to our file system, you see that now there is a txt.txt our test.txt. And if we were to open this up, you can see there is hello world in there. Now let's just move this off to the side, run this again, and you see there's 2, now there's 3, now there's 4. And you can see our text file saying, hey, it's changed, we're going to reload it. And that's append mode. It's just going to keep going and going and going. Now we're going to switch this to write mode. Notice how we only have one hello world, and if we go back to our text file, reload it, there's only one. That's the difference between write and append. Append's just going to keep adding to it, where write's going to completely blow it away and start from scratch. I'm going to switch this back to append because I want to put that up on GitHub the way it is. Now, let's say we want to be able to, let me think about this for just a moment here. Let's say we want to be able to actually pump this out as JSON. So let's do that. Wasn't going to do it, but I'm like, yeah, why not? People are going to ask how to do it. So we're going to say, before we do that, I'm actually going to do something else. List. Sorry for being so scatterbrained. I'm kind of deviating from my original plan here. I'm trying to think in advance of what people are going to ask for. And what they always ask for is, okay, it's great that you can do it in one giant blob, but how do you do it in a bunch of lines? You know, how do you read lines from a file? So I'm just trying to limit the number of questions that I'm going to get off of this thing. And what we can do here is we can just say very simply, and then we can just say readline sync. And you can see how that is currently going to return a list of strings. And it's that easy right there. We could just read the lines. So let's actually do that. And let's comment this out. Actually, let's not. Let's say, see, whenever I deviate from the plan here, things happen very badly, but that's when we probably learn the most. So let's try this txt file. So we want to get the length of this. Let's run that. And you can see how there's 2, there's 3, there's 4, there's 5, there's 6. So there's 6 lines in that list object. So that is how you would read the individual lines. And I'm actually going to comment this. That was embarrassing. Wow, I really just misspelled all of that. So what read lines does is it goes in and it looks for that escape sequence of /n or /r or both, and it actually breaks those up into individual strings. So it's taking that giant string and breaking it down into 6 individual strings. All right, now we're going to go ahead and we're going to read and write some JSON here. So let's actually, all right, let's say bool to, let's say JSON2 file. I'm having a hard time figuring out what I want to call this. There we go. And we'll say string file. Now, what we're going to do here is a little bit different. What we're going to say is map, and then we want a string and an int. We're just going to basically plagiarize what we did on our last tutorial here. Man, I am getting hungry. Like just sitting here, suddenly my stomach just starts growling. So we're going to put if absence, and we're going to say Brian. But yeah, I've had a couple of people say, what is QML? Why are people getting upset that you're not working on it? That's why I've done like I don't even remember how many. I think like 150, 170 some odd videos. A lot. I've done a lot of those videos, and I've gotten pretty advanced in that realm. So anytime I make something that's not Qt or QML, everybody kind of wonders what the heck's going on. Yeah, I'm going to get back to it eventually. I'm actually hoping to get back to it this winter. All right, so we're going to say string JSON, string data equal JSON.encode, and we're going to encode this map, and then we are going to return our write file, and we're going to say the file name, our data, and then our mode. We want this to be file mode.write. Reason being, if we have append, we'll have multiple JSON objects in there, and it'll probably crash the program, or it will just get garbage back, or we won't get the latest object. Something bad will happen. All right, so we've got JSON2 file. Actually, let's call this write JSON. There, that's better. Now I'm happy with it. Now we're going to say void. We're going to read the JSON. I fought JSON for a long, long time. I was really into XML. I did not like JSON when it first came out. XML has just been around forever, but it's horribly inefficient. All right, string data equal, and we want to actually read the file. So we're just reusing the code that we wrote. So rather than reinvent the wheel with the write file and read file, we're just reusing our functions here. Now we need to do a little bit of error handling here. You notice how write JSON is just returning the value of write file. Now with this, we can't do that. So what we need to do is say if data.isEmpty, then we're going to say print no data, and then we're just going to return out of this function. And we should also get the error string from the actual right here, from the actual method. All right, now that we know that we have data, because at this point we should have data, I'm going to say map string int. This is the structure of our map here. Structure of our map. That really didn't make a whole lot of sense, but I think you guys knew what I meant. All right, so we're going to say people equal JSON.decode, and we're just going to decode that data into an actual object. And then from there, we're going to say print we want to know what the people object contains, just so that we can prove that we actually decoded this. We're going to say people.forEach, and then we're going to say key, comma, value. Let me scroll this down a little bit so you guys can see what's going on. And then we're just going to print these out. All right, so that should work. Let's actually put this down in our main function here. And we need a new file name. So we're going to put this into a different file here. And then we are going to simply say if write JSON, txt JSON, then what we want to do is there we go. So when we run this, assuming it's all going to work, we'll get another, we'll get another file out here. Let me actually go to our the directory here. We'll get another file out here called json.txt, and it will contain our JSON object. And then if it returns true in the right, where is it, right here, if that returns true, then write JSON will return true. Then we'll actually read it back, and then we will go through this object and print it out after we've decoded it from string. So this may seem a little complex, but this is actually a really good real-world example. This is really what JSON's designed for, is you would take an object, encode it down to a string, pump it across the network or internet or whatever, and then your consumer, as it's called, the consumer application would take it, read that string, decode it back into an object, and then work with it. And woof, that scared me. It actually did work the first time. You can see we have 7 hello worlds, and our people object contains Brian is 43 years old and Heather's 25 years old. And sure enough, there's our JSON file, and there is our JSON object that got written down to disk. Whew, that was a mouthful, and I'm glad we didn't have any major errors because I'm tired and I'm hungry. So I'm going to go get some food, but before I do that, I wanted to thank you guys for watching, and you can find the source code for this and all other tutorials out on my website, voidrealms.com. Just click on GitHub, and then go out to all the tutorials. I got the Flutter tutorials here, and then all the source code. On top of that, feel free to visit the Void Realms Facebook group. We have 1,700 plus and counting programmers, all different languages. I warn you right now, most of those animals love C++, so you may get a little flack if you post a Flutter question, but actually everybody's pretty decent in there, so they'll probably help you. And that's it. Thanks for watching. Hey everybody, this is Brian. Welcome to our 18th Flutter tutorial. We're going to hopefully today wrap up our Dart conversation and then move into Flutter in the next tutorial. The reason why I want to do this one is it kind of goes through a overview of libraries and how to use them, which we've talked about a little bit, but not really in depth. So if you kind of just poke around Dart, you'll find that there is a pub.dartlang.org, and you get to it by going to libraries, and then you can actually view the tour of libraries, how to create packages, how to commonly use libraries, which I highly recommend you look at. But you'll see that pub is a tool for managing Dart packages, and we've talked about that before, and we've even talked about pub.dartlang. When we go out there, you can search for just about anything. I mean, if you've thought about it, it's already out there, which is just nuts because Flutter itself is in alpha. Dart's been out for a while, but just about anything you can think of. And back to the commonly used, you can see they've got a wrapper for Firebase, HTTP, internationalization, I can never say that right, logging. I mean, we've been over some of these before. So what I want to do today is really go over how to really integrate those into your project. We haven't really covered that. So if you're out there, you can search for HTTP or image, and I've got both pages up. Really, we're just going to work with these two. What we're going to do is we're going to download an image and actually resize it, and we're just going to show just how dead simple this is. In other languages, this is a total nightmare of a project. Your boss says, well, we want to download this image and resize it, and you're thinking, I got to go find a image library, I got to figure out how to work with HTTP, I've got to do the get and the put and all that. No, it's dead simple. So let's just jump right into this. And we're going to make a console application in Dart, and we're going to call this downloader. All right, and this will load our project and load all the dependencies and calculate the meaning of life. Sometimes I really wonder under the hood with that thing. All right, so one thing we really haven't talked about is when you open a project, it opens these 3 files for you automatically. It opens this file, which is your code file out in your lib, this little guy. It opens the main file, which we've worked with many, many times, which is that guy, and then this pubspec.yaml. Notice how in YAML there is a dev dependencies. That's what we're really going to be working with here. So let's just kill that. And we're going to get this and get that out of there. Now let's flip back. To use anything that we find out in the Dart packages, like we just search for HTTP. You can see that's how I got to it right there. Once you get to the page, you can do the README file. You can see who the author is. The HTTP package was actually done by the Dart team itself, and it's got some example code on how to use it. Now, not all of these are created equal. meaning you will find packages that have just absolutely zero documentation. So in that case, you would reach out to the author and say, hey, how do I use this thing? This is pretty straightforward, and it works with streams. So under the hood, there's a lot going on, but to use it, it's dead simple. What you always want to look at is how to install it. Depend on it. So you open the dependencies, you open the YAML file, copy this little bit here, and then put it in the dependencies. So we're going to do that. And we're going to do the same thing with image. We're going to go to installing, going to grab this, and we're just going to put that in there. So save that YAML file. There are really two ways of doing this, but the easy way is just flip over to main.dart and you can see how, hey, pubspec has been edited. This file right here that we just did. What do you want to do? Do you want to upgrade, get, ignore? Well, we want to get because we don't actually have those yet. You can see there's our pub file, our pub folder right here. The little dot denotes that it's a hidden folder. So we're going to get dependencies. And that may take a second depending on your download speeds. All right, once we're done, you should see that the little indicator has gone away. And if we run through here, I think we may actually see them. Yep, there's HTTP right there. I'm not seeing image. I'm wondering where that went. Maybe I'm wrong, but I'm pretty sure that's where it is. That's 11.316. There it is. Oh, there it is right here. Image. Derp. Now I feel very stupid. So that's where they end up going, is under external libraries. And they get bundled with your Dart package here. So we're going to kill that. Go in here. Now we want to actually use these things, right? So many times it's very simple, very easily documented. It's right under here. They tell you how to do a pub get. You can do a Flutter packages get. This is all command line work that we didn't have to do. And then you can import it right here just by copying and pasting. So we're going to copy that for the image. Go back out here. And we're going to copy that for our HTTP. Now, if you have no idea what HTTP is, it's Hypertext Transfer Protocol. It's basically how you communicate on the web. When you open a browser and you go to a web page, it's actually talking a language called HTTP. It's a protocol. So we also want Dart.io. We need to set a few things up here. So what we're going to do is we're going to say void download the premise here being that we are going to download something and we are going to resize it. So what we need to do is actually set up our variables. String URL, and because I just am dead lazy and I do not want to type that whole thing out, bam, we're just going to do this. If you're wondering what it is, it's just the hot reload GIF. This guy. So we're going to download this and resize it. And then we're going to say all right, so now I need a file name. Let's just grab this. See where I'm at on my virtual machine here. I probably should have known where that was, but so we got the directory, and we're just going to say test.gif, and then we're going to say preview.gif. So we've got our variable set up. Now we're just going to simply call the function. Yeah, see, if we would have named that to path instead of file, it would have just done it for us automatically. All right, so a lot of typing so far. Not really. Let's actually make the magic happen, as they say. So we're going to say yeah, I missed a step. That's why that's not working. We want to do this as HTTP. So if you're wondering what I'm doing here, is we want to use the image package, but we don't want to import it as a variable. We just want to actually use it. Whereas the HTTP package, we want to actually import this and create a variable. I'm just kind of showing two different ways of doing this here. That way we can just call HTTP dot, and bang, we've got an instance of that variable already. We're going to say read bytes. And you notice how we've got some parameters here, and it looks really nasty and ugly, but really you don't have to mess with that too much. We're just going to say the URL, which is our variable. So it's going to take that URL, go out there, and it's going to do the HTTP protocol in the background. It's going to read it as bytes, and it's going to return a variable we're calling data. And when that blah, then we need to do a then on the data itself. What's really going on here is, well, you guessed it, we're working with an asynchronous function. Whoops, that didn't work as planned. There we go, kind of. That's a little better. Those always trip me up. I'm still not used to those for whatever reason. They just mess me all up. So what we've got so far is we're going out, we're reading the URL as a byte stream, and then once it's done, we've got the data itself. I probably shouldn't call that data. Let's call this, what should we call this? F data. Why not? That way it's not super confusing what we're doing here. Then we're going to say file, F equal new file from the path. So then once we actually have the file, we're going to, or once we have the data, we're going to open a file, and we are going to actually dump that data down to the disk. And we're going to say random access file. And we've done this before as far as opening the file. And what we want to do here is we want to open sync because we don't want to mess around with any of the asynchronous stuff, just because I'm being a little lazy this morning. And we want to just write to that file. And here we want to do what's called write from sync. And you notice how it's taking a templated list using ints. Now really what that is that is our actual byte stream. So we're going to do that, and we're going to say f data. Actually, we could just call that buffer. It'd probably be easier. Why didn't I think of that? Genius. Man, these Dart developers are just awesome. All right, so then we're going to flush sync, and then we're going to close sync. That way we've got our synchronous code in there. We don't have to worry about any weird timing issues that are going to pop up due to asynchronous calls. Then we want to actually resize the image. So let's put some commenting in here. All right, so now that we've actually got the file down to the disk, what we want to do is we want to actually resize it. And here we're going to use the image library. So there's image, I shouldn't call it image library, image package. I think the two terms are kind of interchangeable. And we want to actually decode image. And we could actually take that buffer. You see how it is a list int, but what I want to do is I want to actually grab the file. So we're going to say new file. and we want read as bytes sync. So really we're just going to say, hey, image, decode the image, meaning it's going to read in the raw bytes, and then it's going to decode that because every image has a certain codec. It's not really a codec, it's called an encoding. You know, the difference between a bitmap or a GIF or a JPEG or something like that is the encoding that it actually uses. So it's going to decode that image by using the bytes that we're reading from the actual file on the disk. Whew. Sound confusing? Now you know why this tutorial gets a little nuts in other languages. All right, so now that we've actually got the image in memory, we want to actually resize it. Actually, I should say load the image. Now we're going to resize the image. All right, so we're going to say image thumbnail, and we want to copy resize, and we're going to take the actual image, and we want this to be 200 pixels. Then once we're done, we want to save the thumbnail out to the disk. So we're going to say and we want to do write bytes as sync. And we want to actually do this as a PNG, not a GIF, because why not? But you can see how you can encode it as a GIF, GIF animation, JPEG, TGA. You can do a named image type, things like that. So there's a lot of power in this little package here. So we're going to encode this as a PNG. All right, so that is a lot of typing. Let's see if this actually works. You notice how right now we've got absolutely nothing out in our folder except for a few other folders and the video that I'm currently recording. We're going to download that file and encode it. You can see process finished, exit code 0. And you can see how there is our test. Yeah, that is not a GIF file, that's why. Let's rename that to a PNG. Okay, just simply because I had the name wrong. There is our encoded here. To kind of solidify that this actually does work, we're going to delete all this nonsense. And we're going to actually fix this, because remember in the very end I changed it to a PNG instead of a GIF. So what we're doing is we're downloading the GIF, putting it on the disk, and then we're changing the size and changing the encoding. Sorry, I kind of confused you a little bit, but I wanted to do both just to show that it could. And then it's just going to work. Nothing up my sleeve, ladies and gentlemen. And bam, you can see it's actually writing it out to disk. And when it's done, which it is, you can see here is the full-sized. That's not working for some reason. It is there, trust me. And there is our thumbnail. I wonder why this one isn't working. I'll have to figure that out. Oh, there it goes. I was just impatient. It was still loading. So you notice how this is animated, whereas the actual preview is not animated. That is in part due to the encoding, which is right here, encode PNG. So let's see if we can go encode, and I'm not sure how that works, but you could do encode GIF animation, and then you would have to do the animation part. I'm not sure how to do that, to be brutally honest. It's kind of out of the scope of this tutorial, but just wanted you to be aware that that could happen. So that is a pretty complex little application in a very small package. I'm really impressed by how Dart packages work and how everything just kind of fits together. And I wanted to kind of do this tutorial before we, just head first into Flutter to show that you can get this level of complexity in a very small, simple to easy to use package. So if it seemed a little bit confusing, it's because it's kind of a confusing topic. And there's a lot of information that we're skipping over. Like we haven't really touched on encoding and decoding. We haven't touched on HTTP get and put and delete and all that stuff. We also really didn't talk a whole lot about the real under the hood differences between these image formats. But you can see now how to actually download a file off the internet and then work with it using the image package. Whew. A lot of talking. I think I'm spent. That's all for this tutorial. I hope you found this educational and entertaining, and thank you for watching. Oh, and be sure to visit my website, voidrealms.com, for the source code for this and other tutorials. Hey everybody, this is Brian, and welcome to the 19th Flutter tutorial. Today we're going to actually start working with Flutter. I'm so excited. Alright, so just for reference, you need to know Dart, which is a programming language. You can find that at dartlang.org in case you skipped the other tutorials. Flutter's main page is flutter.io. Now there is a lot of information here. I mean tons. This is very heavily documented, even for being an alpha. I was very surprised. We did actually already install Flutter, but if you haven't already, if you haven't been following along, go ahead and install it for your OS. It's just dead simple on how to do it. Really, you just go to your operating system, follow the directions, and boom. Now, before we do any of that, what we should do is do what's called Flutter Update and Flutter Doctor. Maybe it's not update, maybe it's upgrade. There we go. So do Flutter Upgrade, and then it will actually make sure that everything's up to date and everything's the way it should be. And I think it actually runs Flutter Doctor for us, but we're going to run it separately just so I can show you what it does. We've been working with this for a while, and because it's in alpha, it's going to change very rapidly. So we want to make sure that we have everything up to date before we really start diving into this. All right, now some prerequisites here, and I'm going to actually run Flutter Doctor just so you can see the prerequisites. Wow, can't not spell doctor. When you run Flutter Doctor, it will make this nice list for you showing you, hey, if you try to work with Flutter, this is where you are. And you see how mine is nice and beautiful. It's got little check boxes next to everything. It's saying we have Flutter on, and then I have it on my virtual machine. And we have the Android tool chain. What this means is I already have the Android SDK, I have Android Studio, I have the Android NDK, and all that stuff actually on there and configured. I know it says on my screen I do not have an NDK, but I actually do. I just haven't pointed it anywhere. And then I have Android Studio installed. I have IntelliJ Community Edition. I have no connected devices, but that is easily solvable. Once you install the Android toolchain, especially Android Studio, you get what are called virtual phones or virtual devices. We will be working with virtual devices in this tutorial. So before you go ahead with any of this, whether you are on Mac, Linux, or Windows, I would highly recommend that you stop what you're doing, actually pause this video, and go out and download either Android Studio or iOS with Xcode. I'm going to be working with Android Studio. I may later work with iOS. Video recording works a lot better on my Linux virtual machine than it does on my Mac for some reason. Everything that you do in Flutter should work on both iOS and Android. So have no fear which one you're working on. They may look a little different, but under the hood they should work. Now, once you have those installed and configured, come back to this point in the video. I'm not going to cover how to do that because it's going to vary drastically on your operating system and your configuration, and there are literally thousands of videos out there. So go to Google, go to YouTube, look on how to install Android Studio, actually go out and do it. All right, once you've got that, come back, run Flutter Doctor again, and once you have all these check marks saying, hey, you're good, you could probably go ahead and work with it. Now, on my Mac, I can work with it, but it's saying that I'm missing some dependency on Xcode, which is just blasphemous because I work with Xcode almost every day on personal projects. So, without further ado, let's actually create a new project. Now, this time, instead of Dart, we're going to click on Flutter. You notice how we have a lot less options, and if you don't have the SDK pointed, it's going to say install SDK. It makes it very nice and simple for you. Now, this is where things get really super interesting with Flutter. Notice how we have this nice, beautiful list of options, and I was blown away when I first saw this. We're going to say first Flutter, not fist Flutter, jeez. Fisting Flutter. Boy, I'm sure somebody out there is laughing pretty hard about that. One of the devs is like, hey, Brian's going to fist Flutter. Anyways, so we've got our name, we've got our location, we can give it a description. You can give it a type. We want to do an application. Organization, your company. This is pretty standard naming convention. It's backwards from your DNS name of whatever website you have. So in my case, it would be void realms. Let's actually do that. I am not good on the typing today. All right, then notice how there's an Android and an iOS language, and that's because it builds an application for Android and iOS. And you can choose which language, because you can do it in Java or Colton. You can do it in Objective-C or Swift. I'm just going to leave those as the defaults, and then I'm going to hit finish. And this may take just a second as it builds our project in the background for us. All right, so first thing we get is this big, beautiful project, a lot of code. And it's pretty well documented. You can see there's huge chunks of documentation in there. Whoops. And it's got all of the packages that we need already in there. It's got the Dart SDK, it's got Flutter for Android. And you notice how that says flutter.jar, because we are working with Java for Android, even though we are actually working with Dart and Flutter. The project structure is a little bit different than what we're used to. You notice how we have an idea folder, we have an Android folder, which is actually our Android project, and we have all our Gradle settings and all that you would expect from an Android project. We also have an iOS folder. We have a test folder, and then we have all the things that you would expect, including our pubspec.yaml. Now, one thing to note is this uses material design, and we'll get into material design in future tutorials, but just understand that that is a necessity for this to work, and it should be under the Flutter section. Now, there is one folder called lib, and in there is main.dart, which is this beautiful file that we're looking at now. Let's actually minimize that so we can see this code. We're going to just go through this code. There's no sense in retyping all this. It did it for us. And you can see how we have our main, and that is just calling run app, and we're making a new my app. My app is a class that extends what's called a stateless widget. There's stateful and stateless widgets. Stateless widgets have no concept of what a state is. Stateful widgets hold a state. So what is a state? A state is, well, think of it as a variable. I don't know why they didn't call it like variable widget or something, but state is kind of like the de facto language in the mobile world. You have to have a certain state. So if you are, let's say, on your phone and you type something, that is part of the state, because if you minimize that application, some operating systems will actually either suspend it in memory or just flat out delete it in memory. And then when you bring it back up, you have to restore that state. You have to put it back the way it was. So think of a state kind of like if you're married and like your wife's attitude. You say, hey, you want to go get tacos? And she's like, no, I hate tacos. Well, now she's mad at you because you want tacos. That's her state. But then you say, hey, let's go get a pizza, and then suddenly she's happy. So that's what state is. So we have two different things. We have stateless and stateful. Whoops. Stateful. So we're running an instance of my app. This is where things get a little weird. We have a stateless widget. That is called our root widget, meaning everything else is a child of this, of some type. You can see how in there it has a build method, which is returning a widget. Everything is a widget. Widget is just, if you're not from the United States, widget is just a generic term meaning it's a thing. Every widget will return a build function, or will have a build function which returns a widget. What the build function does is it marks things in memory based on their state, meaning what has changed. And you can see we've got some properties here. We're going to return a new material app. Now, we mentioned material before in our pubspec YAML. Uses material design. Now we have a material app. We're going to get a little more in depth in this, but really just think of this as like a blank piece of paper in front of you. And on that piece of paper, you're going to draw out all your little widgets and everything that you need for this to function properly. And on that paper, the first thing we're doing is saying the primary color is blue. And you can see in the directions it says, basically change it from like blue to green. We'll do that here in a minute. And then the home property is a new My Home page with a title. My Home page extends a stateful widget, meaning it knows there's a state, it knows something's going to change. And then we have our little constructors here. And then there is our actual state right here, this string. Notice how it's saying create state underscore my home page state, which means it's a private class, because that is how Dart denotes scope between public and private, is that little underscore. And it extends my home page. Well, my home page is here. So we have my home page creating underscore my home page state. My home page state is extending my home page. So you have a bit of a circular reference here, and this gets very, very confusing very early on, because you're like, I don't understand why my home page just can't have everything that I need. Why are we doing this twice? There was a very long article, and I wish I had remembered it, but basically it said that the stateful widget is just a container, if you will, and container is actually not the right word. They used a different term, but it basically holds the state, where the state itself is what's going to change. See how this is underscore my homepage extends state, meaning we know it's going to change. And the type of state it's going to change is the my homepage. Bam, this guy. So that's what we got. Now, and when I say that's what we got, that's just a property of the my homepage. The actual state is this underscore my homepage. If that sounds confusing, it's because it is very, very, very confusing. So Flutter developers, if you are watching this, please make that simpler. Make it more easy to understand, because I spent about an evening with a cup of hot chocolate just cursing at my laptop screen trying to figure out what you were doing. But once you think of it as, you're going to create state, that the state you're going to create is just simply this my homepage, and just drink the Kool-Aid, accept it as is, then it makes a little bit of sense. So the my homepage state, because that's what that is just simply going to increment a counter, and then there's the counter we're going to increment. Notice how in this increment counter there is a set state function. Or I should say set state method. And it literally says this call to set state tells Flutter Framework that something has changed in the state, which will rerun the build method. Remember, every widget has a build method. So in here, we're going to build based on that set state changing the counter. And then in there, don't worry if all of this sounds like ancient Egyptian algebra, we're going to cover this in depth in future tutorials. I'm just giving you a high level overview. But in there you have what's called a scaffold. So the build method of the my homepage state is just returning a scaffold. Think of a scaffold as, well, it's pretty self-explanatory. A scaffold outside of a building. It helps you put things in a certain structure. In that scaffold, we have an app bar, we have a body, and that body has children. If that sounds like a lot to digest, don't worry, it is. It's just the basic structure of a Flutter application. Now we want to run this to conclude this application. So you see how it says no devices? We have the Android Studio installed, and we have an emulator in there. So first thing it's going to do is open up our emulator for us. And we're just going to wait for this to run. Well, that's a little slow, so while that's loading, I'm going to actually just add in some notes here. Alright, so we've got our little Android device up and running. And what we want to do next is actually run this and put it on the device. So we're going to just click this little run guy. So you can see how we're running it on this device, and this is what we're running. And we're just going to, bam, run that, and you'll see it'll actually go out. And it'll start building it, it's initializing Gradle, because Gradle's part of the Android toolchain. I shouldn't say it's a part of the Android toolchain, it's used by the Android toolchain. And then it's going to take just a minute to really build this thing and throw it out there. Once it does, you have something called hot reloading, meaning you don't have to do this every single time. You can just leave the emulator up and running, And as you make changes in your code, in the background, it's going to push those changes out to the device. All right, so real quickly, here is our app bar if you're looking at the code. Here's our home. Let's actually highlight it here. Down in our scaffold, app bar is this blue thing. The body is a new center. Notice how that's a new center, not just center. So center itself is a widget, so we're centering things. And in there we have children. We have a text that says you have pushed the button this many times, which is the new text counter. And it just works. There's the state. You can see the state changing in the background. Now, notice how this is blue. We're going to go in here and we're going to say color green. It's still blue. Let me go in here and save it. And as soon as I save it, notice how it actually changes it. We didn't have to repush anything out. We didn't have to rebuild anything. It did what's called a hot reload. So that's it for this tutorial. I know it's been very informative, and a lot of this is probably still very fuzzy in your mind, and that's to be expected. We're going to start diving into this thing in the future tutorials. Thank you for watching. I hope you found this educational and entertaining. And all the source code for this and the tutorials are out in the tutorial section of my website, voidrealms.com. They're actually out on GitHub, but this just links right to the actual tutorials. On top of that, feel free to join the Void Realms Facebook group, where there is 1,700 plus other developers out there, all different languages, all different walks of life, and we can definitely help out. Thanks for watching. Hey everybody, this is Brian, and welcome to the, what are we on, what the heck? We're on the 20th tutorial, but I literally just published 1819 not too long ago, and there's already like 50 views on each. I have a feeling there's a small group of you out there like watching these as soon as they come out. Anyways, so what we're going to do today is we're going to do the obligatory Hello World application. If you don't know what I mean by obligatory, every time you start a new language or framework, it's kind of like the traditional thing to do to make a Hello World application. It literally just displays Hello World on the screen. We're going to take it a step further because I think those are pretty elementary. And we're going to see what it takes to build a basic application. I mean, we're talking real bare bones here. If in case you're wondering where we're at, we've installed Flutter, we've created our first app, we've set up an IDE, and we've learned Dart. So we're in the tour of the framework, and we're actually on this second bullet point, Hello World. So we've taken this code, Hello World right here, and we put this into a new Flutter application. And we've got our emulator up. Ta-da! And we're just going to run this thing. Now, I have kind of a bone to pick with the Flutter developers because this is a little misleading, and I'm going to explain in depth in this detail in this tutorial why it's misleading. You can see how it's Hello World. So it literally just displays something. Bang, our job is done. Not quite. Let's say we wanted to put a button here. Well, you can see, let's just pick this apart. The import package flutter material.dart. We're going to talk about material a lot. Main, we have our run app, which is kind of the starting point of any Flutter application. And in there, we're going to say it's going to return a new center, which is just going to center everything. The child of that is a new text. In that text is Hello World with a text direction of left to right. Now, for that to work, uses material design true must be in the Flutter section of the pubspec YAML. Remember, burn it into your mind. We are going to talk about material a lot. So, looking at this, I thought, well, it'd be cool if we could just see what's out there. So I clicked on Widget Catalog, went to the basics, and said, oh, these are kind of neat. Hey, they have a button. Buttons are always fun. So let's just view the documentation on this and say, yeah, let's just throw a button out here and see what it takes to get a button on here. So it seems like it's pretty simple. We could just take this, new raise button. Notice how it's nice enough to put the on pressed equal null for us, so we can actually link that to a method. And initializing hot reload, and notice how nothing happened. So we're going to kill this. Typically when hot reload doesn't work, it means there was a problem. And it says some elements were changed during reload but did not run when viewed as assembled. You may need to restart the app for the changes to take effect. So let's run this. Let it rebuild. And I have to apologize if my voice cracks a little bit. I feel like I'm coming down with a cold or something. It's like first snow of the year. It's pouring snow outside. I live in Michigan, so I'm sure I'm coming down with something. So as you can see, mistakes were made. All right, so this is the same error message over and over again, separated by this line. So we're just going to start reading here so you can actually see it. It says no material widget found. Material button widgets require a material widget ancestor. In material design, most widgets are conceptually quote-unquote printed on a sheet of material. In Flutter's material library, that material is represented by the material widget. It is the material widget that renders ink splashes, for instance. Because of this, many material library widgets require there be a material blah, 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 blah. Really what's that saying is your root widget here needs to be a material widget. It needs to inherit material design. Now, what do I mean by material design? This is where you kind of have to take a little bit of a leap of faith because it doesn't really transition smoothly into this. You can see how there's basic widgets and then using material design. So I kind of think material design should be up above. But there is a whole material design guideline here. And you can see how there's a material app. Really what it means is conceptually, think of your application as a desk, and on that desk you're going to put a piece of paper, and on that piece of paper you're going to start drawing your widgets and scaffolds and app bars and all those neat little things. So click on Material App and you can see how overall satisfied with Flutter. Well, I'm going to put somewhat because we've had a boo-boo. No, sorry Google, I'm not going to fill that out. All right, so maybe if I wasn't doing a tutorial when you popped up, I'd fill that out. But you can see Material App is an application that uses material design. All right, so we're headed in the right direction here. And it's a convenience widget that wraps a number of the widgets that are commonly required for material design applications. It builds upon widget app as adding material-design specific functionality such as animated theme and grid paper. All right, and you can see it also says scaffold, navigator, and things like that. So it sounds like a lot of what we need. So what we're going to do here is we're going to get rid of this. And we're going to say new material. Actually, let's not do that. Let's break this out. We're going to extend the stateless widget. We're not going to worry about state in this application. And what we're doing here is kind of just the bread and butter of almost all Flutter applications here. Let's see, new my app. And of course, hot reload won't work because we have a boo-boo here because we're not returning something. So in here, what we're going to do is we're going to return a new material app. All right, so notice how all the little red squigglies went away. So the code thinks it's correct. We still got that error message up, so we're going to kill the app, and we're going to rebuild it and send it out to the device and see what happens here. All right, so pushed it out. Uh-oh, we have a boo-boo. It says, and remember the same error message over and over again is just in these lines. Package, blah, 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 Flutter, source material app, Dart, failed assertion, line home equal null. Home equal null, or home not equal null. Basically, it's saying the home is null. So we need to give some sort of home. We need to figure out what's going on here, right? It's part of material design here, and it's not really well spelled out. At least I didn't find it right away following the Flutter docs. So there's home. It's actually part of the material app. And basically it was an assert call that said, hey, this is null, so we need to figure out what to put here. So let's make a new scaffold. And let's just save this. Notice how it says initializing hot reload and then reloaded, meaning we go back here and ta-da, it suddenly puts something out on the screen. We have a big white box. So what is this thing? And notice how it says slow mode. You may not be able to see it over that clock, but it says slow mode. Okay, so my app is a stateless widget, which is just, a widget. And then the build is going to return or render. Whenever you see return and build, basically we're rendering a material app. So this giant white box is the material app. The slow mode basically means that we have not compiled this for production yet. This is like a debug version, if you will. So it's not really meant for the real world. We're just doing this because we're goofing around on our computer. If we were to send this to like the Apple Store or the Google Play Store, we would want to compile this for production and actually make it so that it's not in slow mode, which we may cover in future tutorials. Actually, we'll probably cover in future tutorials. So you will see slow mode a lot. Don't be alarmed. So this is a pretty plain application. What does the scaffold really do for us? Why are we messing with that? Think of a scaffold, well, like a scaffold. You see these around buildings when people are washing windows or painting. They're just, structures that you put up so that you can get to different parts of the application or different parts of the building in that analogy. So what we're going to do here is app bar equal new app bar. Let's actually say Flutter. Hello, Flutter. And you can see hot reload worked. So suddenly we have a app bar. So the app bar is this top blue section. And really all this does is it lets the user know what you're working with, the name of the application or what page in the application, and you can put buttons and things of that nature up here. Think of it like a giant toolbar. Now this extra white area down here is called the body, and that's what we're going to work with next. Body would be the body or the working area that the end user would actually work with here. So we're going to say new center, and then in center, we're going to say child, new text, save that, hot reload will pick it up, and then bang, centered is our hello world. So remember the whole goal of this is we just wanted to put a button on the screen. So let's figure that out. Let's get rid of this. So we're going to put our new raise button and save this. And notice how hot reloaded that time. So this little gray thing is actually our button. We want to put some text in there so we can kind of see what's going on here. Let's actually my button. And we'll break this out into a new line so it's easier to read what's going on here. Whoops. There we go. So very faintly grayed out, it says my button. It's grayed out because we don't have an on press in here. So we have our app bar, we have our body, and in our body is centered, we have our button. So why didn't this work before and why is it working now? That's the million-dollar question. Remember at the very beginning of this, when we tried adding the button, it said it needed an ancestor of material widget. It needed material design. You're going to hear material over and over and over again. While you don't have to use material widgets in material design, you would be fighting a massive uphill battle. Kind of the de facto way of doing things in Flutter is to use material design. That's why I wanted to start this with the material app, because it's the bread and butter of what you're going to be working with in the future. So that's why it's working now, because as you can see, the button is actually part of this widget tree, and the root of that tree is a material app that has all the material goodness that we need. Whew. So that is a lot of talking. I hope you found this educational and entertaining, and we're going to work with this a bit more. I think the next video we're going to actually do some basic layouts and just kind of figure out how things are laid out. But I wanted to show you just the bare bones Flutter application, like a real quote-unquote application, not the little hello world they had on their website. If you found this educational and entertaining, be sure to visit my website, voidrums.com. We have the source code for this and all other tutorials out in GitHub. And if you go to contact, there is a Voidrum's Facebook group, completely open. Anybody can join, and we have like 1,700 programmers, all walks of life, all languages out there that can help you with any questions you have. Hey everybody, this is Brian. Welcome to the 21st Flutter tutorial. Alright, so in this tutorial we're going to be continuing our conversation about material design, but we're also going to be just kind of looking around here, and if I can find it, yeah, basic widgets. We're going to cover the row and the column classes and kind of hunt and pick and see what they do. Definitely recommend going out and reading their little I want to say their documentation plus the sample code. I was going to call it something fancy, but the word escapes me. All right, so we're not going to do their code, but I'd highly recommend you use their code and you kind of play around with it, figure out how it works. We're just going to dive right in here. We're going to create a whole new project. And we're going to call this Basic Layouts. Now, if you're wondering why I'm not going to cover their examples, is because, well, their examples are on the web. You can just quite simply copy and paste those into your app, and they should, quotey fingers, should just work. Also, it's really because I kind of want to do something a little more advanced than just the bare basic here, plug this in and talk about it for 3 hours. So we're going to wipe all that out, wipe all this out. All right, so go in here. You can notice how test has got a little problem here. We're just going to delete that. If you're wondering why it has a problem, it's because it's referencing the My app, which we just deleted. We're going to actually create that, though. We're going to extend the stateless widget again. All right, so what we're going to really be covering in this is the row and the columns, and we're going to intentionally make this application very busy, a lot busier than it really should be. And when I say busy, I mean the code is just going to be a complete mess, and there'll probably be a lot of mistakes, but I just kind of want to prove a point here. And don't worry, we're going to fix it in the next tutorial, what it really should be. But I just want to show you how kind of spaghetti codish this could be a little bit. But even though it is spaghetti code, it's actually still very easy to work with here. So we're going to build a material app. All right, so we've got our home and our material app is set. Let's actually build this and push this out to our emulator just to make sure we'd have no problems going forward here. It's going to take just a second for this thing to compile. All right, so as expected, we have our big white box with our slow mode. We're going to go out here. Now that we have our scaffold, something we want to do is actually make the body here. We're going to add an app bar too, actually. Now, someone had already emailed me and said, hey, why is everything an object? This gets a little nuts having to say new text just to set the title. That's a good question. It's because it uses Dart in the background. It's the underlying language is Dart. And because in Dart, everything is an object. So everything's a class. All right, so the body of this, we're going to just make a new container. And we're going to use container simply because we want to be able to use some padding in here. And we want to say 32.0 just because why not? And then we want to, Let's just play around with this a little bit here. We'll say child, new center, and in child we're going to say in center we're going to say new child equal new column. And here's our actual column. Now the column is going to go from top to bottom. And in that, we can say children. You notice how this is different from child. The first thing it's doing is it's saying, hey, this is templated. So it's going to hold a type of widget, and then here is our actual array. And through the magic of copy and paste, there's going to be a whole lot of copy and paste in this tutorial. Initializing hot reload, and you can see it reloaded. So here is what we've got thus far. So we've got our app bar, we've got our body in our scaffold, and the scaffold has a container. And think of a container just as a glass box. It's see-through, right? So in this box, we've said we want the padding to be 32.0, which is why we've got 32.0 from the top. If we got rid of that center, it would also be 32.0 from the edge here, but we just wanted it centered. Now, in that center, we have a child called a column. The column does top to bottom. The widgets that we have in there are three texts, hello, and hello, world, and then the exclamation. So bang, 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 there's our three. Pretty simple, pretty easy to use a column, but as you can see, our text starts getting a little crazy in the tab markers. These lines keep going out and out and out and out, and it gets kind of nuts here. So what we want to do next is we want to say new row, and you can see how the tab marker goes out again, and it gets kind of crazy here. We're going to do cross-axis alignment, center, so basically we want to center everything, and then main axis alignment, we want to center that, and then from there we can add our children. Notice how this is once again templated. It's a templated array. Is that even the right term? Templated array. It's expecting a widget type, and it's an array. So we're just going to grab some hello world here, dump that in, and let's see if hot reload picks that up. Looks like it did. So there's our hello world. So that's going across here. Not liking that too much. There's no space between hello and world, so let's actually get this out here. Let me look at this for just a second, see how we want to do this here. All right, let's do this. Let's get rid of this guy. And we're going to say, actually, we can probably just, no, let's do this. I'm deviating from my notes. That's why I'm sitting here on the fence about something here. Sometimes I like to just play around and do things because the notes get kind of boring, because by the time I've recorded this video, I've already done it 2 or 3 times. So we're going to pad this by 5. And then from there, we're going to say and we are just going to grab these right here because I just don't feel like typing that out again. So now you can see how we have got our rows and columns. That was my chair that made that noise. Hope this thing didn't just break and dump me on my butt. All right, so let's find this little guy, and this is very helpful. Where you click on one of these endpoints here, it'll actually highlight where it begins. So we're going to grab this, comma, comma, and hot reload picked it up. So you can see now how it is our hello world on the top, and then we've got 3 on the bottom here. So what we've really done is we've got a column. So here's the first one, here's the second one. And in that second one, we have a row. We have bang, 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 and in each item, we've got another column. So that is kind of crazy how you can lay things out, but you can get really precise with just rows and columns. I'm kind of surprised. Some other mobile frameworks, rows and columns completely suck, but with Flutter, it's actually not bad. I mean, you get pretty nice precision here, and you can just add on and on and on. But as you can see, what happens to your code is it starts pushing out, and you get these tab markers, these lines that go out and out and out and out, and it's not uncommon that you get way out here. So you really need to, and we're going to cover this in a future tutorial, how to kind of shrink that down a little bit and compartmentalize or make things into components or widgets. Ideally, you could actually take this whole hello world thing and make that way you don't have this spaghetti code going out. So that in a nutshell is really how to work with rows and columns, and it's super simple, super easy. I kind of wish this was like a long drawn out tutorial, but it's really just not, because they're so easy to work with. Kind of the major takeaway from this is that when you're working with these, you should kind of check the axis alignment, and you can put things where you want. And then the children property, not the child property, the children, because it can hold more than one, is templated. So you can say widget, and then you can actually change that if you wanted to. Not recommended, but you can change that if you want to. And then it has an array, and you can see how that's everything that's in that array. And then you can, see here again, that's everything in this array. Pretty similar, both row and column follow the same design pattern. So that's it for this tutorial. I hope you found this educational and entertaining. Highly recommend going out reading their official documentation. The source code for this and all other tutorials will be out on voidrealms.com. You just click on that, it takes you right out to GitHub. And you can join the Void Realms Facebook group, which has really close to 1,800 other programmers out there, all different languages. Hey everybody, this is Brian. Welcome to the 22nd Flutter tutorial. Alright, so we're continuing where we left off with our basic layouts application. We're going to kind of clean up the spaghetti code a little bit. As you can see, this gets kind of unruly, and we've got some stuff. So this is a basic design pattern is really what we're going to be doing. We've got this hello world, and let's actually run this in case you missed the last video. You can see exactly what's going on here. We got that hello world repeated. We've got rows and columns, and it's just really simple, just stupid layout, right? So you can see in our application we have some repetition. Hello world, hello world, hello world. So that's all repeated. So what we're going to do is we're going to take that hello world, each one of these, and convert it into its own full-blown widget here. That way we can get rid of some of the spaghetti code. So the first thing we need to do is let's actually make a new Dart file. And we want to import the Flutter/material because we're working with material design, right? Now, really, it's not that bad making a whole new component. I thought this was going to be like a huge, long, drawn-out tutorial. It's really not. So we're going to extend a stateless widget. Help if I could spell widget. And remember, the build is, whenever you see build, think render. So we're not building a widget, we're rendering a widget. So this is what we're going to actually render on the screen here. And because it returns a widget, we need to, you guessed it, actually do something here. So let's go back to our application here, and you can see we've got some design pattern going on. So there's this, let me get rid of this so we can see. You can see container, container, container. So let's actually just borrow that, right? Let's find our endpoint, which is this guy. grab that, copy and paste it, put a semicolon, and bang, our component is now done. So really all we're doing is rendering that hello world inside of its own little container with its padding and everything. So let's actually go up here. We're going to import the hello.dart. And now that we have that import, you guessed it, what we can do is just get rid of this. Let's grab this little guy. And we're going to get rid of these three right here. Just put our hello widget. So I'm going to actually kill this app. That way it'll rebuild the whole thing so you know there's no trickery on my part going on here. So let's save that, rebuild it, run it out, push it to the emulator. It'll take just a second, but it should look exactly the same. The real difference here is that we have pushed that snippet of code into its own little widget. That way we're not retyping that over and over again, and we can just reuse that. We can even extend it if we wanted to. It makes our code a lot easier to handle and a lot smaller too. You can see we still got this this tab line going out further and further and further, but it's not as verbose and it's not as spaghetti as it was before. So it's a lot more manageable. Just wanted to do that quick tutorial because I've already had a few questions on design pattern in Flutter, and we haven't really gotten there yet, but I kind of wanted to cover that early on. And in a lot of my future tutorials, I will actually use this sort of design pattern where I break everything off into its own file, simply because I don't want these unwieldy, 3,000 line text documents. All right, simple, easy. Hope you found it enjoyable and entertaining. And the tutorial will be out on voidrealms.com. Click on tutorials and then go out to GitHub. And I know I say this every single tutorial, but we have a Void Realms Facebook group with almost 1,800 programmers in there. Basically, I'm pushing this because everybody in there is very helpful. I've even asked a lot of questions and gotten a lot of feedback, so it's a good resource to know. Thank you for watching. Hey everybody, it's Brian. Welcome to the 23rd Flutter tutorial. Today we're going to be talking about two things, the app bar and state. State is kind of this weird, ambiguous term, but we're going to try and break it down a little bit. Before we really dive into that, if you go to flutter.io and you click on sample catalog, you'll see there is full sample code to, well, pretty much complete applications, and it works. I'm just amazed that this is in alpha and everything's working so far. It just shows the amount of brain power that's really gone into this. Now, what we're going to be doing today is working with the app bar, which is this little blue bar, which we put up there, but we're going to put buttons up there and make those work. We're not going to blatantly rip off this demo that they have up here. I'll leave that for them. But I want to kind of key in on some other things. So I've got a new project up called app bar demo, and we're just going to start typing away here. So import, and we're going to import the Flutter material.dart package. Remember, we need that to work with the material apps. And then we're going to say and we're going to do run app. And in case you either don't remember or didn't watch any of my previous tutorials, run app is kind of the main entrance point to your application. So without run app, nothing runs. We're going to leave that blank for now. We need to make two other classes real quick here. We're going to extend the stateful widget, not the stateless widget like we've done in the past. And then we're going to make a private class called myAppState. Extends state, of my app. So before we really start fleshing these out, what are they? Why do we need them? Okay, well, the first thing we're going to do is we're going to do main, and then we're going to run app. So we're going to run my app. An instance of my app will be created. I actually should create that. There. An instance of my app will be created and shoved out into memory. Now, I shouldn't say shoved out in memory, shoved out to the emulator, which I'm going to actually boot that up while I'm talking here. And then I'll just go off to the side while it starts up. Now we have the stateful widget and state. Now in the past we've worked with stateless widgets. What's really the difference here? Well, a stateful widget and even a stateless widget is what's called immutable, meaning it will not change. And I'm actually going to put this, will not change. Okay, well that's great, but we want to actually change something on the screen, so what we need is a state, which will change. Man, I cannot type today. So to get these two to work together, what we need to do is we have a stateful widget, and we're going to actually override the create state. So effectively what we've done here is, it looks like a bit of a circular reference, but we're saying the my app state, which extends state, so just don't think of this as my app state, just think the state is going to be the state of my app, this guy. So our immutable widget will have a state inside of it. Now, in our state, the my app state, we can do certain things. For example, we can say string, oops, that's great. We haven't really done anything there. And let's say my state. Let's make this private as well, just to have a similar code convention here. Now you notice how it's already barking at us, and it's saying it's missing a concrete implementation of state.build. Remember in previous conversations, whenever I said build, think of build as render. We're going to build or render the widget. So we need to override, and then we're going to say widget. There, now we're actually not doing anything. So we need to combine some of the knowledge that we've learned in previous tutorials, being material app and scaffold. So first thing we're going to do here is we're going to return a new material app. And don't forget your little semicolon at the end or it will get mad at you. And we're going to say the title is the title variable. And we want the home to be a new scaffold. Now this is where things get a little interesting here. Remember, we're building this in state. You really don't have to do that. You could actually have this as a stateless widget and then have certain parts of it be stateful. But for this example, I want all of this to be the state. Because it gets a little kind of cumbersome and complex when you're doing only certain parts of it. I want you to understand what's really going on under the hood here. So we've got our title, we've got our home, and then in the scaffold we want a app bar. We've talked about this before. And in our app bar, let's just get that in there. I'm going to set that to the title variable as well. Now, what's it barking about here? String can't be assigned to the parameter type widget. Why are you doing that? Oh yeah, because we got to put a widget in there. My bad. That screwed me up for like a microsecond. I was like, what is going on here? All right, so we've got this. Now that we have our home, we want to put in a body. And we're just going to say the obligatory hello world. And actually, let's change this around a little bit. I want this to be a little fancier than this. We're going to put in a new container, padding. Don't know why I picked 32. Just good old days when icons were exactly 32 inches, or 32 inches, geez, 32 pixels. That's the kind of day I've had. And we're going to say new center for the child. If you have no idea what I'm doing, this really should be old school for you by now because we've been doing this for like 20 some odd tutorials. And then we're just going to pump our new text right there. Now remember, everything in Dart is an object. So we're going to go ahead and run this on our device. Whoops. Actually, let's do this. There we go. And we're going to just basically thing builds and runs. If it doesn't, then we'll resolve any issues that we have. I'm fairly confident it will run though. Now, I did have some feedback, and I do try to keep up on feedback, but my inbox is just looks like a bomb went off at any given moment. So it's really, if you email me, it's luck of the draw. That's why I keep pushing for this Voidrum's Facebook group. But they said, why does it take so long to build? Well, you have to kind of have respect for what's going on under the hood here. Is you're taking a language, compiling that into another language, and then compiling that into a whatever the device needs, and then pushing it out to the device. So there's a lot of middleware going on there. All right, so here's our app bar. Here's our hello world. So far nothing's happening. We can't really click on anything. So what is state? Okay, well, what we want to do is we want to change this hello world depending on some sort of user interaction. That's the state of the application. Think of state like you have a parent. You're going to go ask your mom, hey, mom, can I go stay over at a friend's house? Well, depending on her mode, her state is going to depend the answer you get back, right? So we're going to just jump out here into the app bar. And this is why I do like, pushing these out into different files because they can get a little big. But for this example, I'm just going to keep everything all nice and neat. And we're going to say actions. You notice how this takes a list of widgets, but it doesn't give you the actual code you need. So you need to say widget. And there we go. So we're making a list of widgets here. And then we're going to say, what could we put in here? Well, we could put just about anything we want because it's a widget. So we can even say like new text. We'll just say la 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 la. And let's do that. Save that, flip back over. Uh-oh, didn't like that. Oh, it's because I got that in there. There we go. And you can see there's our text up here, la 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 la. Now, what that really means is we can put anything we want up there because everything is a widget. So let's just start putting things in there. Let's say we're going to say new icon button. And notice how it asks for an icon and pressed. So there's two properties that we're going to have to fill in. We really don't have to because they're null, but it would probably be a good idea if we want any sort of real functionality here. New icon. And then we're going to say icons dot, and then we have tons and tons and tons of icons to choose from here. I'm just going to grab some at random. I'm going to say like add alert. And then on pressed, we actually want to give this a function. All right, so here we're just going to say, and if you're wondering what this is doing, this is basically saying, hey, use this function and call this code. Now, notice the syntax here is a little bit different. We're saying press, semicolon, and then we have this anonymous function. Here's our scope brackets. We've talked about scope before. And here is the code we are using now. Notice the underscore, meaning this is a private method. You can't call this directly out of the class. And then here we're just going to print the message. That way we can see what's going on. And we're going to grab this a few times. Uh-oh, what's going on here? I forgot my commas. Now, some things to note right off the bat. is A, we're sending it an array of widgets. B, the icon we chose is over on the left here. Gives us a nice little preview of what we're going to do here. And if you're wondering how these icons actually got into the application, well, they're included. That's right. You heard me correct. They're included. I don't want print. I want to say people. Is there a people? There is a people. So you can see how we have like an alert, a print, and a people. And if we actually run this, I'm going to stop it and just rebuild the whole thing. I was seeing some errors popping up there. I just wanted to rebuild the whole thing, make sure it's going to work here. All right, so we've got our beautiful little icons, and let's say print pressed and people pressed. I like pressing people. People piss me off sometimes, so I like pressing them. All right, so we had our hot reload, and let's just click this. You can see nothing happens. So, I mean, on the screen nothing happens, but we can see here we're getting a lot of action. And what's going on under the hood is we're actually reading directly off the device, and there's our print statements. Print pressed, people pressed. That gives you a good way of telling what's going on in the application. So what we want to do now is when we click one of these, this guy right here will update. That's called application state. So far we haven't actually done anything with state. So because we're calling this method, we know that we can do some things. The first thing we want to do is actually change a variable, which we're going to change this my state. And let's actually do this. So what we're doing now is the child in here of the center is going to be the my state variable. So you can see it's now blank because we have absolutely nothing in my state. And let's just type in no state. That way it's pretty obvious what's going on here. I didn't actually like that. Let's rebuild it just because I want you to see that that variable equals no state. And what we're going to have to do once this is built and gets up and going is we're going to actually have to call something called set state. And what set state does, yeah, you can see now there's no state and nothing's changing because we haven't changed anything yet. But what set state's going to do is it's going to set the state of this variable. I mean, for example, if we just say my state equal test. Actually, let's set it to the actual message. Let's see what happens here. Hot reload should have taken. I'm going to reload it anyways. And we're going to just, you see how nothing's happening. We're even going to kill the application and restart it. I know it takes a little while to recompile, but we're going to push it back out here just so that we can see that nothing's happening. Give it just a second. It should pop up. So there's no state and nothing's changing. Now we are changing the variable under the hood, and we can test that by actually doing this. See, our print is still working. You can see how there's print pressed down here, there's alert pressed up there. So we know that variable is actually changing, but the state is not changing. That's what I'm really getting at here. So what we're going to do here is we're going to say set state, and you notice how it calls out a function. So what we're going to say is maybe there we go. Just going to make a simple little anonymous function in here. And in our set state, we're going to actually update the state. This is going to be a little confusing because it's literally the same thing that we've just done. We just did this. Set state takes, and this is a little difficult to explain, so bear with me, but there is a memory map under the hood called state. And what set state does is says, hey, find the key that has this variable and set the value. Unless you do that, the state's not actually going to change. So let's run our app again, see what happens now. And while this is compiling, because it's not there yet, basically we have our material app. In our material app, we have a scaffold. You need the scaffold to kind of build things up. In the scaffold, we have the app bar and we have the body. The app bar, we have 3 icon buttons. Each button has a built-in icon that we can preview over on the left, and it's calling this pressed method. And then in the body, we have a container, which has a child of center, which has a child of text, which is actually reading the myState variable, which is right up here. We're changing that, you guessed it, in the set state. So you see how we have no state, now we have alert press, now we have print press, now we have people pressed. This is needed because if you go like this and you just kind of jump over to a different program and then kind of jump back, you can see the state is saved. If you didn't have the set state, that would blank out and everything would go right back to default, which if you've ever worked with any sort of like Android programming before using Android Studio, you've noticed that right off the bat, how you have to load the state automatically. Well, or you have to load it manually, where this is all loaded automatically for you. I have to say, this is a lot easier to work with than some other things that I work with, such as like MobX and Redux and things of that. Redux just broke my brain. I must have spent 2 weeks playing with different applications trying to get it to work correctly, and I absolutely hated Redux. MobX was a little better, but I think this is really fluid, really simple. So while we're on the topic, because I did say we're going to work with the app bar here, what kind of things can we put in the app bar? I mean, we know that we can put text in here. We can put icon buttons. You can see, well, maybe you can't see it because it's under slow mode. I hate that little slow mode ribbon. Let me move that up here. You can see there's our text. Let's try to add a raised button. Why not? Whoops. So there's our raised button. And what we want to do here is we want to say, we just want some text on there. And we've done this before. I think we had it in the body, actually. But what we want to do now is actually just put it in that app bar. And I don't think we actually made the button work in the last tutorial, so let's make this work. I'm going to call this Super Button of Doom. Why not? It's been a Monday. Build that, and you can see now we have our text, we have our little icons, and we have our Super Button of Doom. So you can put pretty much any widget up in the app bar. It's not really restricted like it is in some platforms. And you notice how that the text actually puts these little dots or these ellipticals in there, and we can rotate the device, and you can see how it automatically rotates with it, and then it expands it back out. So it's pretty neat the way this works, and we can do some really cool things. So there's our Super Button of Doom, and that's it for this tutorial. Some quick notes: if you want the source code, you can go out to my website, voidrealms.com, click on tutorials, click on GitHub, and it takes you right out to the actual tutorials. And I've got many, many other tutorials in other languages. If you're so inclined, feel free to donate. My website's 100% run off your donations. And if you're still listening, you're one of the cool people, be sure to join the Void Realms Facebook group. There is, I think, approaching on 1,800 other programmers out there, all walks of life. We can definitely help you out with your projects. If you email me directly, I'll try to get back to you, but it's probably going to take several months at this point. My inbox is just annihilated. That's it. Thank you for watching. I hope you found this educational and entertaining. Hey everybody, this is Brian. Welcome to the 24th Flutter tutorial. I'm going to apologize in advance. I have a bit of a cold and my throat is pretty sore, so I may have to pause the video in certain points. What we're going to be doing today is we're going to actually build a demo application. So the first thing we want to do is import the Flutter material, package. Like I just said, man, this cold is just kicking my butt. Let's see what cold medicine and coding can really do here. So I'm going to run our app. I'm going to say whoopsie. we're going to kind of take what we've learned so far and add a few things here too. So this is going to be a little bit of an adventure for all of us. All right, so we've got our My App, which extends stateful widget, and we're going to have to do some things with that. What we're really going to be doing here is we're going to be building out basic login. And when I say basic login, I mean very basic login. So we're going to say I need dinner ideas. I have a cold and nothing really sounds good. I have like this really hot soup that I've been eating, and I love it, but I'm getting kind of sick of it. It's like if you had pizza every single day, you'd just be like, I'm done with pizza, forget this. All right, so we're just gonna make a new material app. Maybe, that's the cold meds right there. I'm gonna blame every mistake in this tutorial on the cold meds. And my voice is cracking, so I sound like I'm going through second puberty here. All right, there we go. And we're gonna make it login demo, and then we're just gonna make our app bar. Whoops, can't do app bar yet because we need a home with a scaffold. There we go. Friends don't let friends have colds and write code. Man, this is just going slow. All right. Whoa, new flow. What the heck? There we go. New app bar. Jeez. And let's get this. Let's actually do this the right way here. Sorry, I was kind of multitasking there. I was looking at my phone, taking a drink of water, and writing code all at the same time. That takes some skill, my friends, let me tell you. All right, so let's actually change this to please log in. Okay. So really all we've got there is we've got app bar, and now we're going to add some actions here. And then we've got an array of widgets, and we've done this before, so this is really nothing new. We're going to say icon button, and the icon is going to be just a new icon. We'll say icons.home. And then we're not going to mess with onPressed yet. And then the magic of copy and paste. Let's say exit to app. And we're not going to mess with that onPressed yet. We're just going to start our emulator. Let that start up while we're typing away here. You can see it starting in the background. All right, so what is this? Missing concrete implementation of creates. Oh, yeah. Let's do this instead. Don't know why I keep doing that. Extends stateful widget. There we go. And then we can make this extend state. All right, this will be a little better. My app state. And then we're going to say create state. My app state. One too many equal signs. There we go. That should be a little better. All right, so our emulator is up. We're just going to start this application and kick it off to emulator just to see what it looks like and get a basic idea of what we're going to be doing in this tutorial. Now that we've got a kind of the skeleton of the application all set up and ready to go. As soon as this thing finishes building. All right, there we go. So what we've got here is just a please log in with our app bar. Two icons, they're grayed out because we don't have the on press filled out. And then we've got a home and then a log out button. And what we're going to have here is a basic username and password login. And if we're not logged in, it's going to default to the username and password login. If we are logged in, it's going to show the settings screen. Kind of like a poor man's way of password protecting your application. So let's do that. All right, so what we need to do now is actually flesh these out a little bit more. Let's go into our lib, and we want to create two new files here. We'll create login.dart, and let's create settings.dart. And we're going to flesh this one out first. Import package Flutter material. Extends, and we're going to make stateless widget because we don't want this tracking the state here. And we're going to say override. Yeah, I don't know what it is about Michigan and this weather, man. Every time it gets cold, I get sick, which sucks because Michigan's always cold, so I'm almost always sick. It's actually not true. Girlfriend's been sick, so I'm sure I caught something from her. You know, that's usually not a good way of saying something about your girlfriend. I caught something from my girlfriend, but anyways, you know what I mean. Alright, so we're just gonna center in a new child, center in a text, and the text is going to be the child of the center. Alright, and then we're gonna say settings here. Nothing real fancy about this. We just want to show something on the screen. Well, let's just jump back into here. Give me just a second here. Sorry about that. I had to get a drink of water. All right, so we got the package, login app, and we're going to say settings.dart. And down here, we want the end of the app bar. We're going to actually say the body next. And let's jump over to our emulator here. We're going to rerun this. And while that's building, we're just going to fingers crossed. So this is basically what it's going to look like after we log in. What we're going to do next is we're going to actually build the functionality for these buttons and the login. The login is going to be a little bit different because we're going to actually make a custom component in Dart, I should say in Flutter, and we're going to have it use what's called a callback. A callback would be like this right here on pressed. We're going to actually build one of those into our custom component. And that was a little tricky for me at first. It took me a while to figure that out. So lucky for you, I actually did figure it out. I should say lucky for me. It kind of took a while. It was kind of making me mad, to be honest with you. I was like, what the heck? All right, so we've got our title. Now what we want to do here is we want to say, whoops. And we want to Probably help if I did that one correctly, huh? There we go. So as soon as we flush those things in, of course it didn't pick it up, but those are now enabled. We'll have to stop and restart the app. I'm just going to let it compile while I'm typing here. Uh-oh. That's why it didn't pick it up. It's missing our semicolon in there. There we go. All right, so, and of course, yeah, now it's complaining about the semicolon here, so let's push that back out. Suddenly, magically, it works, and these buttons now work. They don't actually do anything, so what we're going to do is we're going to say logging out. There we go. Just so that we can see these actually do work. You can see it's now printing out, and it's printing out again. So we got home, go home, and log out. So those buttons are working. All right. Now what we're going to do is we're going to actually flesh out this login component. And this is going to be a little bit of typing and a little bit of explanation, so bear with me here. So we want our package, Flutter material, and we want our import package, Flutter widgets. There we go. And we want import foundation. What we're going to do now is we're going to say class login extends. We're going to make a stateless widget. And what we want to do here is we want to actually make the constructor, and we want to have a few properties in here. So we're going to say const login and let's break this out a bit. And we're going to make a required property here, and we're going to say this is going to be the callback handler, or I shouldn't say the callback handler, it's going to be the actual callback. And then we're just going to add the key. If you're wondering what a key is, key helps identify the actual component. Just adding that in case anybody uses this in the future here. And I actually screwed up a little bit here. There we go. That way it'll turn that into our name parameters. All right, so we want to avoid callback. And this will allow other people to use this component and call back. And what a callback is exactly what we've worked with in the past here. For example, this icon button on pressed, we're telling it to call back or go to this function. That's exactly what we're doing. We're building this into our component. A little bit of an advanced topic, and it took me a while to kind of figure it out. But it's actually pretty well rewarding. All right, so now that we've got that, we're going to say static final text editing controller. We're going to make a new text editing controller. What a text editing controller does is it allows us to work with a text field, and you'll see that here in just a minute. I realize some of this is probably looks like ancient algebra or voodoo magic or something. It'll be pretty clear once we get there, though. So we're going to make getters for the username and for the password. through the magic of copy and paste here. So the controllers interface with the text field, which we haven't actually worked with before. So we're going to go ahead and build that out now. And this is just the build of a method that we've seen before. And whenever you see build, think render. So what we're going to be doing at this point is actually rendering. So we're going to say return new, and we're going to say column. And we want an array here. So what we're going to add now is, you guessed it, new text fields. And text fields are a little bit different than some other platforms out there. You've got to work with them a little differently. So we're going to add in the controller, and we're going to add in the username controller. And then we're going to say decoration equal new input decoration. And in here we're going to say hint text equals, gives the user a little bit of an understanding of what they're supposed to be doing here. Just going to copy and paste that, and then enter a password. Now, because password fields are, well, passwords, we don't really want to give them the ability to see what we're typing for very long. So what we have to do now is actually say, whoops, obscure text is true. I don't know if that's very viewable. There it is. Obscure text is true. And then, of course, the final thing we want to do is a new raised button. And the child of this is going to be cannot seem to do that today. There we go. All right, and in the onPress, we want to actually call our void callback on submit. So looking at this code, really what's going on here is we have a stateless widget. Remember, we're not going to hold the state because it's stateless. We have in the constructor, geez, cold medicine, we have a key which would help identify this, but we're not really using it in this tutorial. I just wanted to show you can do it. We have a required parameter, and we're using this on submit. On submit is actually a void callback, meaning we're expecting this to call a function somewhere else in some other code. We have text editing controllers, both of them for username and password, and those are being used by these text fields. There really isn't a super easy way of getting the text directly out of the text field. You would use either the onChanged or the onSubmit. And what the text editing controller does is it just holds that into a variable, which we can grab using the getters. So we have the user.text and the password.text. Whew, that is a lot of explanation, a lot of typing. That took me a while to figure out. Now we've got to try to figure out how to kind of comb all this together, if you will. So let's push this back out, make sure there's nothing wrong with the app. It runs as expected. Now, you notice how we've got this new settings right here? Well, we want to kind of replace that a little bit. What we need to do is actually have it so it shows a specific screen. Now, I want to say that this is not the correct way of doing this. You should use routes and navigation, but we haven't gotten to routes and navigations in our tutorial yet, so we're going to use this method. So for more complex apps, please use routes and navigation. Excuse my voice, it's kind of getting a little raspy. But all right, so let's see what we got here. I need to pause the video for just 1 second. All right, sorry about that. I had to get a drink of water. I was really losing my voice there. So now that we have that, we need to do here, say widget screen. And notice how we are not declaring it, or I'm sorry, we're not setting the value of that. We're also going to make a few other things. Well, we can't because we have not imported it yet. Hold on a second. There we go. And then we're going to say settings. I'm going to review this video once I'm done, and if my voice just keeps going in and out too bad, I may redo this whole thing. We'll just see how this works when it's all done. Usually I don't actually watch the videos after I do them. Alright, so you notice how the first thing it does is it says, hey, for the login class, it wants a void callback on submit. And you remember the login class is this guy that we just typed out here. It's because of that required parameter right here that it's actually automatically putting that in there. And then we're going to say and let's just say that may not be what I want here. I am kind of deviating from my notes a little bit here. So for the body, because that's going to change, we're going to use a variable. We're not going to just hard code it and say new. We're going to say during the creation of this, the screen is going to be settings, and as we shift around in this code, it will actually change. So we've got our widgets, we've got our login, and we've got our setting here. Now we want to actually flesh out this on submit. All right, and then we're just going to print out that, hey, we're trying to log in here. Now, if you're wondering where you're getting the username and password from, we are creating an instance of this login class, this guy that we just typed out. And we have getters, username and password, and that's where we're getting those. And they're just reading the text value from, or I should say the text property from the text editing controllers. So that's how you're getting those. All right, now, whoopsie, we need to actually set this. There we go. Let's just stop this, rebuild it, make sure we don't have any errors. While that's rebuilding, I'm going to get a quick drink of water because my voice is going out again. All right, so compiled as expected. Nothing's really going on here because we haven't done anything. So we're going to change that. And we're going to get to the heart of this thing and make it work here. All right, so we're going to set authenticated. And what this is going to do is this is going to set state. And you remember from our previous conversations, when you set state, well, you're setting the state of this screen and in thus part of the application. I'm trying to figure out what to get my girlfriend for Christmas. She gave me a cold and a sore throat. I'm wondering what I should get her in exchange. I don't know. Maybe I'll get her something that makes a lot of noise at like 3 in the morning or something. Paybacks, you know. All right, so what set authenticated is going to do is it's going to set the state. We're going to say if it's off, then we're going to set it a certain way. Otherwise, we want to set it a different way, meaning we want the state of the application to change depending on whether or not they're authenticated. So we're going to set our screen to, we're going to say and then we're just going to grab this guy right here. So if we're not authenticated, we want to set the login screen, and then we're going to say, please log in. All right, so now that we've got the set authenticated method, you can see how it's grayed out, we need to actually use it because it's currently unused. To do that, we want to actually say, so log out. And then we want to, for the go home, go home's going to be a little bit different because if you're already authenticated, you need to actually go in here. So let's say go home. So now we need another variable here. See, this is what happens when I go off script. I really shouldn't do that, but so we're going to start off not being authenticated here. All right, so if that, well, actually, let's do this. Kind of got lost in my museum there. Cold medicine made me space out. That's what I'm going to blame it on. There we go. So really go home doesn't really do anything. It's kind of a pointless button. I'm not a big fan of pointlessness, but so let's save this. Let's recompile the whole thing, make sure there aren't any major issues, and see what happens here. It's still showing settings. Well, let's figure out where we goofed. So here's our screen. Well, that would probably be why right here. All right, so we want to start with the login. Let's push this back out. All right, so now it's displaying, enter username, enter password, and then submit. And if we just enter something, that's not going to work. And then hit submit. You can see that it actually tried to, right here, log in with blah, blah. So what we need to do now is actually say, hey, can they log in? So we'll say, and do not ever, ever, ever do this in a production application. This is just for demo. You will get fired, they will burn your village to the ground, and, well, everybody on the planet will die. Realistically, you would want to go out and authenticate against a database or something of that nature. We just haven't simply gotten to the point in the tutorials yet. So you want to set the authenticated to true at this point, because you have now authenticated them. So let's kill that, push it back out. I don't know why I do that. I really don't need to. I could have just hot reloaded it. Give it a good build, make sure everything works. All right, so we're going to just enter some garbage here. And bang, you can see how it tried to do it, log in with Q and R, but of course we didn't have that. So let's actually say, darn you, caps lock, get off there, user, and let's delete this, and And because we successfully logged in, you can see there's our settings screen. We hit home and it just goes right back. We can log off, log in, things of that nature. Now, home really isn't working the way I expected it to. Let's look at this. If it's authenticated, go to settings. Otherwise, so let's evaluate this little guy here. Actually, let's just do this. I want to see what's going on under the hood there. All right, home false. So let's evaluate this again. All right, so we've logged in with username and password. Let's click on home and see what's going on here. That's why this is still false for some reason. I bet we did not set it in our state. We didn't. See, that's what the problem here is. Really, we don't need to do a set state here, but I'm just going to do it anyways. We really don't need it because it's not part of the application state, if you will. It's just a variable that we're using in the background, but I'm going to set it in state anyways. All right, so now when we run this, we will actually and ta-da, there's our settings. If we hit home, it does nothing because we're currently authenticating. You see where it says home, go home true. The premise of this being if you were to time out or something in the background, you'd hit home and bang, it would just say nope. And we can log out. And if we hit home, see now it just says, hey, you're not logged in. So that's it for this tutorial. I hope you found this educational and entertaining. Some key notes here. This is not, I want to say, the best way of handling the situation, but it's where we're at tutorial wise. So definitely read up on how to extend a stateless widget with required properties and things of that nature. Another thing you should know is I actually ran into a bit of trouble on this, and I had to go out to the support and I had to go out to live discussion with the Flutter engineers, and they helped me a little bit. I kind of figured it out on my own while I was waiting, but I just wanted to put that out there that you can really get in here and ask some really great questions. I think our conversation's actually in here. Yeah, right here. So do not flood these poor folks with all of your little nitnoid questions. For that, I would actually recommend going out to the Void Realms Facebook group, joining up and asking questions in there. And for the source code for this and all other tutorials, go out to voidrealms.com, click on tutorials, and go to GitHub. Leave me some feedback. If my voice is absolutely horrible, I'll redo this whole video. All right, thanks. Hey everybody, this is Brian. Welcome to the 25th Flutter tutorial. In the last tutorial, Flutter 24, we showed a couple key concepts, but one thing that we really kind of drilled in on was how to change a widget in the body of a scaffold. Now, that's actually not the correct way to navigate around an application. It's just a very simple way of switching that widget out. So one thing I want to cover today is how to navigate through an application. Now, when I say navigate, what am I talking about? If you go to the Flutter website, and I have to apologize, I still have a cold, so if my voice cracks or I cough, it might get a little nasty, but go to the Flutter website, routing and navigation, and read up on core concepts. You'll need to understand two main concepts, a route and a navigator. A route is exactly what it sounds like, a route going from point A to point B. You're going to go from your house to your friend's house. How are you getting there? And let's say you want to go back from your friend's house back to your house. How are you getting there? That's really what a route does. Navigator actually takes those routes and makes them do things. Makes your application move from point A to point B. And you can see kind of a simple example here. And we're going to build something as always. So we've got our little application up and it does absolutely nothing. It's magnificent, isn't it? So what we're going to do here is we are going to make a new material app. In that material app, We're just going to say the title. Whoops. I don't want to call it router. Let's call it navigation. Now, a couple things you should note right off the bat. We need to put our routes here, but our routes don't exist yet. So if you type routes, it's going to want to know some things. So we're going to say we need a comma instead of a period. That's why that's freaking out on us there. And in there is where we will put our routes. But as I said, they don't exist yet. We're getting to that point. Now we need our home, and for now we're just going to say null. Let's build this out here. So first thing we want to do is create a new, and I like putting a directory, and I like saying screens. But you can kind of do this just really however you want. We're going to import the material.dart. All I know is I have had this cold for about a week. My girlfriend gave it to me, and I am so over this cold right now. It's just like, it's one of those that started like in your nose and then started working its way down. I like didn't even have a voice yesterday. It was ridiculous. So if I sound horrible today, I mean, yesterday was just really bad. All right, so we've got our build method. Remember, whenever I say build, it means render. So we're going to actually render something onto the screen here. We're going to return a new scaffold. All right, now in our scaffold, we're going to say @var now we want a body. And this is what we were swapping out in our previous tutorial here. But this is what we're doing today, routing and navigation, is the actual correct way to do it. Doesn't mean you can't swap out. I mean, it works as designed. It just means this is probably the most efficient way, especially when you start getting into a lot of different things. And you'll see why here in just a bit. So we're going to say edge insets all. Let's say 32.0, just because I really like 32. And then child, new center. And this is a pretty typical design pattern here, where you'll have a container for your padding, and then you're going to center something, and then you'll have a column, and in the column you'll have a series of widgets, and in this case our widgets are going to be a text box, or I'm sorry, a text field. Not text field, just a text. And a raise button. All right, so we have our on pressed, and what we need to do here is we need to fill this in a little bit. Now this is the actual route, and we're going to be working with the navigator. So what we're going to say here is make our anonymous function navigator.of, because we want the context that we're currently in. Think of the context of, it's like a context of a conversation. If I say I'm going out, but the context is I'm talking to my wife, well, that might not be too well. But if I say I'm going out, the context is to my friends, then hey, that might be a good thing. So really the context is what context is the application currently looking at. And it gets really deep. But basically what it means is, how is the application currently running? What is currently on the screen? And it gets really deep. We're not there yet, so just kind of drink the Kool-Aid and just agree for a moment. So what we're doing here is we're saying when the raise button is pressed, the navigator of the current context is going to push named. Now what that means is there's push and pop. Push means like you're going to push something onto a table. You're going to push a new screen out there. Pop means you're going to pull it away. Why is it called push and pop? Well, those are actually, legacy terms from the old C, C++ days that have just kind of carried over into every language out there in existence. So we also need our little semicolon there. Now, push named, this is the actual route. The route does not exist yet, and we will build that here in a second. But we're going to have this on every single screen here. So that is kind of the basic design pattern, and I'm going to actually start my virtual device here. I'm going to start a different device. I'm going to use the Pixel XL, shiny and new. Let that thing boot up. All right, so while that is booting up, we are going to just copy that, make a new file. We'll call this second.dart, and we'll make yet another file, third.dart. My phone made the weirdest noise. I don't know what is up with this. I need a whole new phone. All right, so second, and we'll call this second. This is the second screen, and we want this to go to the third screen. Pretty simple. I mean, it's exactly the same. Now, the third screen, we're going to do something a little bit different here. We're going to paste that in. Spell third correctly is what we're going to do. And let's say on this one, we're going to actually just copy and paste this. All right, so on the third screen, what we want to do is show how to go backwards. So let's say we want to go backwards in time, and we actually didn't put any text in these, did we? Well, boogie. Here, let's fix these real quick while I'm in here thinking about it. There we go. And there's our raise button. Let's fix that in our second one too. All right, now let's actually just wipe both of these out and redo them. All right, so back to where we were. We want this button to be the back button, not the back button, geez. Back button. And instead of push named, we want to pop. Pop's just going to go backwards. Now this one we want to go back to the home screen. And this one gets a little bit different. And you'll see why here in just a second. Actually, let's just fix this up and run it real quick, and then I'll show you exactly what's going on here. All right, so we're going to actually import a few things here. Import package. All right, so we're going to import those screens. Now in our routes, we need to actually flesh these routes out. And we do that using this syntax right here. Meaning we're going to give it the route, say home. Build context, and we're going to give it the context. So basically what this is saying is when the home route is called /home, and you can name this pretty much whatever you want. I just like using these /home, then it's going to create a new home under the current build context. That may not be 1000% accurate, but I think you get the gist of it. And then we're going to make our third. All right, so we've got that. We've got our little emulator up and running with a whole ton of apps on there. Let's save this, give it a good build, push it out to the emulator, and see what happens. Now, the concept of a route is actually a little more involved, especially in other frameworks. Routes can get really kind of messy, and you end up tracking a lot of the stuff under the hood yourself. Some frameworks don't even have the concept of a navigator, and you actually have to kind of build your own navigator class, which is a royal pain. This actually is pretty seamless, and I like it. What is this? Home. Oh, yeah, we didn't set the home, that's why. All right, so hot reload should pick that up. There we go. So this is our home screen. If we hit next, you can see how it takes us to, this is the second screen, and we have this little back arrow here, and we can click back and it goes to the home. That's called I think that's called intrinsic or internal navigation. I don't remember, but in part that's the navigator class helping us out here, I think. I could be dead wrong. That might be part of the app bar, but let's just go with it. So anyways, you can click next, it goes to second. You can click next again, it goes to third. Now, if I click back, it goes back to second. So I can go second, third, back and forth, back and forth. Now, this time, if I want to go home, you see how there's home, but it has this little arrow up here, which takes us back to third. Well, let's say we want to get rid of that arrow. Then we need to do something a little bit different here. So what we need to do is let's go back into third. And instead of push named, what we're going to do is we're going to dot, and this is a little bit of a long one. It's called push named and remove until. Wow, that's a long one. So what this bad boy does, ow, I just hit my funny bone and that was not funny. Gosh, and here I'm all worried about coughing and I'm like jacking up my elbow. So here what we need to do is actually just say route, and we want a dynamic. Let me see if I can push this over here a little bit. That way you can actually see what's going on. So what we're doing here is we're saying the route of a type dynamic, which is actually a route variable, is false. So basically we're just going to keep going until we get to the home screen. So what this thing really does is going to push through that whole route list. It's going to say bang, bang, bang until it gets to home, and then it's just going to remove everything else. Hence the removed until. All right, so let's hot reload this. Actually, let's push it back out. Next, next, back works as expected. Home, bang, there's suddenly no arrow. So that is what the push named and removed until does, in case you ever need that functionality. And then it just works as expected. So that is routing, and that is how you would get around from, I should say routing and navigation, that is how you would get around from one screen to the next. Now, some things to kind of pay attention to for design patterns is you'll notice that each screen is building an entire new app bar in itself. That's kind of just the way I've done it. And then what I do is I take the app bar and I put it into its own special class. That way every single one of these uses the exact same app bar, and then the app bar is rebuilt every single time. If you don't do that, one thing that I've noticed is you'll get double app bars. Like you'll have home here and you'll have another blue bar underneath it. So you kind of got to be careful about that. This is just one of many ways to navigate around your application, but it's probably one of the simpler ones, and I wanted to cover it first. So, I have not coughed or sneezed the whole time. I'm very proud of that fact. Give me some feedback in the video once I post it. Let me know if you guys like these or if you don't like them. I'm really liking Flutter. It's just very fluid. I worked with a couple other mobile frameworks, and I've got to just say, once you get over the Dart learning curve, it actually kind of thinks the way I want it to. And I'm really impressed with, even in alpha, just how easy this is to work with. I'm kind of can't wait to get into some more complex topics here. So that's it for this tutorial. For the source code for this and all other tutorials, go out to my website, voidrealms.com. Click on GitHub, and it will take you right out to the tutorials. There's the Flutter tutorials. You can just clone all those down to your hard drive. And feel free to join the Void Realms Facebook group. There's 1,700 and counting programmers out there, all walks of life. And the site is funded 100% by your donations. So if you've got an extra couple bucks laying around, please feel free to donate. Help keep this site up and running. That's it. Thank you for watching. Hey everybody, this is Brian. Welcome to the 26th Flutter tutorial. I still have a bit of a cold, so forgive me if my voice cracks a little bit. Today we're going to be covering the snack bar. Snack bar is interesting because it allows a lightweight message to be displayed on the screen briefly for the user. It just lets them know that something's going on. I wanted to cover this and maybe the alert dialog before we really start diving into other tutorials. That way when we use them, you're not mystified as to what's actually going on. So I've got a blank project here, and we're just going to start typing away. We're going to import the material design, make our main function. We want the stateful widget. Then we want to create a state for our stateful widget. I always ask, why do people like watching me type? It's so much easier just to say, hey, here's a finished project and look at what we've done. But people like watching me make mistakes. I guess it makes them feel a little bit better because everybody makes mistakes. And a couple people said they like listening to my thought process and how I get from point A to point B. And I get that because sometimes I walk into a application's code and I'm like, what in the hell is this? All right, so we're going to make our new material app. And we're going to say home equal new. You guessed it, my app. Why is that complaining? Oh yeah, cold medicine. There we go. You will see many, many typos while I'm on cold medicine. Point in case. Can't even type create state here. Alright, so we're just simply fleshing out a state of our application here. We need a state because, well, we're pretty much going to have to need one for almost every application we do. Every time you interact with the screen and you're going to save some sort of data, you got to save that in the state. So first thing we're going to do is create our variable here. Then we are going to, you guessed it, do our override. And this is kind of just boilerplate at this point. We've done this a couple times, actually 25 other times. Let's go ahead and build context. There we go. So we've got the bare bones of our application here, and we're going to flesh this out. Now, really what we're going to have here, once we get this going, is we're going to have an app bar followed by a text box followed by a button. And when we click the button, the snack bar will appear down at the bottom. So let's go ahead and actually build out this application. New app bar. There we go. hate having a cold. It's like I'm like here, but I'm not here, and I think I'm doing the right thing, and then I'm not. Like the other day, I went to make toast, and I put the bread in the refrigerator and stood there for like 5 minutes waiting for it to get toasted, and then it occurred to me it was just getting cold. So, yeah. All right, so we're adding a container, so if we wanted to put some padding in there, we could. I don't think I'm going to really play around with padding, but just in case somebody downloads this code. And there's our new center, and inside the center, we're going to say child, new column, children, and there's our widgets, and we'll say new text field, and new raised button. Let's go ahead and run this and see what we got. Just make sure it looks the way we expect it to. And I'm actually pretty amazed. A lot of times I'll build the application and run it just to quote unquote make sure it runs. Part of that is because Flutter's in alpha, but you know, I've never had. I was just going to say I've never had one crash on me, but I guess I just did. What is the problem here? Open again. That didn't work. Lost connection to device. Let's figure out what's going on here. Installing. Syncing files, host new host connection, fatal signal 11. Well, let's look at our code and see what's going on here. Well, let's try debugging this and see what happens. I've actually never had one of these crash on me before. This is interesting. Of course, now it runs. Interesting. Wonder why that crashed. It is working. Alright, well, let's just kill it and rerun it. Raise button. We're going to add in a couple properties here. I was going to say, now I'm a little embarrassed. I was going to say that I'm actually really impressed with the way Flutter's been so far. Even in alpha, I've never had anything crash, but I guess there's a first time for everything. I'm kind of happy that happened while it was on camera here because it's just kind of interesting to see. Makes me wonder what happened there. Although I'm not sure if that was a problem with Flutter or a problem with my emulator here. A lot of times people are very quick to kind of blame Flutter for its shortcomings when it's in alpha, and the reality is it's really not Flutter's problem. Alright, so let's get rid of that. I want to run this one more time just to make sure. Apologize for the delay, but that made me a little nervous that it did crash. It's working. Alright, well, we'll just continue on then. If you're new to mobile programming, don't get discouraged by that. I've worked with React Native before, and it is a little glitchy at times. I'll write code, and I swear that it'll work. I'd bet my life on it, and of course it doesn't work. It crashes, and then I have to figure out some weird error message. It's just kind of the state of mobile programming at this point. So the first thing we want to do is actually track that variable. So, yeah. We're going to do that through the set state. There we go. So we're just going to take this onChange and we're going to monitor the onChanged in the text field. Whoops, better put this in here. There we go. So when onChange is triggered in the text field, we're going to pump out that variable to our onChanged value. You could very easily take the set state and put this right here, but I wanted it to be very obvious what's going on, and I wanted to kind of break that out without making it look really ugly down here. Alright, so we're going to show the snack bar in this one. To do that, we have to add a little bit of magic here. And this is going to take a little bit of discussion, and admittedly, I'm not an expert in this either, so this is kind of the blind leading the blind here. we need to make what's called a global key. And you see how it's a generic type. So it's global key extends the state of a stateful widget. So we're going to say global key of the scaffold state. And we're going to call this scaffold state. All right, so first off, what is a global key? What is even a key? Well, a key is a way of identifying something. A global key is a unique key across the entire application. That being said, there can only be one of these scaffold states across the entire app. So let's actually add this in here. And we're going to use that. And then in our show snack bar, we're going to say, actually, let me modify this just a little bit here. We don't want to show a blank snack bar here, so if it's empty, then we're just going to get out of there. All right, so we're going to say scaffold state, current state, and then we're going to show the snack bar. First thing it wants, of course, is a snack bar. So we're going to say new snack bar. And then we've got some content in there. And I'm going to break this down a little bit so it's a little easier to read. And in here, we're just going to say new text. And we're going to say the value that we're trying to display. Let's actually put this on the same line there. There we go. And then on here, when we press the button, we're going to say show snack bar, and we're going to use that text variable that we're holding in state. All right, let's run this out. And there is our snack bar at the bottom. If our keyboard was hidden, it would be down here at the bottom. So that's really a snack bar. It's just a little instant notification on-screen display and let the user know something happened. So you could say something like if you're in a settings dialog and they click the save button, you could just say like settings save. That way they know something happened. It's unique to the application because we're using global key. So I believe, I haven't tested this, but I believe that if we were to use the navigator and switch from one screen to another, that state would, or that snack bar would still show up. It wouldn't automatically disappear. But I haven't fully tested that yet, so don't quote me. So that's it for this tutorial. Thank you for watching. I hope you found this educational and entertaining. The source for this and all other tutorials will be out on my website, voidrums.com. You just go out here and click on this big GitHub link. It takes you right out to the tutorials. And if you're so inclined, join the Voidrums Facebook group. There's 1,700 other programmers out there that we can definitely help you out with your coding problems. Hey everybody, it's Brian. Welcome to the 27th Flutter tutorial. Today we'll be going over the alert dialog. This is part of the material design widgets. And like the snack bar that we covered in the previous tutorial, I'm covering it now so that if I use it in future tutorials, you understand what's going on. So there's really no black magic or voodoo magic or whatever going on here. Should be noted, there are other types of alerts such as the bottom sheet and the simple dialog and the expansion panel that we aren't going to cover until future tutorials. I just wanted to focus on these two for now. So let's go ahead and jump into a blank project here. Going to import material design. Whoops. We're going to extend the stateful widget. And I'm still, like I've said in the past few tutorials, got a cold. So I've been recording these over a few days, but man, this cold just will not die. We're going to create the state of this. Oops, not new. And we're going to shove my app out is the home of the material app, and then in here, see, I'm trying to get healthy as fast as possible because I want to go out and see the new Star Wars before it leaves the theaters. It's been out for a little while now. All right, so in here, it's going to be the same design as we had in the last tutorial where we're going to have the text, or we're going to have an app bar, we're going to have a text box, and then we're going to have a button here. So let's go ahead and kill that existing demo. And let's go ahead and type all this out. Oops. Plus sign. Boy, that's an interesting operator. There we go. Build context. All right, so we're just going to build that bad boy out here. And we need to actually build our user interface. So first thing we're going to do here is we're going to say, I'm going to return new scaffold. We're going to say alert dialog demo, and then the body. Don't know why I did that. There we go. New container, just in case somebody downloads this code and they want to add some padding. I'm not going to really worry about padding myself, but center everything up. Then we've got our widget array here. We're going to say new text field. The new raised button. And let's go ahead and save this. Missing concrete implementation of stateful widget create state. Oh, create start. Derp. All right. Let's go ahead and build this, run it out, make sure this thing actually runs on the device. Grado's resolving dependencies, and we're going to push it out here. And just give it a minute, and it should appear on the device. There we go. So we've got our text field that we can type into, and we've got a button that we need to put some text here. And when we click this, a little alert dialog will pop up here, and we can play with that. All right, so let's branch this out here. We're going to set the state here. So we need to hold that variable in memory. Or I should say we need to change that variable that's in memory as part of the state. And we're going to use this on change right here. Pump that variable over to our onChange function. All right, so let's actually All right, so what we've got so far is basically when the text field is changing, we're going to take the value and pump that through the set state into our text variable here. Now we want to actually show the alert when they click the button. And we're going to use the text variable for that. Now in here, what we need to do is we need to create an alert dialog, but we don't want to show one if it's empty. So we're going to say if value dot is empty, then we're just going to return out alert dialog equal new alert dialog. And you'll get so used to doing that throughout your little career here as a programmer. All right, so the content of the alert dialog, we want to say new text, and in here we want to say the value, and then we want to set a style here. So let's say style new text style, and we want the font size to be 30.0. That has to be a double, it cannot be an integer. So if you do that, it's going to freak out on you. All right, so we've got that in there. Now we need to say actions. Oops. And there is our widget array here. What we're going to do for this, and let's actually just run this just so you can see what it looks like here. Did it not run? Oh, probably help if we actually... Did we do that? What was going on here? Oh, I know what we did wrong. We forgot to actually show the dialog. Derp. Not show about dialog. So we want show dialog, and the context will be the application context, and then we want the child to actually be the dialog. Save that, pump this bad boy back out to our device here, and we'll say test. And there is our alert dialog in all its glory. Now, if you're looking at these actions widgets array over here, what we're going to do is we're going to add a list of options here, and then when we click that, we want to know which option was clicked. So let's just get back out of that. And sorry about that, somebody was texting me and it kind of threw me off a little bit here. We need to make an enum here, so we'll say enum my dialog options. Do you want to call these options or actions? Let's call them actions. My dialog action, why not? We'll say yes, no, maybe. All right, now in here, in our actions for the alert dialog, we have a list of widgets that we want to pump in here. So we're going to just make one widget. We'll make a flat button. Notice how it says on press and child for us. It's very convenient. And then it'll say, let's say, all right, now the on press, we need to actually wire this into a function here. So let's say whoops. We're going to take that enum and we're going to put it in here. And for this, we're just going to print this out. We're going to say print the actual value here. And then dialog result. All right, so let's run this back out to the device. And then we have a yes. And if we click it, nothing happens. Now, actually, under the hood, if I could find my... Where is it? Too many options. Took me a second to find it, but it's right here in our little Android monitor, right there. Boom. So we selected yes. Let's go ahead and click that a few more times, and you can see that it's actually happening in the background here. So that was bloody confusing. I don't know what I got all hung up on there. So we're going to go back in here, and we are going to make a couple of these. And to close that dialog out, we have to go navigator.pop, and we want to pop to the current context. That way it's not going to leave the current screen that we're on. Let's run this again. And we'll say, do you like Flutter? We have yes, no, maybe. So let's look at our little Android monitor here. Pop this back. Where's my emulator? There you are. And if we say yes, you can see that it closes the dialog, and we get this you selected the my dialog.action yes. And from there you could do a switch statement to determine what actually you need to do next. So pretty simple, pretty easy, pretty useful too. I mean, you can do a lot with this. You can do yes, no, maybe. You can put other controls in there. You can put drop downs, things of that nature. Pretty awesome for a very entry-level control. Well, I feel I'm losing my voice. This cold's still kicking my butt. So we're going to call this tutorial done. For the source code for this and all other tutorials, visit the tutorials tab on voidrealms.com. Go out to GitHub. And if you're so inclined, go out to the Void Realms Facebook group, where there is 1,700 other programmers out there. All right, thanks for watching. Hey everybody, this is Brian. Welcome to the 28th Flutter tutorial. Today, we are going to switch gears a little bit here, and we're going to go down to, where is it, the text field. We've worked with this before, but we haven't really talked about it in depth. So what we're going to do in the next few tutorials is talk about individual widgets. We're going to talk about text field, then probably checkbox and radio box. Or actually, it's just called radio. In other frameworks, it's called radio button or radio box, depending on, but in Flutter, it's just called radio. Anyways, so today, text field. Let's just go ahead, and we've got a little demo project. Let's get that out of there. Let's open a new emulator. Let that bad boy load up while we're typing. All right, so let's import our material package. And I'm probably going to deviate from my example code that I have on the other side of the screen here just because I don't really like it. Sometimes that gets me into some trouble, but we'll just see what happens here. Still, gosh, this cold, man. I'm still got this cold. Trying to fight through it. Might be successful, might not. So if my voice cracks a little bit, I haven't actually done tutorials in a while because my voice has been really bad. Just forgive me. All right, so we're going to extend the stateful widget. And then whoopsie. All right, so we're going to extend the state of the My app. Had a lot of good feedback about Flutter. Even for alpha, people seem to genuinely love this. I actually really like Flutter. It's kind of hard to describe unless you've really worked with it for a little bit. It's got a lot of things that other frameworks are really, really lacking, even though it's just an alpha, and I think there's going to be a lot of really good, promising things coming out of this. create start, geez, create state. Alright, so we've got kind of our boilerplate here. Let's just finish this up real quick. I may start the tutorials with what we have now, that we don't spend 2 minutes watching me type this over and over and over again. Just let me know in the comments how you guys feel about that, because I know that sometimes I try to just have pre-written code and everybody's like, no, don't do that. We like watching you type. I think you guys just like seeing my horrible spelling mistakes here. Alright, so return new. We're going to return new scaffold. And bang, we can actually start our program now. So as always, we've got our kind of generic pattern here where we do run app. We're creating a new material app. The material app's home is a my app. My app is a stateful widget. The state of that is the my app state, which of course extends the state of the my app. Seems a little cyclical and a little confusing, but I think we're getting there. All right, so first thing we need to do is, well, actually, let's work with our state here. So, let's say, what do we want to do? Yeah, why not? All right, so now that we've got our scaffold up, I'm going to say app bar, new app bar, title, new text. And with the body here, we are going to say new container. Let's get a little bit of padding there, just so we know what's going on here. Whoops. Let's say new center. And then we have our list of widgets that we're going to flush out here. So the first widget we're going to add here is a new text field. And a, whoopsie, new raised button. That way we know that this is a text field demo, not a text demo. There we go. All right, so we played around with text field before, and if we actually just run this so we can see what this looks like here, let me pull my emulator over. Text field is actually pretty interesting little control. There's a lot of functionality packed into this bad boy, and you wouldn't really know it unless you started diving into the documentation and playing around with it. So we're just going to make a completely obscure example that you will probably never use, but it shows off some of the functionality of this. All right, let's build this up, throw this out here. So here's our text field that we can type into, and here's our raised button that we're going to be able to click. Let's finish that button up here. I have failed you. Do it. Do as I command. Anyways, new text. There we go. Now, what we want to do here is we want to actually do the on press, which we've done tons and tons and tons of times here. So let's just make a void on pressed. Now you can do this much more compact. I just do it that way. It's, you know, there's no issues understanding what exactly is going on here. So it will call this, and we can even say print button test or button pressed. We've done that before. Now, what we want to do is actually grab the text out of this text field. And we've seen this before where we can't actually say text field dot text. The text field itself does not store a state. It's a stateless widget. So what we have to do is grab those changes as they occur. So we're going to actually say and then here, let's bang this down here and then separate that down. That way it's just a little more easier to understand. And we need to say string value. And then there's our value. We, of course, need our semicolon at the end here. And let's push this back out to the device. And now, as we type, you can see we are grabbing the text that is in the text field. And if we click, we have our button pressed. So what we need to do now is, you guessed it, set state. I don't like it that there. Let's bump that up. There we go. Value. That way we actually have the value here. And then we can say hot reloading should take care of that. And bang, the text is blank. Yeah, because we haven't actually stored it in the state. Let's try this. Yeah, there we go. So the text is whatever we just typed. So we've seen that before in similar older tutorials that we've done. Now what we want to do is show off some of the features of this thing. We understand now that the text field is stateless, and that's why we have to grab this on changed. But what are some other things that we can really do with this? Well, we're going to play around with it a little bit. We're going to say max lines equal 3. So we're going to have 3 max lines in here. And we want autocorrect turned on. That's right, autocorrect. Yeah, buddy. And let's just play around with that and see what that does. So let's grab this. Notice how we have 3 lines in here. 1, and we have autocorrect. So if I just type, and we can say catch, comma, and we can go down a line, maybe. Can't figure out how to go down a line on the emulator here. Oh, well, I kind of did it. You get the point, though. We have multiple lines now that we can really play around with. And the text is whatever, blah, 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 catch. So you can have multi-lines, you can have auto-correction, you can have all sorts of stuff. You can even have this little, this is an emulator, so it won't work, but I can click that and it'll actually dictate out whatever I'm saying. It'll type it out for us. Pretty awesome. So obscure text, true. I think we've done this in a previous tutorial. This is for passwords. Notice how it's a bunch of dots, and as we type, you only see the letter for a second, and then bang. So we could actually say something like, my top secret, I can't even spell, my top secret password, bang. So let's comment that out for the time being. Let's say we want a decoration. We're going to do a new input decoration. And we're going to say icons dot, why not, just icons dot print. Hint text, and we will say type something here. And we want label text to say, what is your name? Uh-oh, something blew up. I guess that worked. So now you can see that we have a label text. What is your name? Let me kind of reload this because it kind of shrinks when we do that. It says, what is your name? And then when you click on it, it zooms it up there. We have an icon and it says type something here. And we have multiple lines of text. That's actually really cool. One thing you should be aware of is this whole pattern of tracking the state and all that. It can seem a little cumbersome at times. So one little trick that you can do is you can say final text editing controller and we can get the controller here and we can comment out this. Actually, we can even leave it if we want to and just say controller and give it the actual controller. Then what happens is, and we will say we want on press 2. And I'm going to comment this. Just kind of playing around here. And we're going to just print out the controller.txt. Let's reload this whole thing. So now when we click the button we're calling on press 2, which instead of grabbing the text variable is actually grabbing this controller variable. So we can say blah 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 blah, click, and you can see we get the text. And we didn't have to mess around with set state or any of that because we've got it all in this text editing controller. Actually pretty neat. So that in a nutshell is the text field. There's a little bit more to it, but I don't want to get too in depth. These are still beginner tutorials. But as you can see, this thing packs a lot of functionality into it, probably more than most other frameworks out there. And I was really just kind of blown away when I started playing with this. So let's end this with, I hope you like Flutter. So that's it for this tutorial. If you're looking for the source code for this, maybe, there we go. Go to my website, voidrooms.com, click on tutorials. It'll take you right out to GitHub, and I have links to all of the tutorials. I do different series, but you can click on the Flutter tutorials, and then I've got all of them. You can clone the entire repo down to your hard drive and have the source for everything. On top of that, you can join the Void Rooms Facebook group. There is almost 1,800 other programmers out there, all walks of life, all different languages, and we can definitely help if you have any questions. That's it. Thank you for watching. Hey everybody, this is Brian. Welcome to the 29th Flutter tutorial. Today we're going to continue our conversation on some basic widgets, and we're going to cover the checkbox. Checkbox is a pretty basic little component, or I should say widget. But one thing we're also going to cover is the checkbox list title, which is an interesting widget. It's kind of a combination of many, and we're going to go over that as well. So let's just jump right in here. I'm going to import our, you guessed it, the Flutter material package. We'll make our simple pattern here. You think I'd have this down, but like in my sleep by now. We've done this so many times now. My app state extends state. We're going to extend the state of my app. We're going to do the run app function. Let's do this. I'm going to do a new material app. I'm going to do a new my app. Let's get that out of there so we can see what we're doing. Kind of excited for Christmas. It's like a couple days away here. All right. our state. I'm going to build this out. All right, we are going to return a new scaffold. All right, so there's our text. All right, so now we're ready to get down to business here. Save our work. And the first thing we're going to do is we are going to, well, you guessed it, we're just going to add a new checkbox. You can see how we have value and then on change. So you can already see that we've got some interaction here. And this is very similar to the text field, which we covered in the last tutorial, where we have to track on change because this is a stateless widget. It's not going to track it for us. So the first thing we need to do here is we need to say bool is check equal false. Copy that. Grab our value. Oops. And then set state. Let's actually make this private. There we go. So now we're going to track the value of whether or not that is checked. So we're going to say the value of this is checked. I should say it is the is checked variable. And we want to track that through the on change. So we'll say bool value there we go. So let's push this out and see what it does here. Where is my emulator? There it is. So pull our emulator up and wait for this to deploy it. It's going to take just a second. My computer's running slower than normal. I don't know what's going on with this thing. I think it has a cold. It caught the cold that I had. So you can see dead center of this is our checkbox. And we can check it and uncheck it. Not very helpful. So we need to snazzy this up just a little bit. So let's go out here. Let's just completely grab this thing. And we'll say new row. And in our row, we want a new text. And we'll say click it. That's not liking that for some reason. What is going on here? Oh, I know what I totally forgot. Children. There we go. All right, so we initiated a hot reload. You see it says click it, and we can check it, uncheck it, check it, uncheck it. But if we click the actual text, click it, nothing happens. You got to actually tick that little box. And if you have big fat fingers like I have, it's not very fun. So what we're going to use next is what's called the checklist box tile. That is a fancy name for much better than what we've been working with. So let's just do this. And we'll say new checklist box tile. And bang, you can see how instantly it almost has the exact same signature. Well, actually it does. So we can just copy this whole little bad boy right here instead of retyping all that garbage out. Wait for our hot reload. Did it hot reload? No, it didn't. Let's just push it out. Uh-oh. Dependencies cannot be established. What? Expected to find. We screwed something up here. Alright, let's figure out what we did here. Unchanged bool. Why is this messing up on me here? I see what the problem is. We're missing one. And trusty hot reload works as we expect. So now we've got this little guy over here. Now because we have linked these, when I say linked, I mean they're both using the same variable and we're tracking that variable through set state. When we click one, the other one's going to change also. That's the magic of state. If you didn't really understand state before, maybe you just had a light bulb moment. Just to kind of go over this again, both of them are using the same variable, and we're saying on change, so both of them are saying on changed. So it doesn't matter which one we do, it's going to change that variable. And because they both have the same variable, and that variable is being set through set state, it's going to track the state of that variable, whether it's checked or unchecked. Thus you get this dual action going on here. So that's nice and all, but we still have the same problem where we have this checkbox and nothing else. So let's fix that. Let's break this down just a little bit. All right, so first thing we want to do here is add in title, new text. Click me. You can see how now we can click the text and it acts, this whole thing acts as a giant checkbox. So we've kind of done this where we have a row with the text and that, but the whole thing's now clickable. And let's just say we want to do active color equal colors.red, because we want to really differentiate this bad boy. And we want secondary. And I don't know what to, let's just say home. Why not? So we're going to add a few things here. So now we have an icon, and it changes the color when it's active. Pretty neat, huh? So that is the checkbox and the checklist tile. It's called a tile because, well, it's in the shape of a tile, but it makes life a heck of a lot easier. So if you've got really finicky users or a really finicky production manager and he doesn't want to try and click this little guy, you can just use a checklist tile and life is good. That's it. Thanks for watching this. I hope you found it educational and entertaining. If you're looking for the source code for this and the other tutorials, once again, go out to my website, voidrealms.com, click on tutorials, go out to GitHub, go out to Flutter, and you can just clone all of the code right down to your machine. And if you're still listening, you're one of the cool people, you are invited to join the Void Realms Facebook group. We have 1,700 other programmers out there. And I had a few questions. People say, why are you always plugging the Void Realms Facebook group? Because it helps me. When I have a question, the first thing I do is go out there and ask, and then I usually get like 24 people with answers. So that's it. Hope you found it educational, and thank you for watching. Hey everybody, this is Brian. Welcome to the 30th Flutter tutorial. Wow, we've got 30 of these so far. Today we're going to be covering radio buttons, or radio as they're called. They're these little circles. You've seen them before where you click one and the other one unchecks and it goes back and forth, and you have little groups of these guys. So that's what we're going to cover today. We're going to do the bare basic implementation because these are still kind of beginner tutorials. Let's just jump right in here. And we've got our material package. We're going to say going to extend the stateful widget. And we're going to extend the state of the my app. All right. Going to do run app. Make a new material app. new my app. We've done this before. I'm just trying to flesh this out as fast as I can here. Override, and then we're going to say my app state, create state. All right. Why is this thing isn't a type? Well, crap if I did that. All right, so let's actually flesh this out now. Widget. All right, so I like that widget. That was interesting. All right, so we have this. Now we need to build this out and render it. And we're going to say return new scaffold. And let's do that. Bang. Ooh, new title. I don't want a new title. I want a new text. Where am I getting these things? I think I'm just typing too fast for my brain. All right, so then we have our body. All right, so we've got a center. Let's actually make new center. That way it actually works. And all right, so we've got a new column here. And this is where we're going to deviate a little bit from what we've done in the past here. I know if you've been watching some of these, you're probably going, okay, the same old design pattern over and over and over again. We're going to actually do this a little bit different. What we're going to do here is we're going to make a function called make radios. And we're going to call this right here. And this function will actually generate the radio buttons for us and wire everything up and make it all nice and neat. And we'll return our list out. So first thing we need to do is actually, make some of these. So we're going to say list.add new radio. And you can see how it's got a value, a group value, and an onChanged. We're just going to save that and run this out. So the value, while this thing is loading, the value is the actual value of this specific control if you were to select it. The group value, because remember radios come in a group, the group value would be the value selected within that group. And the onChanged, of course, is this is a stateless widget, so we have to track that state. And here is the radio button in all its glory. It's disabled because we are not tracking the onChange, which is why it's grayed out. As you can see, we have kind of the same problem we had in the last tutorial with checkboxes where we don't have text or anything. So we're going to follow a very similar pattern here. And we're going to just say, I'm going to add a row. And then children, we're going to add a new text. Uh-oh, my background music died on me. There we go. Sorry about that. My headset has like this timeout, and for whatever reason, I can't get it to not timeout. So if I don't have some background music and it's not registering through the microphone. So if it's not playing anything through the speakers for I think like a minute, it shuts off. Really annoying when I'm recording a video. Okay, so we're going to say radio button. Actually, just call it radio. And then new radio. And then we have our stuff here. So let's say the value of this is 0. And we need to actually track a value here. And we're going to say wow, could I have misspelled that anywhere? There we go. And we've seen this before, very, very familiar design pattern where we have to track the change and set the state. And we're going to say selected equal value, bang, grab this onChanged, and we want to track that change here. Now the group value is going to be the selected value here. So what's going on is we're going to have a row, and in that row we'll have a text field, or just a text that says, radio. And then next to it we're going to have the actual radio, which is going to have a value, the group value that's shared through them all, and on and on and on. We track the change. So we're going to just grab this, push that out through hot reloading, see what it looks like. Sure enough, bang, that works. So let's just do this for let's push that out. That didn't quite work the way we wanted it to, did it? There we go. So now we have 3 radios, radio 0, 1, and 2. And you can see when we select one, the other ones are not selected. That's the group value right there. We are currently tracking that in there. And we can actually just say value 0, value 1, value 2. So we can see which one's which. Now, we have a very similar problem that we had with the checkbox, which is this text right here. If we were to try to click that, nothing happens. And if you have big fat fingers like me, you're not, a 10-year-old Asian kid, it's really hard to kind of click these specific little things. So as you might have guessed, when we go into the documentation, similar to the checkbox, there's a radio list tile, and the radio list tile is very, very similar, and we're going to actually flesh that out right now. So let's jump back into our code here, and we're just going to say for int I equals 0, I less than 3. All right, so we're going to say list.add new radio list tile, and you see it has a very familiar signature here, and we're going to break this out a little bit just so it's easier to kind of see and understand. All right, let's actually push that out there. So the value, we're just going to say I, the group value is selected, and the onChanged is the actual value. Now when we look at our hot reload, bang, we have 3. And we have similar to what we had in the previous tutorial where they share the state. so that you can understand what's going on with state. And you can see now if we click off, it's the entire row. And we're going to fill those values in right now. So let's actually go in here and we're going to say title, new text, give it that title right there. And we've got our on changed here. We're going to say active color, colors.red, and we're going to give it a subtitle of new text. And we're just, I have no idea what to put here, so we're just going to say subtitle here. All right, and of course our favorite, the secondary. Give it a new icon. And I never know what icon. We're just going to say home. Why not? And in something more production-y, you would actually say, you know, an icon for each one. And let's push that out. And ta-da! In all its glory, we now have much, much fancier looking radio buttons. Or I should say radio list tiles. Very simple, very easy to understand control. Very robust, and it's kind of one of the founding fathers of all controls ever since the dawn of graphic user interfaces. So pretty simple, pretty easy to use. One thing we haven't covered is how to have like groups of these. It's a little bit more complex, but I just kind of wanted to let you know how that worked. All right, so thank you for watching. Hope you found this educational and entertaining. The source code for this and all of the tutorials is out on my website, voidrealms.com. You can click on that, and then you can just simply go out to Flutter, and bang, you can pull down the source code for all of the tutorials all at once. Also, if you're so inclined, join the Void Realms Facebook group. There's 1,700 other programmers out there. We can definitely help you out if you have any questions. Hey everybody, it's Brian. Welcome to the 31st Flutter tutorial. We are going to be looking at the switch, which is very similar to the checkbox or the radio button even, in the fact that it has an on or off. It's graphically different because it switches back and forth. Think of it like a light switch. It's just an easier way of letting the user know what's going on here. So typically you would use this for like a setting of some kind. You know, like do you want to give feedback, yes or no, turn it on or off kind of thing. So we're just going to dive right in here, and we're going to say import package, import material, make our main function here. And then let's we're going to extend the stateful widget. And then we're going to extend the state of that stateful widget. And you notice I've kind of deviated a little bit. I say underscore state instead of my app state, just so it's a little easier to understand what's going on under the hood. I had some questions about the difference between the two. And remember, in Dart, anything that starts with an underscore is private, so that's not accessible outside here. So we're going to say run app. I'm going to make a new material app. I'm going to set the home to new my app. And here we're going to just simply override this, and we're going to say I screwed that one all up. It's been a while since I've done a tutorial. I took a little break over the holidays, so now I'm going to fat finger just everything. There we go. And then here we're going to say override. All right, so pretty simple design pattern we got going on here. We have our main function, which creates a new material app through the run app, and that's what's going to actually run. We have our stateful widget, which is going to hold a state. The state of that is going to be called by create state, and Here's the actual state. Now in the state, we're going to call the build function, which remember, whenever we build, quotey fingers, we're going to actually render something on the screen. So we're going to return new scaffold. And this is where the real meat of the program comes into play. I'm going to say app bar. Yeah, fat fingered that. We're just going to say switch demo. And in the body, we're going to say new container. And we're going to have some padding in here. And then we're going to have an array of widgets inside of a column here. And in here, we're just going to make a new switch. And you see how it has a value and an on change. So automatically it wants to know, hey, what's going on here? So with that, you should understand that we got to actually set some things here. So let's say bool value equal false. That's our initial value. And then we're going to say void. Then we're going to set the state here. Now in set state, we're going to actually set the value. So we're going to say value equals the value. Pretty simple. So we get our initial value here, and then the onChanged, we're going to say maybe if I could actually type. All right, so then we're going to say onChanged value. So then we're going to just simply set the value here. So if you've kind of skipped the previous 30 tutorials, basically what's going on here is we have a private variable called value that we're holding in the state. When the when the switch is actually changed, it's calling this onChange using the value of the current value of the control, whether it's on or off, shoving that into this function here. As you can see, we're calling it there, and we're setting the state. That's very important to call set state, because if you don't do that, well, the state is not saved, and then when the screen's refreshed, nothing happens. Or I should say, if you don't call set state, the screen never refreshes. That's actually more accurate here. And the initial value, or the value that's bound to it, is this underscore value. So we have this private variable here. So let's go ahead and fire this up, run this on our emulator here. Had a lot of positive feedback about the Flutter tutorials. I'm actually pretty happy to see that. I was kind of wondering when I first started these how many people would actually even be interested in it. And it turns out quite a bit of you guys actually are. I was really shocked. For such a new technology, especially in alpha, I mean, it's not even in beta yet, it's still in alpha, there is just a humongous amount of feedback on this. All right, so here's our little switch. You can see we turn it on, turn it off, turn it on, turn it off. And it follows the design pattern very similar to what we've seen previously with checkboxes and things of that nature. So with that, we're also going to check out the, you guess it, the switch list title. Has the same signature here, so we're just going to copy and paste this. And we're going to break this down a little bit more. Whoops. Screwed that all up. I'm so embarrassed. All right, there we go. So with this, we're going to actually add in a few little things here. We're going to say a title. Now, someone did ask, with titles, you're saying new text. Why wouldn't you just put in quotes? Because it's actually expecting a widget. So for the title, you can put anything you want. You can put another switch, you can put checkbox, you can put an image, you can put custom control, anything. I'm just putting a text in there because it's very easy to do that. All right, so we have our title. Let's set the active color equal, we're going to say colors dot red. And for secondary, we're going to say just a home icon here. You notice how off to the left it actually previews it a little bit. We're going to rerun this bad boy. And now we have our switch. And because they have the same value that they're bound to, it doesn't matter which one that we click. The difference being this, you would have to add like extra text or whatever. Well, this is all one control. So you can even click on the little house here and it turns it on or off. So that's it. Simple, easy to use. If you found this tutorial educational or even funny, let me know. Be sure to visit my website, voidrealms.com. Click on tutorials for the source code for this and all other tutorials. It takes you right out to GitHub. And note that this website and everything that you're watching is 100% funded by your donations. That's why I don't have advertisements on the videos. So if you are a corporation or if you've just got some extra money, be sure to feel free to donate. A lot of that times that goes towards funding the website, running the host, and all that stuff. So thank you for watching, and I'll talk to you guys later. Hey everybody, this is Brian, and this is the 32nd Flutter tutorial. Today we're going to be doing a little bit different. I know we've kind of gone through checkbox radios and a switch, which all follow almost the exact same design pattern. We literally could have just changed one word, checkbox radio switch, and it would have been the same darn thing. So today we're going to do something a little different. We're going to cover slider, which is actually set up a little bit differently, and we're going to cover, where is it? It's going to take me a minute to find it here. Of course, now I can't find it. It's the linear progress indicator. Did I pass it already? There it is right here, the linear progress indicator, basically a progress bar. So we're going to cover both of those today. All right, so let's just jump right on in here. I'm going to import the material package for Dart. We need this for our material design widgets. I'm going to set up our basic code pattern here. We're going to have our main function. We're going to extend a stateful widget. And we're going to extend the state of that stateful widget. And in here, we're going to say run app. This is what actually starts the application up. I'm going to make a new material app, and the home parameter is going to be a new my app. So we're just going to make an instance of our class here. All right, so now that we have that, we're going to actually create our state here. And in our state, you guessed it, we have to do our build function. All right, so I've had a few questions about why this is the way this is. So we'll kind of break it down a little bit. We need our import, obviously, for the material design package, these widgets that we're working with. This is all material design. The main, obviously, is where our starting point is, which we call run app. Then we're creating a new material app, which actually wraps in a lot of the material design and the things that we need. From there, we need a stateful widget because we're going to track state. When we quote-unquote track state, we're just tracking that something changed, and we want to see those changes. Now, the difference between a stateful widget and state is minute but major, and I know that's a complete contradiction. Stateful widget means that something in the widget will change. State is the thing that actually changed inside of the stateful widget. So while the stateful widget itself is not changing, the state is changing. The difference between a stateless widget and a stateful widget is the stateless widget does not care about change whatsoever, where the stateful widget, what we're working with, wants to track those changes, which is why we have to call create state. because we want to say, hey, we have a state, we're going to create it and monitor it. Whenever the build is called within our state, the entire screen is going to refresh, or I should say the parts of the screen that really need to refresh. All of this is kind of held, I want to say, like in memory, sort of, and only the things that changed are really tracked, but then everything's re-rendered to the screen. So that's kind of an answer to that. So in our build, we're going to return a new scaffold. Remember, a scaffold is just kind of, well, it's like a scaffold. It's, you ever seen those building scaffolds where they, either build a building or they're, cleaning windows or something. They have to build this structure so people can walk around. That's really what a scaffold is. All right, so the app bar is just our top blue bar here. We're going to set the title parameter to a new text. All right, and then the body, oops, not even there. There we go. So the body is going to be a new container. I'm still kind of outed. I haven't done tutorials in a while. I'm trying to get back into the swing of it because I'm trying to get caught up. Really, I've got a couple personal projects. Ooh, that is not what I wanted. 32.0, because why not? And for the child, we're going to do a new column. And then we have an array of widgets for the children. All right, so in here, this is where the magic's going to happen. We've got our array of widgets here, and we're going to say slider value is, and we're just going to say 0 for now. We need to go up here and actually create our state. Notice this is a double, not an int. And then we have our unchanged here, which is going to be when the slider actually moves around. We haven't added the slider yet, so this takes a bit of imagination. Break that down into our function. And then we've got our set state. We're going to just say value equals the value. So we're updating our state. All right, now let's actually make this work. So there's our slider, and you notice how the default ones are value and onChange. So it's very, very similar to what we've seen before. And we're gonna let's break this down so it's a little easier to work with. All right, so slider also takes some other properties. We want a minimum value of 0.0. Remember, it's got to be a double. And a max. And we're going to say 100.0. So let's put that off to the side for a second here. Gotta put the value in there. So we're going to say slider value is, and then whatever our value in state is. And we're just going to run this out to the device. So once this run, we'll be able to move the slider around and actually see in real time that text widget will change with the slider value. What we're going to do next after this whole thing is actually working is we're going to put the linear progress bar under it. Typically a linear progress bar goes right under this app bar, but I want it to stand out. And you can actually grab this and you can see how it kind of changes. Now you notice because it's a double, it's got this 52 dot blah, all this behind it. So we're going to modify this a little bit. We're going to say value dot round. Take care of that. Hot reload should switch it. Yep, sure enough. Hot reload took into effect. So now we've got a nice min and max and everything in between. So to add to the goodness here, we're going to put our linear progress bar down here. And we're going to tie that into the same value so we can kind of see what's going on. There's our linear progress indicator. Sorry if I call that a progress bar. I'm just very used to doing that. And we're going to say the value. We're just going to tie it into the value that we're using. But we're going to multiply that by 0.01. That way we get an actual positive number here. See, nice and smooth. And let's actually say and let's just grab this. Not sure if we can even do this, but we're going to try it. This may be a spectacular disaster, but I'm pretty sure we can do that. All right, so there is our in all of its glory. So really what the progress indicator or progress bar, if you're from other languages and frameworks, just shows a progress so the user can see. So we would say we're at 0% all the way up to 100. Now the progress indicator, notice 100% is actually a 1.0. Anything less than 1 means it's not there. So this is 56 or 0.558, blah, 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 blah. So just be mindful when working with the progress indicator that you have to give it that. You can't say it's at 50%. You have to say 0.5. Pretty simple, pretty easy to learn. Hope you guys found this educational and entertaining. I just like doing this. It's kind of fun. But if you did find this educational and entertaining, be sure to visit my website, voidrelps.com, for the source code for this and all the tutorials. They're all out on GitHub. If you notice any mistakes, definitely contribute. It helps out quite a bit. And it is getting to that time of year where I need to pay for my web hosting. This site and all the tutorials are 100% funded by your donations. That's why there's 0 ads on these videos, and I'm trying to keep ads off of them because I think ads on YouTube really suck. So if you got a few extra bucks, feel free to throw it my way and I will help pay the bills. Thank you for watching. Everybody, it's Brian. Welcome to the 33rd Flutter tutorial. Today we're going to be talking about something called a drop-down button. And I looked in the widget catalog and all through here, and I could not find what I was looking for. I had a simple user feedback saying, hey, where's the combo box? And I dug through this whole thing. I couldn't find it. If you're wondering what a combo box is, it's just simply a little box or button that you can click a down arrow and it gives you a list of items to choose from. And I could not find that anywhere. It actually exists, even though I couldn't find it out in their documentation. We're going to work with it today and see how it works. It's been a little temperamental for me. This is the 3rd time doing this tutorial, and I'm a little flustered with Flutter right now. But it may actually be something I'm doing wrong, not Flutter itself. Also, big disclaimer, it's way past when I should have eaten, and I've got a slow cooker full of food downstairs. Then I can smell it all the way up here, and it smells just amazing, and I'm starving, so hopefully this will actually work this time. Otherwise, I'm just going to set this video aside and go eat. All right, so we're going to just do our boilerplate code here. All right, so let's do this. Run app. Yeah, told you I was hungry. New material app. Here we go. All right, I'm having nothing but problems here. All right, there we go. I'm going to create the state here. And now in the state, we're going to actually do a little bit of work here. So we've got our main, we've got our my app. Now in the state, what we need to do is actually not just define what we're going to build, but we also need to initialize a few things too. So we're going to say string value equal null. And then we're going to say list string values equal new list of the type string. It's 2016. I gotta start using the shorter method of doing that. Anyways, then we're just gonna hit Control O on the keyboard, and we are going to go to init state, and we're gonna override this. Now, what init state does is it says, hey, when this is loading up, we want to initialize the state. So let's actually initialize this. We're gonna say values dot add all. And from here, we're going to actually add all those items in there. And then our value is going to be values dot element at. And we're going to give it the 0 position. Why not? Probably makes sense if that was also a private variable here. There we go. So now we are initializing the state, and no state is complete without the build function, but we're not there yet. We want to actually do a void unchanged string value. We're going to, you guessed it, set the state here. That way, when we get to the control, which we're going to get to here in a second, and we do the on change, we can just plug it right in there and it just magically works. Now we're going to say widget, build context, and we are going to return a new scaffold. Man, dinner is smelling really good, and I'm getting really hungry here. I don't know if you guys can hear my stomach growling, but it's almost comical. All right, so at bar, new text. Oops, nope, we don't want new text. We want new at bar. Then in there we'll say title. And drop down button demo. Longest title ever. All right, so in the body, we want a new container. Padding, new edge inset all. We're going to say 32.0 because that's what we've been using for all of these. Child, we'll say new column. And new children. Whoops, not new children. On the children property, sorry. There we go. Whew, that's a lot of typing. Fingertips actually get a little numb when I type that much. All right, so in here now, we're going to make the magic actually happen. We're going to say new drop down button. Notice how it wants a list of items and it wants the on change. So let's break this down a little bit. So the on change is pretty easy to work with. We're just going to add in what we had before. And we're going to say on changed. That way it'll plug right in and set our state. Now items, this is where it gets a little bit different here. We want to take the values and we want to map them. You notice how it's saying string and then it's to a function basically. So what we got to do here is we're going to say map, and there's our little indicator that that's a function. And we're going to say toList down here. And in here, we want to say string value. So if you're not completely sure what's going on here, we're saying values, which is just a list of strings here. And we're going to map. And what map does is it goes through every single item in that list and performs a function on it. And that function is going to be right here. And then we're converting that map back into a list. So we're going to say return new drop-down menu item. So yep, that's exactly what we're doing, is we're just making a list of drop-down menu items. And this is suddenly complaining about something here. Let's see here. Could not print blah 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 type T. All right, so let's say value. All right, so we have our drop-down menu item here. And we are just going to work with this a little bit. So our value here would be, of course, the value. And the child would be we're going to do a new row here, just to show that even in the individual items, you can actually do some pretty complex things here. Children is going to be a list of widgets, and we're going to say new icon icons.home, new text, and we are going to just format this. We'll say person is, we'll say person, here we go, value. If you're wondering where value is coming from, it's actually coming from right here. It's coming from our map function. So each item in that list is going to be a variable called value, which is going to get shoved down into this function. And then in this function, basically what we're doing is we're saying make a new drop-down menu item and add in a value, add in a row. In that row, we have an icon and then the actual text. All right, so we have no issues that we can see. Let's go ahead and fire this up, see if this thing works. Now, the few other tutorials that I did with this, I actually got to this point. I would build it, run it, and it just would not work on the device. It would spew out some horrendous error message, and I'd have to figure out what was going on. And I would verify, the code, what I wrote versus the code in my notes, because what I do is I'll actually write the tutorial on another OS. I actually write it on a Mac. And then when I record the videos, I actually come to Linux and I type all this out that you're seeing now. But it appears this time it has worked. So I'm going to guess it's just something that I had been fat fingering. But here is our drop-down list in all of its glory. And you notice how you have an icon, you have the formatted text of person equals. Now, some of you are probably wondering what happens if you don't set the state. Well, you'll still see the drop-down, but when you click, it never changes. So it would just get stuck at whatever the value was. So that's all for this tutorial. Pretty simple, pretty easy to work with. It's actually kind of fun to keep clicking. Some little caveats I would note is that on some phones, if you have a huge list, it won't scale correctly and it won't scroll. So if you have like a gigantic list, you should use something called a list view, which is what we're going to do in the next tutorial. That's all. Thank you for watching. If you're so inclined, you can go to my website, voidrums.com, grab the source. It's out in tutorials. It's actually out on GitHub. And join the Voidrums Facebook group. We have 1,700 other programmers out there that can definitely help you with whatever questions you have. Thanks for watching. Hey everybody, it's Brian. Welcome to the 34th Flutter tutorial. All right, today we are going to cover the list view. And I actually didn't find it out in the widget catalog, but if you go to the sample catalog, they actually have quite a few of them out here. Like I think that's one, that's definitely one. And they use something called a card, which we're also going to add in here. But we're not going to do any of their tutorials. We're going to do something totally different. If you have no idea what a list view is, some good examples just by doing Google Images Flutter list view, you can see some really good examples. You can have, compound controls. When I call compound, I mean there's more than one thing in there. Like there's an icon, there's a text, and there's a checkbox, things like that. You can make some pretty interesting combinations of things. So really, it's just a list that shows things going from top to bottom, and you can add different things in there. So that's what we're going to be working with today. We're going to do a pretty basic example. List views can get very, very complex very fast. So import, and we're going to say package, Flutter material. All right, we're just going to set up our normal application here. All right, there's that. extend the state of my app here. All right, let's get rid of that because that was rather annoying. All right, so now that we got our my app here, we're going to override, and we're going to say make a new state for our stateful widget. All right, then in the state, this is where the action is really going to happen here. And what we're going to do is we're going to say we're going to make a list of Boolean values. And then we are going to override the init state. Don't know where that little semicolon came from. Whenever I do something like that, it really just kind of scares me. I'm like, oh no, what did I just screw up? All right, so here we go. We're just going to set the state on this. And we're going to say for and we're going to say we're going to just set everything to false by default. And then we are going to, my fingers are cold. It is like freezing outside. Even with the furnace going full blast, it's still cold in here. All right, now we want to return, not rect, return new scaffold object. Going to make an app bar, and on that we're going to say the title. And we are just going to say this is a list view demo. All right, so now this is where things get a little bit different here. We're going to say a new list view. And you notice how there's a couple different these. There's list view with normal, list view.builder, and list view.custom. We're going to cover list view.builder because this is kind of like the standard of what almost everybody's going to be working with here. Custom is obviously pretty self-explanatory, or not self-explanatory. It's when you want to do something completely out of the left of field there. Where list view itself, I think you actually hand it a list of things and it just kind of tries to figure out what you're doing. I've had nothing but problems with that, so I always use list view.builder. You see how the first thing it wants is an item builder, and this takes a little bit of explaining, but it's very simple to understand. So when you have a list of items, and let's flip back to our graphic here, you notice how they're all kind of standard size here. So what this needs to do is it needs to know how many of them there are and what sort of dimensions they really have, so it knows how much the user is going to be able to scroll and things of that nature. So you can see how this is different than, say, this, or even say that. You know, they're just different shapes. So let's go back in here, and what we need to do is really look at this guy, and we're going to say item count equals data.length. That way it knows how many items are in our data. Now the item builder itself, we want to actually turn that into a function here. And we want to say build context. So we can hand over the context if we needed to. Probably help if I spelled get build context right. That was somewhat embarrassing. There we go. And we want the index. The index is going to be the index in the internal array that the list view is going to be working with here. And we're going to tie that into, you guessed it, our list. We should probably put that semicolon there, we're going to have nothing but problems later. So now that we have our item builder somewhat going here, we need to actually do something with this. So what we need to do is, you guessed it, return a new widget. In this case, we're going to return a card. So let's save this. Let's run this, and let's just see what we got so far here. I kind of want to explain it as we go because it gets a little bit in depth, but it's kind of easy once you wrap your head around it. A lot of frameworks, especially in the old days, would not allow you to do some of the things that Flutter's allowing you to do, which is add custom compound widgets in. All right, so you can see there is our app bar, and there is absolutely nothing here. So we need to figure out what's going on here. Probably the first thing you'll notice is that we did not add in the correct data. So we have a new card, and in here we're going to gel new container, padding, why not, 32.0 because I love that number, and then child. In the container we're going to have a new column, whoops, new column filled with children, and the children in there are going to be, let's just kind of move this up so you can see it. So there's our index. And then we are going to add in a new checklist title. And the value of this little guy, actually let's break this down so it's easier to see what's going on here. Initialize our hot reload. You notice how as soon as we did this, bang, suddenly we've got items in here because now we're actually using that value and it knows what we're trying to do with it here. And we can scroll. So that's what the list view is really giving us here. So what we're going to do now is we're going to really make these things come to life. We're going to actually drop this down to 5 instead of 32. We're going to set the control affinity, and we want this to be list tile control affinity dot leading. As soon as we do that, that checkbox should jump over. Yep, now it's over on the left. And we're going to fill some of the stuff in here. I don't know what I want to put in here. How about we just say new text. I'm kind of going off script here. There we go. So you notice how this is grayed out. It's because we don't have this on change actually anything. It's just null. So once we fill that in, this will suddenly work. And then we'll tie that in using state so we can update our list in the background. So let's go ahead and do that right now here. All right, so set state. All right, so we're going to say data index value. So we're just setting the item at that index within the list to the value of whatever the onchanged was here. And here we're going to say full value on change, and then there's our value and our index. Save this. Now suddenly, automatically, it works. Pretty simple, pretty easy to use once you understand. Some key features you really have to wrap your head around is use the listview.builder. It's much easier to work with than some of the others. You'll always have to give it a length, and when you do the builder, just understand that you can put any type of widget out here. So we've actually got, each item has a couple widgets in it. You know, there's a text, and here is a checklist tile, and that checklist tile is actually made up of a checkbox and a text, and I'm assuming something in the background, so you can click way over here too. And it's all embedded inside of a card, so it's pretty awesome the way this works. And we can actually, let's just do this. Perform a hot reload on this. You see how now, whoops, maybe now we have to rerun the whole thing from start. There we go. So now it'll just go and go and go, and we've got all the way up to 1,000. Pretty simple, pretty easy to use, and personally I like it. I mean, compared to other frameworks out there, it is just ridiculously simple to work with. If you've ever had to juggle like list view adapters and models and things like that, it's such a pain. This is so much easier. So what you should really tie into is you'll have some sort of back-end data. In this case, I just have a list of bulls, but you can have a list of any sort of class and then have the data inside of that class. So you could have a list of people, a list of dogs, a list of pets, list of airline tickets, whatever. As long as you're tying that back in through the individual render here in the item builder, you're good to go. All right, so that's it for this tutorial. I hope you found this educational and entertaining. Be sure to check out my website, voidrealms.com, for the source code for this and all of the tutorials. It's out in GitHub. Ta-da! And I think they're under Flutter tutorials, at least they better be. And if you're still watching, go ahead and join the Void Realms Facebook group. There's 1,700 plus other programmers out there. We can definitely try to help if you have any issues. I'm in there every day, and I know a couple of the other admins are actually looking at Flutter very seriously themselves. So definitely check it out. Thanks for watching. Hey everybody, it's Brian, and welcome to the 35th Flutter tutorial. Today we're actually not going to do a whole lot of coding. I'm going to show you how to set up a live template. Here's why. Every tutorial, you see me type out the same old, design pattern. I think we've solidified that in our brains now, what everything does. And I make a lot of typing mistakes, and it takes me a while. And usually the first 5 or 10 minutes is nothing but me typing very badly, I might add. So like we'll say class my app extends stateful widget, and then of course we do this class underscore state. And what we can actually do is we can use what's called a live template. So if you just type S, and you'll see there is some right here. So there's a stateful. We're just going to say stateful widget. Double click on that, and bang, it types most of this out for you. That's called a live template. And we're going to actually just fill this in a little bit here. And then we're going to say run app. New material app, the home property of new my app. And then down here we have why is that returning a container? That's just weird. New scaffold. And then in the scaffold we're going to say app bar equal new app bar. Title equal new text. Name here, and then let's see, body. Whoops. Here we'll do a new container. Padding, edge insets. Whoops, let's do a new edge insets. Do a new column and children. We'll just say new text. add widgets here. And let's just run this just to make sure that everything is exactly the way we expect it would be. I got my emulator already up and going here. All right, so this will be the kind of design that we're choosing, the design pattern, which is pretty standard for a Flutter tutorial or a Flutter application. So we'll have an app bar, and then we'll have our widgets here. Now what we're going to do is take this whole thing and just cut that, and we're going to go to settings. And if you don't have IntelliJ, I'm sorry, I don't know if your IDE of choice will actually support this or not. You may have some IntelliJ variant though. And anyways, we're just going to make sure you're in the Flutter, and you're just going to add a new live template, and we'll say Flutter tut, and here we'll say Flutter tutorial. And we want to make sure that it is in shortened, fully quantified names, no application defined. We want to do Dart top level, and then just paste that text in there. Hit apply, hit OK, whatever you want to do. Now we should be able to just say Flutter tut, and bang, there is all the code. That will shave about 2 to 5 minutes, depending on how horrible my typing is that day, off every tutorial. And we can just move on from there. I think we understand the concepts of stateful versus state and stateless and all that. So that should save some time. And that's it for this one. We will resume the Flutter tutorials in the next video. Thank you for watching. Hey everybody, this is Brian. Welcome to the 36th Flutter tutorial. Wow, it's hard to believe we've done 36 of these. Today we're going to cover the drawer, which is a material design panel that slides in horizontally from the edge of a scaffold to show the navigation links in an application. I know you've seen these, but sometimes you got to see it to really understand it. So we're going to cover it. First thing we're going to do, if you followed along in my previous tutorial, we made a live template, so it'll save a lot of typing. So I'm just going to pop open the live template here, and that imports our Flutter material design package. It has a main which does the run app, which starts the material design application. The home property of that is a new my app, which is a stateful widget, which has a create state or a underscore state of the my app. You should understand all those concepts before really proceeding further here. In there, we just have a simple template of a scaffold with an app bar and a container with some widgets in there. We're just going to run this so you can see what it looks like with the default configuration here, just in case you missed the previous tutorials. So really this is all this looks like. And what we're going to do is we're going to add a little button here that when we click that, the drawer is going to slide out. We'll have an array of widgets that we can put in there. So without further ado, let's just dive right in here. So the scaffold has another property that we haven't really played with called drawer. And in the drawer, we can add, well, pretty much anything we want. So say child, and we're going to say and let's just say, why not? Let's just do 32.0 just because I really like that number. And the child, as you can understand now, the design pattern we've been following, whenever you say child, it expects a widget, or when it say child or children, it expects a widget. So we can put literally anything we want in here. So we can say new, text, hello drawer. And let's, actually I think hot reloading actually did take it. I don't have to reload the whole app. So now we have hello drawer. Pretty cool, huh? So what can we do with this? I mean, well, pretty much anything we want. We can put any widget in there that we want. So let's just add a few things and show how to kind of close this and do what we want to do with it. So we're going to say new column, and then we'll have an array of widgets here, and we'll say new text. I should have just kept that hello drawer. And then here we'll say new, let's do a raise button, because we've worked with the raise button before. And we are just going to say say it's going to be a red button. And let's give it a child of new text. And the on press, we are just going to say navigator dot, and we're going to pop it under the current context. So what that will do, and I'm just going to run the whole thing over again just in case hot reloading doesn't take that. So what that will do is we have our drawer, and then we have a text widget or anything else we want to put in here. For example, we have a red button that says close, and we click that, boom, closes the drawer. But you can put anything you want in here. You can put images, you can put text input fields, check boxes. Typically what a drawer is used for is for navigation. So you'd say that, and then you have like, account, settings, map, details about whatever you wanted to do. But we just wanted to cover the basics of the drawer class and how to get it open and closed. So that's it. Very simple, very powerful widget. It's actually part of the scaffold itself. So thank you for watching. I hope you found this educationally entertaining. For the source code for this and all other tutorials, go out to my website, voidrealms.com. It's out on GitHub. And feel free to join the Void Realms Facebook group. We have 1,700 plus programmers out there, all walks of life. We can definitely help you with your problems. Hey everybody, this is Brian, and welcome to the 37th Flutter tutorial. Man, we're getting close to 40. We're cranking through these. And we're doing it very quickly, which shows just how fast and easy Flutter is. I don't mean to sound all evangelical about it, but Flutter is actually pretty awesome. So today we are going to do the floating action button. It's a little red button here. I'm sure you've seen it in like email applications or maybe Facebook or something like that. So we're going to go here. We're going to use our live template, which we created in tutorial 35. And you should know what all of this means. We have our main, we have our myapp, which extends stateful, and we have the state of the myapp. If you have no idea what any of those means, please rewind, watch the previous tutorials. All right, so now that we have our bare basic application here, what we're going to do is start working on the state. So we're going to say string, whoops, and we'll call this last press equal, and we're just going to say never. So what we're going to do is really just print on the screen when they actually press the button. So let's get this in here and we'll say last pressed I gotta say, while I'm kind of typing this crud out, I'm really surprised at the feedback I've gotten on Flutter. For something that's an alpha and not very well known, my inbox has been pretty well flooded. All right, so now that we've got kind of a rough idea of what this is going to do, how do we add the button? Well, in the scaffold, this is why we love the scaffold, there's a floating action button property, and we just simply say, like kind of like the drawer, new floating action button. And you notice how there's an on press because this is a button and we need to manage that button press. So we're going to just pop that down so we can work with this a little bit here. And we're going to say child new, because we want to add an icon in there. And we're going to say icons dot, I don't really know what to add, timer, why not, timer. And then we're going to just change the color. So we're going to say background color equal colors.red. Why not? And then we just simply fill in the on pressed. And we need to make a function here. So let's put this back to null. And this is where the magic's really going to happen here. We're going to say print, just for debug purposes. And then we're going to say set state. And we're going to say date time, current equal new date time dot now. That way we get the current time. And then we're just going to simply say last press equal current dot toString. Just raw unformatted toString. There we go. And that should actually, oh no, we gotta fill in our little on press here or nothing's gonna happen. And voila, we will run this in our emulator here. Pull our emulator over while this is loading. And this should work without any problems. So one thing that I really love about Flutter while this is loading, and it seems like the more I do these tutorials, the more I fall in love with Flutter, is that it's very streamlined, it's very easy to use, it follows a very simple design pattern. You notice almost every single tutorial has followed a similar design pattern to the point I actually had to make a live template. So here's our button, and we click it, you can see there's our last pressed, and there's pressed. One thing I haven't figured out how to do, and I see this in my email program, is you should be able to click and drag that around the screen to reposition it. So if there's an element here on the screen, you need to tap underneath it. Haven't quite figured out how to do that. That may be a future tutorial. I'm sure it's a simple animation or something. They seem to have thought of everything with Flutter. So anyways, that is the floating action button. Very simple, very easy to use. If you found this tutorial helpful, the source code for it and all other tutorials is out on my website, voidrumps.com. There's a link right out to GitHub, and you can just crack that open, and it takes you right out to the tutorials. Also, if you're so inclined, be sure to join the Voidrumps Facebook group. There's 1,700 and growing other members out there. We can help you with all, I mean, not just Flutter, but I mean all different languages. And last but not least, if you're still watching, this site is 100% funded by your donations. That's why I do not have annoying advertisements in the videos. So if you are working with a company or your startup, you have a few extra bucks, feel free to donate it and I will help fund the website. That's it. Thank you for watching. Hey everybody, it's Brian and welcome to the 38th Flutter tutorial. Sorry, my phone made a weird noise. I had some user feedback. I really try to keep up on my inbox, but sometimes it's just impossible. This one really stood out. It said, hey, I've been doing work in Android and I want to know how to do application lifecycle in Flutter. If you have no idea what I'm talking about, just Google Android app lifecycle. And there's tons of graphics out here that kind of explain there's a created, a started, a resumed, a paused, a stopped. And what is all this? What does it really mean? All right, so if we just do our live template, we're going to run this. Here you see we have the clock application open. It's going to flip over into our app. So this thing is now running. Now what happens if we go back into that? Well, cell phones are not like your laptop sitting in front of your desktop. They run on limited power, they have batteries, and they have power constraints. So what they do is when you put an app into the background, they will pause that app. And when you pull it into the foreground, they'll resume that app. So sometimes, some applications, it's very helpful to know when the application is in and out of the foreground or when it's paused or suspended. So that's what we're really going to look at today. Kind of non-visual. You're going to have to kind of take a little bit of a leap of faith here, but that's what we're going to do. All right, so first thing we're going to do is we are going to say with widgets binding observer. Bang. So what this will do is it'll allow us to actually observe the life cycle in pretty much real time. So we're going to do a Control O and just have a look around here. You notice how there is some interesting properties here, like did change locale, did change application lifestyle state. Ooh, that sounds promising. We're done. Definitely add that. And then we're going to just Control O again. And we want the init state. And let's just Control O one more time. And we're just going to have a little peek here. Dispose. There it is. So now what you can see is kind of a pattern here. We got when the state is initialized or when it's first turned on, when the did change app lifecycle state, meaning when the cycle changed. Did it get paused, resumed, suspended? And then when it's disposed, meaning it's no longer needed. Remember, in Dart, there is no such concept as a deconstructor. So you can't simply say, hey, the deconstructor of this class like you would with other languages. You have to actually track this whole life cycle. Gets a little tricky, but it's really not too hard. So we're going to say print init state, server.init state, and then widgets, widgets binding observer, the instance. Why are you not doing? Oh, that's why. Widgets binding instance dot add observer, and we're just going to add this, the current object here. So what we're doing there is we're binding to the widgets binding instance, blah, 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 basically saying we want to observe this object's life cycle. Then in the dispose, we'll fill this out because it's pretty easy. We're just going to do the exact opposite here. I'm going to actually pull this up here so we can see it a little better. And we're going to say, dispose, and we're going to say super.dispose. But we have to do this at the end here. And here we're going to remove observer. So we're going to stop watching this object. Now the magic actually happens right here in this did change app lifecycle state. And what we need to do is just say print, and we're going to just say we're just going to print out the current state, and then we want to actually switch on this thing. So say switch state, and we're going to say case app lifecycle state dot, and we'll say inactive. Paused. Why is this suddenly griping and complaining? Missing, oh, that's why. It knows what we need, so it wants to force us to do everything. So we're just going to add those in super quick. We're going to say paused, we want resumed, and suspending. And then we're just going to grab that because I want those to stand out a little bit here. We'll say inactive, paused, resumed, maybe, and of course suspending. All right, let's actually reload that whole app. And you can see the first thing that happened was a init state. Oh, where is it? We'll do a full restart on this thing. It says it restarted. Did I break it? I have a very good knack of breaking things. We're just going to clear everything out of here. Start it again. Maybe that's a bug in Flutter. I don't know. All right, so we're going to start this whole thing again. Disclaimer alert, Flutter is still in alpha, but I have a habit of just horribly breaking things. So, okay, so there is our init state right here. Bang. And what we're going to do is we're going to actually, and you see as soon as we click that, it's still kind of there. It's in the app chooser. You can see how the state equal lifecycle paused. And if we go back, resumed. So that's kind of what it would do. So if we were to, let's just clear this out. What if my Dart analysis is not working? Darn it. I got to figure out why that doesn't work. But anyways, so if we go in here and we just go in here and we open, like, say, the clock, you can see how our app is paused. And then if we just go back in, you can see how the state equals resumed and resume and life goes on. Now let's clear this out and let's actually kill our app and see what happens here. And you can see how lost connection to device, but nothing actually happened. We didn't actually get to dispose there. Kind of a little disappointed in there, and it might be a bug in my code, not necessarily in Flutter itself. But it gives you a rough idea of how to actually interact with these. Now, what would you use them for? Well, let's say you're running like a live video feed or something. Well, whenever it gets paused, you want to actually pause that video feed. You want to stop downloading because the user's no longer looking at it and you're just chewing up their battery. And then when it resumes, when they pull it back into the foreground, that's when you would start it again. Init and dispose are a little bit different. Init is where you would like load the settings off the disk or download from Firebase, where dispose would be where you would clean everything up. And I'm kind of a little wondering why I never got a dispose here. I'll have to figure that out. But I hope that answered your question. I know it took me a while to figure this out, and there really wasn't a whole lot of clear examples out on the web that I found. Maybe you'll have better luck. But at any rate, thank you for watching. I hope you found this educational and entertaining. Source code for this obviously will be out on voidrums.com. You just go to tutorials and then GitHub, and be sure to join the Voidrums Facebook group. Hey everybody, it's Brian. Welcome to the 39th Flutter tutorial. Today we are going to be going over date and time pickers. This is kind of a little bit of a complex one. I've had a few questions on how to use this thing. People seem to be mystified about it, and when you go into the documentation, you can see there is a kind of a rough template of what you need to do here. There's a future with a date time show picker, and it kind of, I don't want to say it's difficult to understand, but for somebody who's new to this, it definitely has a little bit of a learning curve on how to use these things. So we're going to jump right in and just do it. Now, I should note that I am very closely following the source code, the official Flutter GitHub repository. Not on all tutorials, but on this one specifically, I am actually pretty much just ripping out these two functions, simply because it's really the only real way to do it. It's pretty efficient. So just wanted everybody to be aware of that. So we're going to say add our Flutter tutorial live template. If you have no idea what that is, it's because you did not watch the 35th video where I showed you how to build a live template. All right, so we're going to import the Dart async so we can work with futures. And we have our main with our stateful widget and our state. And we're just going to actually build into this thing. And we are going to say date time, date equal new date time now. And we're going to say, what is it, time of day, time equal new time. Whoops, I want time of day, not that. Time of day, not now. So we're just going to grab the current date and the current time here. Now, what we want to do is write two functions, one to grab the date and one to grab the time. So we're going to say future. Maybe if I could spell future. And we're going to say select date. This is, of course, an async. Why are you not popping up on me here? I think I broke my IntelliSense. Let's see if it'll start. Maybe if I did it like this and actually did it correctly. There we go. Man, it's frustrating when you're typing and IntelliSense just decides it doesn't want to work because you didn't know what you're typing to begin with. But anyway, so we're going to say final. And when you type show, you're going to see there's a show dialog, show bottom, blah, blah, blah. We want the date picker. And you see it has a lot of properties. So we are going to term that. I'm trying to figure out why this thing is freaking out on me. It's because it's an async function. We have to await it. There we go. I was staring at the screen going, why is that complaining? All right, so we have our show date picker function, and we want to actually add in the build context here. That way the dialog knows where it's coming from. There's our context. And for our initial date, we want to just say the date. And this is where it gets a little confusing. You have a first date and a last date. Well, you don't want them going all the way back to the beginning of time, and you don't want them going all the way forward to the end of time. So you have to say like new date time, and we're just going to say the earliest they can go back is 2017. Actually, let's say 2016. And we'll say new date time. Earliest they can go is 2019. So we're going to really limit their choices here. Then what we need to do is kind of monitor this thing. If picked, well, that's not even an if statement. What was I thinking there? There we go. Not equal null. and picked is not equal to the current date. We're just adding a little bit of logic here. Actually, I don't want that. Then what we're just going to do is we're going to say print just going to grab that toString, and then we're just going to set state here. And then we're just going to say the date is equal to the picked value. So there is our select date function in all of its glory, and we are just going to just completely copy this. Man, I am really screwed up today. New raised button. Too many positional arguments. What? Oh, I forgot the child. Got a little ahead of myself there. I was like, what are you talking about, Flutter? I know what I'm doing. Unfortunately, I really don't know what I'm doing, apparently. So we're going to say select the date, and it should show the context in there. There we go. So anatomy of this code is very simple. We are going to return a future, which is actually a null, meaning we're not going to return anything, but we are going to use the async functions for this because this is an async call. We need to await it. So once we've actually awaited for this whole little block of code to finish, then we're going to have this picked value. We're going to make sure it's not null and it's not the currently selected date because we don't want to update a change if no change actually occurred. Then we're just going to simply print out our debug statement, and then we're going to set the state so that we can track this whole thing all over again. Got our little emulator up, and we are going to push this bad boy out. All right, give it a second to build. Oh, what have we here? Semicolon expected on press. What did I screw up? I think that's a pretty self-explanatory error. There we go. So there is our selected date, and if we hit select date, bang, there is the date selector. And go back here, and there is our selected date. We said the earliest we could go back is 2016. Let's actually just test that real quick. Yeah, it won't let us go any further back. If we hit cancel, nothing happens. We select a new date, bang, get a new date. So that works pretty well. So what we're going to do next is we're going to actually just put in a new text as a spacer here. Don't like doing that, but I'm just kind of being lazy today. So we're going to add that, and then we are going to actually future with a null. There's our async function. Get rid of this so we can actually see what we're doing here. And then we want a pretty much same design pattern. Final, time of day, picked, equal, await, and we want the show time picker. And this thing wants a context plus an initial time. So this is going to be pretty straightforward and easy to work with. So we'll give the we haven't had the context in here. Got a little ahead of myself. There we go. And the initial time we're going to say is the time. Then we're just going to, for the sake of speed here, just copy and paste this. Bang. And we want to copy this. Very similar design pattern. We are just using asynchronous call to the show time picker. We're waiting for that. And then once we get that, we're making sure the picked is not null and it's not the current time. And then we're just saving the state back up. So we are going to just continue with our blatant copy and pasting here. That way it's very simple, very easy to understand. And hot reload should grab that. There we go. So now we can actually choose a time. And there we go, 9:30. And it'll pick it back up where we left off. We could say 7:30, 2:30, whatever we wanted to do. So that, in a nutshell, is the date and time pickers. I hope you found this educational and entertaining. I thank you for watching. And if you're so inclined, the source code for this and all other tutorials is out in my website, voidrumps.com. There's a link to the GitHub. And let me just crack this open here. So you just go down here, you click on Flutter tutorials, and they're all numbered. And you can actually just clone that whole repo so you have all the code. Also, there is the Voidrumps Facebook group with 1,700 other programmers out there. Not just Dart and Flutter, all different languages. So if you're working on something completely different, you can ask a question there, and most of the time we can help out. Last but surely not least, this site is 100% funded by your donations, so please consider donating if you got some spare change laying around. Hey everybody, it's Brian. Welcome to the 40th Flutter tutorial. Today we're going to be going over the simple dialog, which, don't let the name fool you, it's anything but simple. It's actually a very powerful and complex piece of code here, so we're going to go over this in detail. First thing we're going to do is bring up our live template. If you have no idea what I just did, go watch video 35 in this series. Alright, so import, and we're going to work with async, so we need the Dart async. And in here we're going to modify our state. So we want string, and boy, I cannot spell answer. That's embarrassing. Alright, so we've got our answer. Now we're going to have a function that sets this. We're going to say void set answer string value. And from here we're just going to do the set state. And from here we're going to say answer Alright, so I just put that little to-do there, so if you're using this as a template, you would say, okay, record it to a file or send it to a database or whatever you were working on. So we have our little set answer there. Now we need to actually show the dialog, and this is kind of the meat of the tutorial here. Null, not num. Geez, what are you thinking there? I'm going to do ask user. This is an async call. So in here, what we need to do is build a simple switch statement. I'm going to say switch. And in here, we're going to say case. Oh, I almost forgot. What we need to do is back up just a bit. Part of what the simple dialog does is it actually can take in a num and display it to the user and get the answer back to them, or get the answer back from them. So we've got our enum here, answer. So we're going to say answer dot yes, and then break. And via the, let's just do this, set answer. Through the magic of copy and paste, we are just going to make a few of these here. All right, and you could actually process it down here in the switch as most people do, but they're all just going to call set answer because they're all pretty much going to do the same thing here. All right, now that we've got our switch, we need to, well, switch. We need a value to switch on. So what we're going to do is await the show dialog, and it has a build context and a child, and we're going to actually pop that over there so we can see very clearly what's going on. So the context is just going to be the current context. And the child, we're going to show a new simple dialog. And the simple dialog has got a few properties. And what we're going to do is we're going to say the title and children. So title. Do you like Flutter? And for the children, see, that's an array of widgets, so we can add literally anything we want to this. We could say, like, raised button, or we could say text, or radio, or whatever we want. But there is a widget specifically for this thing, and it's a new simple dialog option. Let's get the simple dialog option in there. And the simple dialog option has an onPressed, which we're just going to say null for now, and a child property. And the child, we're just going to say add a couple little, things in there. And for the onPressed, let's do navigator.pop, and it takes the context and it takes a dynamic result. So the dynamic result is going to be answers.yes. So really what we're doing is when this is pressed, we're going to pop the navigator under the current context with that enum value right there. And we just grab this little guy. And I'm sure there is a much more streamlined way of doing this, but I want it to be very obvious what this program's doing. Expected to find, oh, derp, completely forgot. So much for copy and paste saving us time. And then we have our maybe. We have the skeptical maybe in there. So just to kind of recap here, this function returns future null, which means we're actually not returning anything. It's an asynchronous function. It's asynchronous because the show dialog is async. We have to await on that. We're going to switch on the value returned out of that. And what this does is it takes a enum, which we have up here, and basically says, hey, which one of these do you want? So you have simple dialog option that has the enum values in it, and you are popping the navigator, meaning pushing that data back. I shouldn't say pushing, you're popping the data back. That's the correct way of saying it. All right, now what we need to do is just simply say, there's our answer. We're going to say new raise button. Just going to say click me, and then of course we are just going to say bang bang and ask the user. Now this should work. Let's bring this up in our emulator. Seems to be taking a long time to compile these days. I really didn't do anything super complex. I wonder if it's my computer. There we go. So we have a you answered blank. And if we say click me, do you like Flutter? Yes, no, maybe. And we're going to say yes because we love Flutter. And it says answered yes. So you can see how you can pretty much do anything you want here. Now, the really neat thing about this is you can add other things because it is a, where is it, a array of widgets here. You're not just constrained to the simple dialog option. You can say something like I have no idea what to put there, just icons.home or something like that. Hot reload should take care of that. And then we have a home icon at the bottom here. You can put buttons, icons, whatever you want. It's actually very, very convenient. So if you wanted to do like a radio list group, so you have radios to check from or check boxes, or do you like Flutter? Maybe, and then like a little input field or something like that. You can do all of that. It's very, very straightforward. So that's it for this tutorial. I'm going to click yes because I like Flutter. Thank you for watching. You can find the source code for this and all other tutorials out on my website, voidrealms.com. And be sure to join the Void Realms Facebook group. I can't push that enough. Everybody sends me emails and questions. Join the Void Realms Facebook group. Ask questions out there. There's 1,700 other programmers because I'm not always available. And that's it. Thanks for watching. Hey everybody, this is Brian and welcome to the 41st Flutter tutorial. Today we're going to do something a little bit different. I've been getting a lot of feedback and some people kind of want to see a quote-unquote real-world application. So we're going to make a quote-unquote real-world application. I don't edit my videos, so you see all the successes, challenges, and complete and utter failures and spelling mistakes. So there may be parts of this you're going to want to fast forward through. I try to whip through it pretty quickly, but being what it is, it usually is filled with errors. So we're going to make a pizza ordering app. Now, while this won't actually order a pizza, it will be the skeleton from which you could order a pizza if you had your own pizza company. So from here, we're going to create a directory, and we'll call this screens. And we want to create another directory here called images. Now you notice how images is actually at the root. It's not down in the libs here. And we want to create another directory here called code. I'm just kind of showing how I break things up a little bit here. All right, so what we're going to do here is we are going to build an application that allows the user to order a pizza and select toppings and size and things like that. And I'm going to start the emulator up and kick that off in the background while I'm sitting here talking. All right, now first thing we want to do is create a Dart file here. And we'll just call it pizza. And we're making this in the code folder. And this is going to be the actual state of what we're saving here. So class pizza. And in the past, what we've done is we've had the state per page. And what we're going to actually do in this is we're going to make this class on one page and then hand it off to another. And we're just going to make the list of pizza sizes that are available. Oops. And we're making this static because we want to be able to access this from outside of a instance of the class. And you'll see what I mean here in a little bit. All right, now we want to say string size, the initial size that we're going to let them choose, equal sizes dot element at, and we want 0. That has to be static or we won't be able to use that as an initializer. And then we want the map we're going to call this toppings. Man, caps key didn't want to work there. And I've been asked a lot of questions like how many of Flutter apps have I built, what have they been used for, things like that. Really, they've been a lot of internal prototypings of future projects that I'm working on. I've actually been looking at getting I want to say a prototype up and built for a big project, and I've been looking at different. Make sure I spell pepperoni right, or I'll never live that down. All right, there we go. Yeah, you guys will never let me live it down if I spell it, although I always misspell everything. It's like a curse. But anyways, I want to find just like the perfect mobile framework to work with, and it's got to be cross-platform, and it's got to be a few things. And it's got to work with Firebase and Facebook integration, and it can't cost money. It has to be open source. There's a few requirements for this project, and that's what really led me to Flutter. So we're going to add just some toppings here. Pineapple. Usually I'm like a pepperoni sausage, extra cheese kind of guy. I don't really like pineapple on sardines, and I'm just adding a bunch of weird stuff. Onions, I guess those are right. I usually just pick them off, throw them in the trash. Mushrooms. Let's see, peppers. I don't know. I gotta think of some crazy stuff here, like, I don't know, pickles. We'll call it the pregnant pizza. Maybe chocolate. Not sure. Jeez, I misspelled chocolate. That's embarrassing. Alright, what else could you throw on a pizza? I'm just trying to think of some really off-the-wall whack bananas. Why not a banana pizza? Banana. There we go. And one more. Why not? What could we throw on a pizza? Olives. There we go. All right. So really what this class is going to allow us to do is hold the state in memory as we pass it from one page to the next. And we've got the size, or I should say the sizes that are allowed for the user to pick. The default size, which is going to be the first one when this class is first created. And then we've got a map of toppings, and they are all false initially. All right, so that is in our code file here. Now we got to create some screens. Dart file, here we go. Call this home. Home is kind of like always my de facto. What I'm doing next is going to just build out the rest of them. We want order. This will be where they actually order the pizza. And I've got to kind of slide my notes here a little bit. And then one more, which we will call review. This will be actually after they've selected the pizza and their toppings, and then they want to review their order before submitting it. That's kind of like the typical way of doing something. So we're just going to, because these depend on each other, we're going to work backwards here. So what we're going to say is import, and we're going to import the package Flutter material, and then we're going to import the package pizza demo. And we want to be in code, and we want to import the pizza.dart file. That is our code file that has all of the state goodness here. Then we'll say class, review, extends. So we want the stateless widget because we're not going to hold any state here. And we want the pizza called pizza order. And that's just going to be null initially. And then we want a list with string, and this is what we're going to just kind of convert our pizza order to. And we could have wrapped this functionality directly into the pizza class, but I just kind of wanted to separate it so you could really see. All right, so we've got that and that. Now what we need to do is, let's just get rid of this complaint here, override widget build context. All right, that is going to include the body here, so we need to return a scaffold. There, now it'll stop complaining for a minute. All right, so a couple things need to happen on the review page, and this is the final page right before they submit their order, is we need to actually take the existing order and render it out for them to view, and then, basically have a button for them to do something with. So to render that out, we need to actually create a list, and then we're going to present a list view to the end user. So what we're going to say here is review. This is the constructor of the class in case you were still fairly new. So to use this class, you're going to have to hand us an existing order, basically. Without that, you just can't create it. I'm going to say pizza order equal order. And then from here, we are just going to say, we're going to add the value of the size. We'll say size equals, and then we want the there we go. And then we're just going to say list.add, and we're just going to add a blank line here. And then we're going to save a little bit of time here. And we are going to say pizza order.map, actually toppings.map. This is why I put it in a, not map, this is why I put it in a map, so we could do the for each. And then we're just going to say bang bang, and then do that. Create our anonymous function here. So then we got the name and the value, and we're going to say if value, then going to add the name there. So pretty easy to understand. When we create an instance of this review.dart, we are going to take the existing order out of the constructor, we're going to add it into our pizza order variable, and then we're going to generate a list which we're going to present to the user in the form of a list view, which we've done before. So down here in the scaffold, we are going to say app bar new app bar. Why are you messing up on me here? Oh, title, okay. Say review pizza order. And then in the body, we're going to say new container. Going to do 32 padding, and let me get rid of this little bottom thing so we can see what we're doing here. Now, child, we want a new column. And in the column we will have the children. And then we have our array of widgets. So we're going to say new text. And let's actually break this down a little bit here. And we want the font weight to be the font weight bold. So we're just going to boldface that, review your order. And now that we got that, I think I'm just going to collapse that back down into one long one, just to keep it nice and neat. Sometimes I get overly picky about this sort of stuff. All right, so we have our text. Now, this is something that, if you're kind of zoning out on me, you're going to have to kind of pay attention to a little bit here. what we want to do is add a list view like we've done in the past. The problem is if your list view goes outside of the bounds or the visible area of the material that you're working with, it will display this ugly yellow and black bar, and you'll probably see that later on in the tutorial, but I'm going to add this just to get rid of it. It's a new expanded. And what expanded does is it, well, expands as far as you need it to go, really, without getting overly technical. And from this, we're going to say new list view dot builder, and then of course we do our item builder from that. So what we need to do now is let's break this down. We've got our item builder null, and let's do shrink wrap is true. That way we don't run into any bounding issues. Item count is equal to the list that count. Whoops, list that length, that count. And then for our item builder, this is where we want to say context. Oh, what is this thing complaining about? Null can't be assigned to the parameter type. Well, we're not giving it null. Oh, I know what we missed. There we go. That should make it happy. So in here, what we need to do now is break this item builder out and actually have it build the items. We've done this before, but just so we understand what's going on here. We're going to just simply return a new text. Pretty simple what we're building here. Let's get rid of that. And we're going to return the element at index. So really we're just saying, hey, the list.length is the item count for the item builder. We're just going to go through each item and then print out each line of that list. Pretty simple, pretty easy to understand. There is our review page. And now working backwards, we're going to go to our order page. Actually, I think we're going to fast forward. We're going to go to the home page because I want to actually run this and display something here. So I'm going to say import, and we'll say package, and we'll do the Flutter material package. Class home extends, and we want the stateless widget because we're not holding a state at this point. And we want to override the build function. I've had a couple people ask me, not just with these Flutter tutorials, but other tutorials, how hard it is to actually make a tutorial, and it's pretty challenging. Trying to think, type, and talk all at the same time is not really my forte. As you can see, I'm making some very gnarly little mistakes here. So the home page is going to be very simple, but there's going to be a key element that I don't think we've gone over yet. We're going to just, how to display an asset image. So what we're going to talk about is getting that in there. So we'll say app bar equal new app bar, title equal new text, pizza demo, why not? And then from here, we're going to say body. Just get our padding in there, and then we're going to say, do I want to center this or I want to just column it? I think I want to just, I want to back this out a little bit. I do want to center that. There we go. Whoopsie. There we go. There. So we're just going to center this container, and then in the container, make a new column, And then in our children's, we're just going to have simply two widgets in here. We're going to have the image asset and the raise button. Now, before we do the image asset, this is going to be key. We have to actually add the image in. So we're going to go to, I have this little pizza image. If I can just blow this up, that's what it looks like. So I'm just going to copy this, literally copy it, and then go over to my images folder and paste it in. And make sure that it's in there. Now, I do want to check one thing real quick. I think it's this pubspec.yaml file. And yeah, you see how it didn't add the asset in. So we're going to have to add that in. So let's, and it says literally to add assets to your application like this. So we're just going to go bang, bang, and we're going to say images, and we're going to say pizza.png. Pretty sure that's what it's named. And that's the full path to it from the base or from the root. So it's in /images/pizza.png. Just make sure that is in there. All right. PubSpec's been edited. Pub failed. Ooh, that's not good. What did we screw up here? Let's go back and look at that. Oh, that's why. Let's try pounding that out like that. That should work. Okay. So if you're wondering what the heck that was all about, it's got to be tab indented. There's a certain parser that runs in the background, and it wasn't tabbed. So putting that tab in there, suddenly it magically knew what I was talking about. All right. So what from here, we're going to say new, and we're going to say image.asset. Whoops. I screwed that one up. Say new image.asset. There we go. And then it wants the fully qualified name here. So we're going to say image. And then from there, we are going to say new raised button. And then expand this out. And we don't have the navigator in there yet, so let's work on our main real quick here. And we want to import the material app. We want screens, and we want home.dart. Right now I'm on a mission just to get that home page showing. So and we're going to do a run app. My app doesn't exist yet. We're going to build that super quick. And then we'll say class my app. And we're going to extend a stateless widget. Now from here, we need to override, you guessed it, the build. And then we're just going to simply do navigation like we've done before. We're going to say return new material app. And then from inside the material app, we're going to do our navigation. What is this thing griping and complaining about? Did I build an app? No, it doesn't. Subtype blah, blah, blah. Why is that complaining? Widgets build context. Did I misspell something? See, this is the part that drives me nuts about not editing my videos, because you'll sit here for about 20 minutes watching me trying to figure this out. Invalid override. Build context. Isn't a subtype? Of course it is. Oh, I see what it is. It's not widgets, it's widget. Derp. Now I feel stupid. All right, so there's our material app. And there we're going to say title, and we're going to say navigation, and then of course our routes. And we want the widget builder. Now that we've got our string widget builder, we are going to simply say bang, bang, and then create our routes. And we're just going to copy and paste this bad boy, because why not? Save some time. And from there, we can just copy and paste this whole thing and make our 3 routes: home, order, and review. Boom. And we're just going to, let's flesh out this order page real quick. We're just going to do the bare minimum on the order page. All right, import package material. And then we're going to say extends the stateful widget. And then we're going to override the state, which doesn't exist yet because we're going to build it here in just a second. Always makes me nervous when I type things out before I've actually created them, because then, you know, IntelliSense isn't helping me, and I have a nasty habit of typing faster or slower than I think sometimes, or faster than I think. So we are just going to make the state of the order, and then we're going to, you guessed it, override the build. And from here, we're just going to return a new scaffold. And I kind of want to mess with this one last, just because this is going to be kind of the meat of the application, and I really want to make sure we get this right here. So we're just going to say new center, and then in there we're going to say child equals new container, and then child equal new, what do I want to do here, new column. And we'll just leave that blank for now. I'm going to add the padding in there. Edge insets all 32.0 because that's kind of my favorite here. All right, so now it's time for us to actually try to give this thing a build and make sure it actually runs. We've got kind of the bare bones of our application. And so the main Dart file, we are going to, actually we need to import some things, so this is going to complain. Order, and then review. All right, now it should kind of somewhat run. So our main Dart file, we just have our material app, and in there we have our routes. The goal of this is to bring up the home, and we're going to see if we can get that to work real quick here. We are actually missing a piece here. Home equal new home, otherwise it won't do anything. There we go. So we're going to have our initial route in there. All right, let's give it a whirl and see what breaks and what works. Pull up our Android emulator here. I've had a few questions about why I use the Android emulator instead of the iOS emulator. It's very simple. It's just because I'm programming on my Linux machine. If I was programming on my Mac, I would have a choice of both, which you could probably just do both at the same time. I haven't really gotten into that simply because I have my microphone plugged into my Android box. Android box has been kind of my main development box. All right, so there is our home page, and the order button is grayed out because we haven't put that in there yet. We're going to do that navigator next. But you can see there's our beautiful pizza icon, and we're going to just start fleshing this thing out. So let's switch over to home, and there's our onPress is null. We're going to say onPress bang bang, and then we're going to say, whoops, the navigator dot of context, and then we're going to just do a push name, and we're just going to push over to the orders page. Hot reload should grab that. Yeah, now we can actually click our button, and nothing happened. Oh, I think we're missing something here. Import package. Whoops, that's not what I wanted. Pizza demo screens order. I bet we just forgot the import here. Let's try that again. Hot reload, and nothing happened. This should work. Let me rerun the whole thing. Maybe it just didn't pick it up. If it doesn't run this time, I'll actually read the error message. I'm not a fan of modern day error messages. Ah, come on. All right, what's going on here? Blah, 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 blah. Exception caught by gesture. The following assertion could not find generator of route orders. What? We have it right here. Oh, that's why. Order. Hence, spelling error. All right, let's try that again. Now suddenly it goes to our order page. All right, so we have basic navigation, we have an image, and we're going to start actually just doing the order. The review page should be done, so we just got to really focus on this order page. Once we hammer this out, we should be pretty well done here. So let's flip into order, and we got some work to do here. So we want to import our package, screens review. We want to import the package from the pizza demo code pizza, because we're going to work with that class. We're going to make a simple order here. And from here, we need to actually go into this and actually build our state out. Say pizza, pizza order, equal new pizza. Ah, no IntelliSense, why have you betrayed me? All right, there we go. So we're going to have a couple things in here. We're going to have a, let me pull this up so you can actually see what the heck I'm talking about here. The way I want it is we're going to have a drop-down box here so we can select the size. And then we're going to have a list of toppings in a list view and then a button at the bottom so that we can actually review the order. It's pretty simple, but it's a little bit of a learning curve to get this to work just right. So let's actually just start working on it. And we are going to say new drop-down button. Drop-down button, where are you at? There you are. And then we have items and null. So what we want to do here is we want to actually give it our template, which is going to be a string, which I'm not sure if that's really needed or not, but we're going to add it in anyways. So our items are going to actually be the pizza class dot sizes dot map, and then we want to map that I don't think we really want the on change, do we? Yeah, we do. Hold on a second. Let's do this. Let's go. We want our value. We want the initial value to be the pizza order dot size. There we go. That's what I was getting hung up on. Now, what is this thing griping about? Too many positional arguments. What do you mean there's too many positional arguments? Why are there too many? 0 expected but 1 found. What are you griping about here? Yeah, I'm not liking this. Something's going on. Let's just start over on that. New. Drop down button. Bang. Item null. Oh, duh. I feel really stupid here. Children. Bang. Okay, that makes more sense why it was griping. I was hung up on that button. Anyways. New drop down button. That looks a little cleaner. Okay. Like I said, sometimes typing, thinking, and talking all at the same time really don't mix well. So pizza order dot size. So we want the initial size, and then the onChanged, we're going to actually make a function here. So let's just mess with that first. We want to do the set size. And let me look at my notes, make sure I'm actually doing this right. Yep. All right, from the set size, we are going to just simply do a set state. And in the set state, you might have already guessed what we're going to do here. We're going to say pizza order dot size equals the size. And we should actually say value. That way we're not really confusing anybody here. All right, now in here, we can actually say our have to scroll down, make sure I'm in the right spot with my notes here. It gets really confusing if I get kind of off here. And then we want our string value. There we go. Now comes the really confusing part. I really don't like the way that the drop-down button is handled, but it's just is what it is. So for the items, we have to do the pizza order. Actually, no, we don't. Sorry. We need to do the pizza dot sizes dot, and then from here we do the map. And this is where it gets kind of really confusing for people. So we're going to say string value. And then we're going to map this accordingly. And then in the mapped, we're going to return a new, I think it's a drop-down menu item. And then there's our child null. So let's break this out a little bit so we can see what we're doing here. All right, so the initial value of this, or I shouldn't say the initial, the value of this is value. And then the child itself, we're just going to make a new row. And then we're going to have children in here. And in the children, we're going to say new icon, icons, what was it, local pizza or something like that? I found this really cool icon. There we go, local pizza is an icon. I was really surprised when I found a pizza icon. I was like, yay. It's little things in life that really make us happy, you know? And then here we're going to say simply size equals and then the value. Add that in case we decide to mess with any more properties. Hot reload, we're going to actually just start this whole thing over again. Did a lot of typing, I wasn't really trusting hot reload. And boom, we are presented with a big fat error, and we are going to have to figure out, whoops, nailed my microphone. Alright, let's see here. Type mapped list iterable string, blah blah blah, is not a subtype of list drop-down menu. Say what? Mapped list iterable. Alright, so basically what it's arguing about is in here. I bet I know what the problem is. We didn't give it a type. Nope. Let's just stop this thing again. See what it's griping about here. Map list iterable string dynamic is not a type of list drop-down menu item string. Okay, well, what is the problem with this? So we got drop-down button string, pizza order sized. Oh, I see what's going on here. Okay, I think I see what's going on here. We're missing a list here. Yeah, two lists. That's what's going on. If this is right, I'll explain the voodoo magic that just occurred. Tick tock, tick tock. Let's check our order, and okay, yeah, it's what I thought it was. So now we've got a drop-down list, and we've got the on select, so or on the on change, so it's tracking in the state. So the thing that I was missing here was this .to list of this whole thing. And if you take that right there, it should highlight it. Yeah, it's on the pizza map. It's in the items. Because the items is expecting a list, and I was just giving it a mapped. So I was just giving it a whole wad of data rather than an actual list, and that's why I was complaining. Some of these error messages. All right, anyways, so we've got this, and this is a major hurdle right there. The rest of this should be, quotey fingers, should be fairly straightforward. All right, so now that we've got that, we're going to new expanded. And I had to actually go into the Flutter live chat they have on their site because I didn't know what the heck was going on with this. I tried just adding a list directly, and it went out of bounds, and I'll actually demonstrate that here in a little bit. And it showed that ugly bar that you guys may have actually encountered by now. All right. Now let's call it continue. All right, so in our expanded, we want to put a new list view in here. We want to do list view builder, and as you can see, our item builder is going to be null initially. Let's just get rid of that blank line. That way it doesn't get all confusing. All right, and we can just say shrink wrap true. Probably don't really even need that, but I like putting it in there. And then item count. And the item count here is going to be the length of the toppings, because remember that's a map under the hood. And then the item builder, we want to actually do a non-function here. And in this, oh yeah, I keep forgetting that index. I always forget that. That's my only really gripe about this. Otherwise, it's very beautiful the way that works. Now we're going to return a new checklist title, which we covered in previous tutorials. Let's put the semicolon up here. And we want to add a few things to this. First thing we want to do is the control affinity. The control affinity, we want the list title control affinity to be leading. That puts the checkbox in the left instead of on the right. And then we want the title. And we want this to be the, oh gosh, what was it? The pizza order, toppings, keys, element at, and then the index. Remember, the key is the string, so we want the string portion, not the boolean portion. And then from there, we want our value, and this is going to be, and we can just actually grab this whole thing. What? Come on now. Don't be difficult. Alright, so let's hot reload this to see if it works. Yep, as you can see, there is now our toppings, and there's our button. They're grayed out because we don't have the on-change handler. So let's go ahead and wrap that in now. And let's do this. set topping. And in the set topping, we of course need a int index and a bool value, because we want to know the index and the value of that. And we are going to, of course, set state. And in our set state, we are just going to very simply say string key equal get the actual key here, and then we're just going to say set the value of that key. Now we need to wrap this guy into this. So where is it? Right here, onChanged. And onChanged is going to simply be the now it has the index and the value. Let's flip back over. Suddenly they're enabled and we can actually click and unclick things, and it's tracking that in state as we do that. So every time we select or unselect, it's calling this set topping, and it's going through this little function right here. And we can actually scroll through the list and we can set the size. Last but not least, let's actually set the on press to this raise button. And we're just going to say bang bang. And this is going to be a little bit different. What we want to do is we want to do a push. And notice how it has a context and now it wants a route. So we actually have to build the route manually here. So on our route, we're going to say new material page route. And we need a builder here. And I'm going to kind of break this down a little bit. That way we can see what's going on here. The builder, of course, is going to be the build context. And we want a new review, because this is where we're sending it to. Now review, of course, you can see how it just popped up and reminded me order is null. Well, we don't want a null order. We want our pizza order in there. Why is it not doing that? Come on now. There we go. Oh, I know what it's doing. All right, so we are sending our pizza order to it. Let's get rid of that semicolon, or it's going to describe and complain. So really, if you're following along, what we're doing here is we are taking that, and let me rerun the whole app here. We're taking the class, we're creating it, the class being this pizza.dart file, and then we're manipulating it. So no longer do we have variables locally that we're doing. Well, we kind of do. But now we're going to push this off to the review page. And you can see here's the review your order, and it just has your toppings in there. And we can go back, and the state is still perfectly there. So let's say we only want pepperoni and sausage, because that's my favorite. And I'm too skinny to eat a large by myself, so I want a medium. So we have a medium with pepperoni and sausage. So that, in a nutshell, is kind of how that works. Now, some caveats to this is, A, it's not backed up in the cloud. That's a problem. So we will be doing, hopefully, in the near future, Firebase tutorials. Also, there should be a button down here that you would do a HTTP push to Pizza Hut or Little Caesars or Domino's or whatever you order your pizza from, Bob's Pizzas or whatever. Some other things is, the problem with programming, you ever hear the expression, there's more than one way to skin a cat? Kind of a gruesome expression, but there's more than one way to solve a problem. So this may not be necessarily the solution you're looking for. This is just something that I do for simple apps where I just make a class that holds all the settings I need, and I manipulate that as the state and then push that class over in the, where is it? The material page route. I just take that variable, that instance, and just shove it straight over into the other file as part of the constructor here. That way I just get the state, and I don't have to worry about rebuilding it, loading it from a database or anything. It's all in memory. It's all good to go. Pretty simple, pretty easy to use. Now, one thing I did want to go over here. Where is it? Order. Expanded. This is what I was looking for here. I'm going to comma that. Whoops. That didn't work out the way I planned it. Please hold. Alright, so we're just going to take this whole chunk here, and we're going to comment that out. But we're going to grab this list view and put this in here, just so you can see what happens. And you see already this thing right here. That was the first indicator that something went boom. And when you look at it now, this is why you need that expanded, because the list view goes down lower and it puts this ugly thing here. And I, for the life of me, could not figure out how to get rid of that. That's simply why you put it in an expanded. So we're going to just get rid of that. Uncomment this, uncomment that. Put everything right back the way it was, and suddenly, magically, it works again, and we can scroll down, and life is good. So, some key concepts that we've covered in this that I don't think we've covered in other tutorials is how to put an image up here, how to make an expanded, meaning if you try to take that list view and just put it into like a column or something, you need to have an expanded in there. Otherwise, it shows that ugly bar. And how to manipulate the state in another class, basically, or use another class as your state, I should say. And then, just passing that class between them using the material page route. So this is kind of, I would say, not a super elite difficult tutorial, but this is definitely not on the beginner side. So you guys have been wanting kind of a real world example, and I'm hoping this fits the bill. I'm hoping this answers a lot of like organizational questions and how you structure things and how you get images in and how you pass variables back and forth. Whew, that was a lot of talking, and I'm pretty well spent. So for the source code for this and all of the tutorials, visit my website, voidrealms.com. It's out in GitHubs. And join the Void Realms Facebook group. There is 1,800. We just breached the 1,800 mark. 1,800 other programmers out there, all other languages and frameworks. Definitely help you with your problems. And if you're feeling so inclined, like if you're running a business, this site is 100% funded off donations. That's why I do not include advertisements on YouTube. So feel free to donate. That's it. Thank you for watching. Hey everybody, it's Brian, and this is an unofficial tutorial. We are going to cover Flutter. We're going to cover Google sign-in and Flutter authentication with Firebase. However, I'm not going to make like a full-blown tutorial. We're going to actually try to figure out a problem. First off, in case you've been wondering where the heck I've been at, I've been making tutorials out on udemy.com. Definitely check those out. I know it says they're for sale, but if you visit the Void Realms Facebook group, I'm often posting free coupons out there. So if you're a starving college student, message me in the Void Realms Facebook group and I will give you a free coupon. All right, so the crux of the matter here is we want to use Firebase authentication. And let me back up just a smidge. Let's say you don't know what Firebase is. Firebase is a online, always on, real-time database and storage along with messaging and a whole slew of other analytics attached to it. It's from Google. It's actually kind of amazing. One of the reasons why I picked Flutter is because I highly suspect Google is going to take their Firebase product with their Flutter product and kind of marry them together very tightly, which will make Flutter just hands down one of the best mobile platforms out there. I actually kind of think Flutter's kind of leaning in that direction, but I digress. Anyway, so what we have before you is a very basic Firebase console. I literally just opened this up and said, I'm new to Firebase, hit me. And we have before us, it wants to get started. We're going to actually build a Firebase Android application, but we want to use Google Sign-In. So there's some prerequisites to this tutorial. First thing, I've got a blank Firebase. I have done very little, if any, modifications. The only modification I have done is I've gone into authentication and I've gone into sign-in method and I have enabled Google sign-in, and you'll have to follow the directions on the screen. You'll have to have like a project and Some people are kind of weary about showing this information. I don't care because I'm just going to delete all this crap when I'm done. Um, so there's Google, and I also did email and password, but we're going to focus on Google authentication. I know there's also like Facebook and Twitter and all this other stuff, which I'm not going to cover in this video. I may cover at some point. So the other prerequisite is that we are going to do an Android application, not an iOS application, because I'm on Linux and I love Linux. So anyways, let me jump over to Android. The prerequisite here with Android Studio is you have to have the Play Store installed on your emulator. I'm using the Nexus 5 with API 27 with Play Store. That means you're going to have a valid email address, and you're going to have to use a valid Play account and all that stuff, and you'll have to set that all up. I've already got the emulator running, right here. So we're going to give that a shot. Whew. That's a lot of prerequisites so far. The other issue is these two packages don't really work well together. If you go to Firebase Auth and you go into their homepage on GitHub and you go to issues, you see there's some issues going on here. I have been posting a lot of issues because I'm working on the Flutter advanced tutorials on Udemy, and this thing is not working, and it's just straight up pissing me off. So I thought we would just fix this. I went through and did a lot of stuff, and I did figure out how it works. So let's just dive right in and do this. We're going to create a new project, Flutter. I should note you should probably always do Flutter Doctor. I've done it like 4 times today, but so let's call this Flutter Google, because we're going to do a Flutter Google login. And we're going to just hit finish. And it will calculate the trajectory of everything in the known universe. And here we go. First thing I'm going to do is get rid of all this gobbledygook and use the skeleton that I like working with. And then we're just going to run this just to make sure our base application runs out of the box. I should note I'm doing a different video recorder too. I'm using OBS instead of Kazam. So if the video seems a little different, let me know if you like it or hate it. I'm still getting a little used to this recorder. It's got some hotkeys and I keep hitting them accidentally. So, all right. We verified Flutter works, IntelliJ works, our emulator works, our code on the emulator works. Let's dive into actual packages here. Reading Firebase Auth, the first thing you need to do is, well, you got to get the Google sign-in plugin, which we've already got here. This has some steps in it which are a little confusing to folks, and I think it's this in a combination with the setup following here that kind of messes this thing up. So there is a Google sign-in instructions, and if you click that, it just literally takes you to the other page that I have here. So we're just going to jump over here. This is a Flutter plugin for Google sign-in, blah, 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 a bunch of stuff we're not going to read. Let's just go here and grab our dependencies. Let's jump into our pubspec.yaml. God, I hate this thing. I don't know why that just won't die a slow death. All right, so let's go into pubspec.yaml, grab that, add that in there, save it, do a packages git. Might as well just kill that on the emulator. Now, we're not done. This is where things get a little confusing. We've got some extra work to do. We need to actually go to the README file and read some stuff. iOS has some configuration stuff. It's got some usage. And what it's saying for Android is that you have to register your application. What does that really mean? What does that really entail? So let's look at this. Of course, it takes us to Firebase, which is where I started down that whole route. So let's jump into Firebase. First thing it wants to do is say, hey, let's do something. So I'm going to add an Android application, and it wants us to register the app. So it needs a package name, a nickname, and debug signing with SHA-1. And let's just dive in here. So package name, it wants to get that out of the app level build Gradle file. So let's go in here, bang, bang. Notice how there's 2 build Gradles. That gets confusing. This is the project build Gradle. This is the app because it's in the app folder. We're going to crack that bad boy open, and we want the application ID, this guy right here. com.example.flutter Google. Let's jump back to Firebase, and we're just going to paste that in there. We want a nickname. We're just going to name it that right there. This part will just straight out piss you off. Debug signing certificate. It's actually required for this tutorial. How do you get it? If you do this and you right click and open a new tab and see this page, you need something called the key tool. And it even gives you a nifty little blurb here. And you're going to get what's called a SHA-1 or SHA, SHA-1 fingerprint. So let's just crank open our terminal. Make sure you have key tool installed. If you don't, you don't have Java installed. So that was my first issue because this was a brand new Linux installation. I completely blew away my desktop and none of this stuff existed. So make sure you have key tool installed, otherwise do a Java version. And you should see you have a Java version. Paste in what they tell you to and boom, you get an error message. So we have to fix this. It's saying you can't do multiple commands at once. After some exhaustive creative Googling, I found out you can just simply delete that little bit about export cert and it wants a password. Boom. There is our fingerprints. Notice it's giving us a SHA-1 and a SHA-256. We want the SHA-1. So let's just grab that. Copy that bad boy. Go back in here and paste it in. In case you're a wannabe hacker, no, there's no secret sauce to that. It's just the key tool on my local box, which I'm going to generate a new key tool after this video, so have fun using it. I don't care. Now, register the app. This is where things actually get kind of interesting. So we click register, and it wants us to download this JSON file. Why do I say JSON? JSON file. That's the Canadian in me. JSON. It's like saying foot instead of foot. You Canadians know what I'm talking about, but I'm actually American. My family's from Canada. So let's download this JSON file. I know I'm going to get hate mail. Everybody in Canada is going to be like, we don't say JSON, we say JSON. Anyways, show in folder. We're going to grab this and just copy it. In case you're really morbidly curious and want to know what's in there, we can take a quick peek, but we need to put it in a specific location. Notice how we go into the app folder. And this is the confusing bit because this is not a Flutter. That's an Android project, so you'll see a lot of stuff missing there. Let's go in here. We're in our Android folder. We want to go into app, and we want to paste this. It's going to say, are you sure? You're going to say yes. And here's the JSON file in all its glory. This is specific to your application and your Firebase installation. Every application will have their own little JSON file. That's what I love about Android versus iOS development for this, is because it streamlines all of this. You don't have to put any of this nonsense in. It just generates a file and you're good to go. Now, boom. This is the confusing part. We have to add some stuff to our Gradle. All right, so add the Firebase SDK. We're just going to click that. And this says do it in the project build Gradle. So we'll go in here. We'll go into our build on the project side of things. Probably want to expand that out for this. And we're just going to add in our dependencies. Give that a good save. Flip back into here. Now we need to go into the app level build Gradle, so we're going to copy that. And I've got too many windows open. Back up to here. And it's at the very bottom. Bang. Just going to compile Firebase core. Then we need to apply a plugin of the Google services, the GMS. Copy that. And it says just add it in the bottom, so we'll do that. It's going to apply the plugin. That part is pretty simple. Next, we need to run the app and verify the installation. Notice how it says checking to see if the app's communicated with the server. So we're going to actually build this bad boy, save our work, run it out on the emulator, and we're just going to pull this emulator up. Maybe, if I can find it. I've got too many windows open. Bear with me, bear with me. There it is. This part takes a little bit, and you'll notice when it does eventually come up that it even takes a few seconds longer after the application comes up. Let me actually flip back over here because it's still building. Okay, so the app's up, and it's still thinking. So our app's running, and it's still doing stuff on the back end with Firebase. Now I think this is just pure latency on Firebase's side. There's some verification checks going on, making sure the app was actually valid, and then the database stores it internally, it replicates out, and then it updates Ajax to the web page. So we're just going to sit here until this thing 100% says it is working. There we go. Congratulations. You've successfully added your app to the Firebase. So we're going to hit continue. All right. So far, that was pretty painless. We have Google sign in. And if we wanted to, we could actually go in here, go to this example, paste this code in, and ta-da, it would just work. However, we don't want just Google sign in. We want Firebase authentication. There's a difference here. Google sign in allows you to sign in using Google services. Google services are different than Firebase. When you look at Firebase, where's my Firebase? There it is. And you look at authentication, you should see user identifications in here. That's separate. You can use Google sign-in without using Firebase. So what this does is it adds a layer. When I say this, I mean this guy right here. Adds a layer on top of Google sign-in that allows you to use it through Firebase. You can do the same thing with Twitter, Facebook, and all this other stuff. It uses their underlying channels to communicate and to authenticate, and then it just simply updates the Firebase database. This is also where we start getting into trouble. So we're going to grab this, and let's go to our pubspec YAML, throw this out here, bang, do a good packages git. Might actually want to stop that. And of course we are not done with the installation. So let's just throw this import out here just so our program knows we're using it even though we're not using it yet. And go back to our README file. So it says configure the Google sign-in, which we've already done. Import the plugin, which we did. Now we need to actually add some dependencies here in our project level build Gradle. So let's just grab these. Go to our project level build Gradle. Here's our dependencies. And we're just going to paste those in. Right about now, somebody is screaming at their monitor to comment out or delete these. We're just going to leave it for now and let the program figure out what it needs. Save that. And notice at the bottom of the app level, we're going to apply this plugin. We've already done that, so just for verification that it's the same darn thing, we're going to just comment this out. You can see it's the com Google GMS Google Services plugin, so we don't want to do that twice. This is why, and let me just Flutter auth Google sign in. There we go. This is where I started getting into trouble here when I was doing the Flutter advanced tutorial. This is where things just deteriorated. If we save this and just try to give this a good build and run, it completely died on me. Yep, see, blah. It says minimum supported Gradle versions 4.4, current versions 4.1. Luckily for us, it gives us how to fix this bad boy. So let's go in here, and it says go into this specific file, Android Gradle wrapper Gradle properties .244 all. This is the confusing bit. If you're in the actual editor and you want to go into Android Gradle, you see there's no wrapper folder, and you're like, where'd it go? So let's bring up this. Go to code, Flutter. What are we in? Flutter Google, Android Gradle. Suddenly there's a wrapper folder. So the IDE tricks us and hides it from us. Shame on you, IDE. Let's go ahead and open this up in a text editor. And you can see here is the offending line, Gradle 4.1, and it's requiring 4.4. So we're going to say 4.4 all, save that. Now run this again. And if I remember correctly, we get an entirely different error message, which just will infuriate you, and you'll pick up your keyboard and chuck it across the room, or just ninja punch it. Yeah, okay, here we go. So let's expand this out. What went wrong? Failed to notify dependency resolution listener. Huh? English, what does that mean? The library, blah, 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 play services, you remember that guy we did in the end of our file there, is being requested by various other libraries at this level here, 1504, 1504, but resolves to 1502. I Googled the heck out of that and could not figure out how to upgrade that. Turns out you don't really need to. So let's play around with this bad boy here. Let's go here, and let's go to the very end here. I actually did post it. So we're going to look at our dependencies here, and we're going to look at that GMS services 4.0 right here. Simply commenting out this fixes the issue. How did I find that out? Dumb luck. I just started commenting out things to see where it started working. So let's bring up our emulator here, and we are going to just run this bad boy just to see if we can get a solid build out of this. And this may take a second because it's pulling all that stuff in and compiling it. My chair's getting squeaky. That's going to get annoying. We got some notes. We're just going to ignore that. And should install the APK, which means it built, and boom, there's our program. So let's actually get Google sign-in working. Okay, let's go here, and I'm going to cheat, and I'm just going to do the example. I don't like doing this because you have to really pick apart somebody else's coding style and figure out what the heck's going on, but I just want to make sure this thing works. So we're going to completely blow away my code, save this. Hot reload's going to, of course, die, and we're just going to restart this whole thing from scratch and see if it works. What we should have when this thing is done is a nice interface that allows us to do Google sign in through Firebase and still update the Firebase backend. All right, so we're going to test sign in with Google. And it says choose an account, voidrum05, that's my dummy account. Don't ever email me because I'll never answer you. And we've successfully signed in. Boom, sign in with Google succeeded. Let's check our Firebase backend and see what it actually looks like here. And this is the part that's got me a little dumbfounded. It doesn't actually show. Oh, there it is. Yep, voidrum05@gmail. So now we have our user ID on our Firebase backend with our Google provider, and everything is working as expected. And we can copy the UID and all that stuff. So I'm sorry there wasn't a whole lot of typing in here, but this has actually taken me about a week to really figure out why none of this crap was working. And I've been going back and forth on the GitHub page trying to figure it out. So that is how everything works. So if you've at this point and you're really stuck, the big thing to really take away here is, whoopsie, where did I do it? Where did I do it? I just screwed that all up, didn't I? Yeah, I'm in the wrong file, aren't I? Boom, here it is. In the project level build Gradle, just comment out that services 4.0. Make sure you're doing the Gradle 4.4 all in the specific Gradle wrapper properties file, and then it should just work, assuming you have set up the project correctly. The other big takeaway from this is if you skip that step with your application setup and you didn't put in a SHA-1 because you didn't want to screw around with key tool or any of that, this will not work. You need that SHA-1 in your application. That's it. Thank you guys for watching. Thank you for being very patient with me as I'm still grinding away with videos. I know I haven't posted anything in Void Realms in a while, so I wanted to throw this out here first. This is going to be part of a larger thing in the Udemy tutorials I'm going to make. I should say I'm in the process of making Flutter Advanced. There's going to be 6 sections, and I'm on section 5 right now, which is Intro to Firebase, which is going to cover a lot of what we just talked about. And then section 6 is going to be like Firebase storage, Firebase real-time database, how to get information up in there and back and forth. So thank you guys for watching, and I'll talk to you later.